In this course, you learned a lot about React. You learned about all those core features that make up React, and you are able to build your own React apps if you went through that course. But in this entire course, we used React with JavaScript, with the JavaScript programming language. Because React is a JavaScript library, and most examples and demos and the official documentation which you find out there is about React with JavaScript. But you actually can also use React with TypeScript, and that's what this course section is about. Now for that, I'll first of all explain what exactly TypeScript is and why we might want to use it. Good news is that it's not a totally new programming language. Instead, it builds up on JavaScript. Then I'll walk you through some TypeScript fundamentals, some important basics which you need to know about TypeScript in order to use it. And then, of course, most importantly in this section, I will show you how you can use TypeScript in combination with React, how you can write your React code with TypeScript. So what is TypeScript and why would you use it? TypeScript is a so-called superset to JavaScript. It's a programming language which builds up on JavaScript. It extends JavaScript, you could say. And that is really important. The core programming language still is JavaScript. So the base JavaScript syntax, you know, how you write JavaScript code, if statements, for loops, objects, all that does not change. But TypeScript then adds more features to the JavaScript syntax. And that's also important. Unlike React, TypeScript is not a library for JavaScript, so it doesn't use JavaScript features to build new features on top of them, to build functionalities around them, but instead it extends the core JavaScript syntax. And most importantly, it adds static typing to JavaScript. And that's also where the name comes from, TypeScript. It adds static typing to JavaScript because JavaScript on its own is actually dynamically typed. And what does this mean and why is this useful? For this, I prepared a very simple example here, which you find attached. This is not a React app. This is a standard JavaScript function and a standard HTML file which has no actual content, but which imports this script file. Now, if I open this file in the browser, simply by copying the path here and then opening that path in the browser, if I reload this page and open the developer tools, I see 7 here in the developer tools in the JavaScript console. And I see 7 here because in this script file, I define an add function, and then I call this add function and store the result in this constant, and then I log this constant. So that's standard JavaScript, nothing fancy here. Now, JavaScript has types. JavaScript knows the concept of types. For example, here, the 2 values which I'm passing in are of type number. And that's something JavaScript knows on its own without TypeScript. The important thing just is that JavaScript, as I just mentioned, is dynamically typed, which means that this function here does not expect any particular types. It just knows that it will receive 2 parameters, and that's it. So it's not statically typed. The types for this function are not announced ahead of time. Instead, it just takes whatever it gets and then tries to execute this code. And that code happens to work with numbers. But this code also happens to work with strings. And hence, if I convert my 2 numbers into strings here by wrapping them with quotes, then I got 2 different types here. I got 2 strings instead of numbers, which are types JavaScript knows. And if I change it like this and save this file, if I reload, you see now we get 25 here. Because now the plus operator does not add these two arguments in a mathematical way, but instead it concatenates two strings because it receives two strings here. And that shows why just JavaScript is okay and great, but why it might not always be best. Why having static typing could enhance your code and prevent errors like this. Now, of course, you might say, which error? I can simply not call add like this. I just make sure that I always pass in two numbers and I won't face this problem. And that's true, but in a bigger project with lots of code files and potentially a lot of people working on the code base, you might sometimes call a function or use some object in an unintended way. And then you could run into problems like this because nothing is warning you that this is not how you should use this function. Nothing is telling you that this function actually wants two numbers instead of two strings or any values. And that's where TypeScript can help us. Because with TypeScript, and I'll show you this code even though we haven't installed TypeScript yet, but I have it installed on my system already, and we will install it together in the next lecture too. But let me show you this first. So with TypeScript, if I copy this code, what we will be able to do is we can add type annotations here, simply by adding a colon after our parameter, and then adding the type which should be used for this parameter. And I'll do this for B as well. And we'll also not just be able to use type annotations on function parameters, but as you will see throughout this module, we can use types in many other situations as well. So now I'm making it clear with TypeScript that here I actually want two parameters which both should be of type number. And hence, I already get an error here in my IDE, which tells me that this argument of type string is not assignable to a parameter of type number. Pretty helpful. And with that, I can catch such an error, such an unintended use of this function before I run and test my code. And that, of course, allows us to write better code in the end because we can avoid such errors and we don't have to track them at runtime, but we see such errors right when we start writing code. And that's why using TypeScript could be worth a thought. So now that we know what TypeScript is, that we can add types to our programs with it, and how the syntax generally looks like, let's make sure we can all use TypeScript. And therefore, if you search for TypeScript, you can visit typescriptlang.org, and that's the official TypeScript webpage, where you can learn more about TypeScript and where you can also learn how to install TypeScript. As a side note, if you want to learn way more about TypeScript, I also do have a complete TypeScript course where I dive deeply into TypeScript. In this module, I'll just cover some basics. So if you want to learn more, my full course might be interesting to you as well, or the official docs, of course, in addition. So now to install it locally, we can click here on install locally. And now we basically need to run this command here. Now for that, we need to make sure that Node.js is installed, but we needed this for this course and for using React anyways, and therefore that should already be installed. So therefore we can now run this command to install TypeScript. And running this command will install TypeScript into a specific project. If you want to install it globally on your system, then you need to run npm install -g TypeScript. But often installing it just into one specific project is enough so that you can then use TypeScript in that project into which you install it. And therefore, that's what I'll do here now. I will open my terminal, which is integrated here into this project, and run npm install TypeScript. And actually for this, I'll first of all run npm init -y to create a empty package.json file. because we'll need that to install dependencies, and then I'll run npm install TypeScript. And this will now install TypeScript into this project. Please note, this is still no React project. This is still just a standard web project. We'll move towards our React project a little bit later. So now TypeScript is installed. With that installed, we can now invoke the TypeScript compiler. And that is really important. As you learned, TypeScript is a superset to JavaScript, extending the JavaScript syntax with those extra types. Now, the important thing to note is that TypeScript code does not run in the browser, though. So if you try to execute TypeScript in the browser, it will fail. Therefore, we need to compile TypeScript to JavaScript. And during that compilation process, all our type annotations will be removed, because JavaScript doesn't know those annotations. But it's during this compilation step where we will be notified about errors, in addition to the notification we get in the IDE already. So it's this compilation step which then will warn us of potential code problems if we haven't spotted them in the IDE before. And then it's that compiled code which will run in the browser. Now, to invoke this compiler, we need to run this command here, npx tsc. So now if I run npx tsc like this, you'll see that I get an error though. I get this error because if I run this command just like this, then it expects a TypeScript configuration file in that project folder that tells TypeScript which files to compile. Now we'll add such a configuration file later. For the moment, we can run this command slightly modified. We can point at a file that should be compiled. In this case, with TypeScript.ts. So if I run npx tsc with TypeScript.ts, then this file is getting compiled. And hence now here I get one compilation error, the same error my IDE warned me about before. So if I haven't spotted it in the IDE, now I get an error here. Now you will notice that a no TypeScript.js file was created nonetheless. That simply happens because by default, even if you get an error during the compilation, it still completes. It just warns you because of that error, but it still gives you a JavaScript file. And this JavaScript file, sorry, this one here, is now based on our TypeScript file. And you see it's almost the same code, just without the types. And actually it changed const to var because by default right now it still also compiles the code such that it runs in older browsers as well. That is something which can be overwritten with the TypeScript config file, but we don't have such a config file yet, and therefore we have this code change as well. But of course you see that other than that, it's the same code as we wrote in the TypeScript file. Now, of course, we should get rid of that error though, otherwise using TypeScript doesn't make any sense, and hence I'll convert my two strings here to numbers, and if I save this now, the error is gone in the IDE, and if I now compile again, this also compiles without errors, and we still have the same JavaScript output as before. But now it's this JavaScript file which we could import here and use here. If I now save this and then reload this page, I get 7 again. But now, if we continue working in the TypeScript file and then compile it to run in the browser, now we actually protect ourselves against errors like we had it before, thanks to TypeScript. And now with that installed, and now that we understand what this compiler does and how this generally works, let's dive into some core features you need to know when working with TypeScript before we then thereafter see how we can use TypeScript with React. Now, let's dig deeper into TypeScript. And for this, I'll add a new basics.ts file in which we'll dive into some core basics you need to know about TypeScript. And for that, I want to start with the basic types you can work with in TypeScript, which you will need all the time. And that will be our primitives, which we know from JavaScript, numbers, strings, and booleans. And then, of course, we also have more complex types like arrays or objects, for example. And then thereafter, we'll also talk about function types, parameters, and much more. So that's generally what I want to talk about here. And let's start with the primitives here. The primitive values we have in JavaScript are numbers, strings, booleans, and also null and undefined, and also symbols, but we can ignore that. And number, string, and boolean, as well as null and undefined, are the important ones therefore. Now, if we have a variable, let's say the age of a user, and we want to make it clear that in there we want to have a number, we can make that clarification with TypeScript by adding a colon after the variable name, and then simply specifying the type of value that should be stored in this variable. And then we can finish this variable declaration here. If I then later assign a value, assigning a number is okay, including floats, so numbers with a decimal place, but assigning a string would give me an error. That's what we saw before with that function and its parameters as well. Now, of course, we can also assign a value here right away. We don't have to have this declaration without a value assignment. Both is allowed. Now, we also can, of course, have a username, which should be a string, and for that, we can assign a type like this. String is the type we want to use here. And one important note here, in TypeScript, it's number and string written like this with lowercase starting characters. It's not number like this. We don't get an error if we use that, but this actually points at the number object in JavaScript. We want the number primitive type, which starts with a lowercase n. The same for string. We want the primitive type, which starts with a lowercase s. And then, of course, here we can assign a value. And we can also, of course, store Boolean values like is instructor and add Boolean as a type assignment so that thereafter I may store true or false in that variable. And these are our core primitive value types, which we can assign, in this case, to variables. Before, we also saw how we set types for function parameters. And we'll see more places where we can set types in the next minutes. Now, as I mentioned, we also have null and undefined as types, but we don't typically set something to be null. If I set hobbies to null here, then this would be possible. But then whenever I try to assign anything, I get an error, which of course is not too useful. Instead, we'll use null and undefined in a slightly different way, which we'll learn about in a couple of minutes. So numbers, strings, and booleans are the core primitive value types we should be aware of. Now let's talk about the more complex types, so arrays and objects here. And let's start with arrays. If I have my hobbies, that might be an array of strings. Hence, this type assignment is wrong. This allows me to store a single string in hobbies, but I want to have an array of strings. To tell TypeScript that I want an array of strings in there, we can instead assign this type, string with square brackets thereafter. This tells TypeScript that we want to have an array of strings in hobbies. And of course, we could have the same with an array of numbers, an array of booleans, whatever. But here I want to have an array of strings, and that allows me to store an array of strings in there, like this. Now this is possible. If I would add a number in addition to the strings, I again would get an error, because that's not a string, and I'm making it very clear that only an array of strings may be stored in hobbies. So that's how we can set up array types. Now we also can set types for entire objects. Let's say I have a person variable, and in there I don't want to store a name or an age, but an object. I want to be able to store something like this, an object with a name and an age, something like that. That should be stored in person. Now, of course, this works like that because TypeScript out of the box without configuration is quite forgiving, and it by default allows me to store any value in a variable. It has a special any type for this, which we can see if we hover over person. The default type assumed is the any type, which we can also explicitly set like this, which simply tells TypeScript, I don't want to tell you anything about the types of values stored in this variable. Anything is allowed. And that, of course, is a fallback type, which you typically should not use, because that kind of defeats the entire purpose of using TypeScript in the first place. With the any type, you're basically back to standard JavaScript. So it's the default, but of course, it's not what I want to keep here. Instead, I want to make it very clear which kind of object can be stored in person. I want to allow this object, for example, but storing another object with a different structure, where I have, let's say, just a Boolean in there, that's something I don't want to allow. And for this, we can again add a type assignment, but now we want to add an object type, a type defining an object. And for this, we then add curly braces, just as we do it when we create an object. But please note that this is not on the right side of an equal sign here. So we're not creating an object here. Instead here, it's in the place where we set a type for a variable on the right side of this colon after the variable name. And therefore, this here is actually a type assignment. And hence here, we're not creating an object, but instead we're using a TypeScript feature here, which is the object type definition. So we're defining the type for an object. We're defining the structure of an object. And here we can then, for example, say that person should store objects that have a name field where the value of that name field is a string, and which have an age field where the value is number. So where the value is of type number, I should say. And with that, we're telling TypeScript that only objects that have this kind of type should be storable in that variable. That's why I can store this object here, because that object down there has exactly the structure I'm defining here. It has a name field, which has a string as a value, and the age field, which has a number as a value. On the other hand, this object down here is not storable, and hence I'm getting an error here because it is having the wrong type. This object's type would be that it has an isEmployee field, which stores a value of type Boolean, which does not match this type description here. So I'll comment this out. And that's how we can define array types and object types. Of course, we could also combine these two. If I wanted to have an array full of people, so full of people that have this type signature here, then I could set the type of people here to this object type. So I'm repeating this, but as an array by adding square brackets thereafter. Now I'm saying in people, I don't want to store a single object of that structure, but an array of such objects. And that's how we can then already get a bit more advanced by combining different TypeScript features and by combining different types. Now that we learned about those base types, before I'll dive into functions and parameters, I want to talk about type inference. In all those examples which are listed here, I always declared a variable with a type assigned, and then in a second step, I set a value. Now, often in programming, you do that in one step. You create a variable, and you then also immediately assign an initial value. So therefore here, let's talk about type inference. And let me show you what that is. Let's say we have another variable down there, the course variable, and in that course variable, I want to store the name of a course, like React the Complete Guide, like this. Now, if I create this variable like this, and thereafter I try to store a number, for example, the course ID, then you will see that I get an error, because the type number is not assignable to type string. But why am I getting this error? After all, I don't define a type anywhere. Well, here TypeScript used its powerful feature of type inference. By default, TypeScript tries to infer as many types as possible. So it tries to know which types are used where without you explicitly stating those types, which means that you need to write less code. I could also set my type here, as we learned it. That would not be wrong, but it's redundant. Because if you immediately initialize this variable with a type, TypeScript will look at the value type here, so it will see that we stored a string in that variable, and it will then use that value type as an inferred type for this variable. And if you then try to assign a different type thereafter, you'll get an error because of type inference. And it is considered a good practice and a good idea to embrace that type inference feature, so to not unnecessarily specify the type in addition. You can do that, you can explicitly state the type, but it's really redundant. It just means more work from your side, and therefore you should not do that. You should instead stick to that type inference and use it whenever possible. And that's another super important feature which I wanted to highlight here. Now, type inference is great, and in general, up to this point, we already learned quite a bit about TypeScript and its core types. But up to this point, we also always had the scenario that every variable took just one type. So we always had just one possible type that could be stored in a variable. Just a number, or just a string, or just a boolean. And often, that is what you need. But sometimes you want to allow multiple different types. Let's say here for the course. We might be fine with storing a string in there, but maybe storing a course ID as a number should also be correct. It really depends on what you're building. It's not unrealistic that we could have a variable where both a string as well as a number should be allowed. Or that you have some variable which should allow two different kinds of objects. And for this scenario, that you have more than one type which you want to allow, you have a feature called union types. A union type is a type definition that allows more than one type. You add it like any other type assignment by adding a colon after the variable name on the left side of the equal sign, and then your type. Now, I mentioned that explicitly setting string again here would be redundant. But it's not redundant if you don't want to use the type inference here, but if you instead want to specify such a union type, hence allowing multiple types. You set up such a union type by adding a pipe symbol after your first type, and then adding another type, like number. And you can have as many types which you want to allow here as needed. But here I just want to have string or number. And now you see that that error which we had down here before is gone, because now we are allowing a number alternatively to a string value. And of course you can use such a union type anywhere where you have a type assignment, not just when you're using type inference. I could also use a union type up here, allowing username to be a string or let's say an array of strings, for example, so that we have first and last name in an array, for example. That's also something I could allow here. Union types are another key TypeScript feature which allows you to define more flexible values and types. Now, the more TypeScript code you're going to write, the higher the chances that at some point you might be repeating some type definition. And we're actually already doing this here. Here, for people, I'm saying that I want an array of this kind of object. So that I want an array full of objects that have this structure. And that's the same object I have up here for person. The same type definition, just in the non-array form. But the object type is the same. Now you can, of course, duplicate the type definition, but it's more realistic that you want to avoid that duplication. And for that, you can create a so-called type alias. You can define your own base type, in which a more complex type definition is stored, and then use that type alias instead of repeating the entire type definitions. For that here, for example, before we use this object type for the first time here, we can define such a type alias with the type keyword. And that's a keyword which does not exist in standard JavaScript, but which is added by TypeScript instead. Now, after this type keyword, you use any name of your choice, which will be your new type name. For example, person, like this. And then after the equal sign here, you then have a type definition, because this is a pure TypeScript feature. This will basically be thrown out of the window when the code is compiled to JavaScript. So here on the right side of the equal sign, it's not a JavaScript value, but instead a type definition. And that could be our object type definition here, which I now store here in this person type. And now in all those places where I used this object type, I can use my alias instead now. And it's therefore still the same type, but I only define it once, and then I can repeat it in all the places where I need it. And I can still also change it like I'm doing it down here to use it just as person like this, or to use it as an array full of persons. That also works. And that's the very important feature of type aliases, which can save you a lot of typing work and which can therefore make your code more concise and easier to maintain. Now, there are a lot of other core TypeScript features which I do explore in greater detail in my TypeScript course. To come to an end here for this introduction, so that we can move to our React example and see how we connect TypeScript with React, there are just two last features which I want to cover here. And that would be functions combined with types, and then thereafter generic types. Let's start with functions and types. And I'm saying function and types because when we work with functions, there are different places where types can be assigned. Let's start by adding a function here. Let's say the add function again, which we saw before. The add function can get parameters, of course, like any function, just as I did it before. And then for these parameters, we can assign types. That's what we saw before here in this first example. Just as we can set types for variables, we can also set types for parameters. We can make it clear that here we want to allow numbers, for example. And then I can return a plus b. But with that, we also have one inferred type here in this function. And do you see where we're using type inference here? Well, here in this function, I am returning a value, and that tells TypeScript something about the return type, the type of the returned value of this function, and it infers this type. We can see the type it infers if we hover over add. Then we see the TypeScript definition of this function, and we see that, of course, for the parameters, we have the two types we set up, the number types. But then here, after this function name and the parameter list, this colon here and this type here, that's not coming from us. We haven't added this code. Instead, that's the inferred return value type TypeScript infers here. So TypeScript knows that here it will get a number as a return value because it sees that this code with these parameters, which are always of type number, can only return a number. There's no other value that could be returned. And that's why this number return value is inferred. We could also explicitly set it though. We can set the return type of a function by adding a colon after this function parameter list and then setting the return type here, like number or string or a union type. That would also be possible. That's something we can do. But just as before, if you don't have a reason for doing that, you shouldn't do that. TypeScript already infers a type here, and if that's the type you want to stick to, then there's no need to explicitly define it yourself. Still, I want to mention this, that functions, when we work with types, don't just use types for the parameters, but also for the return value. That's easy to overlook, but it makes a lot of sense, because a function, after all, does not have just some input, it also has some output, and hence it has a return type. Now, there is a special return type, which is also worth knowing. And for that, let me add a print function where I get a value, and that could indeed be of type any, because the only thing I'll do with that value is I'll console log it. So I don't really care about the concrete type of this value, I'm just logging it. Now, one important note about naming this function print though, which I unfortunately only discovered after I named the function like this. Of course, in JavaScript there is a built-in print function already, so now this function will clash with this built-in function, and hence if you would try to compile this TypeScript file, you would be getting an error because of that, so maybe just name it print output or something like that to avoid that error. But the important thing about this print function now is that this function does not return anything. It has no return statement. And therefore it has a special return type called void. Void is basically comparable to null and undefined, but it's only used in conjunction with functions, and it means that this function never returns. So if I want to work with the returned value from that function, I will work with undefined. And that's that special void type for functions, for the return value of functions. Now we'll of course work a lot with functions once we start working with React and TypeScript, and therefore we'll then see all those function types in action there. I want to conclude this basic introduction to TypeScript with a slightly more advanced yet very important TypeScript feature, and that would be generics. Now this can be tricky to wrap your head around, but I'll try my best to explain it such that it makes sense. Let's say we have a function here, which I'll name insert at beginning, and this function takes an array and a value as parameters, and the array should be an array full of any kinds of values, and the value should be any kind of value, because I don't care in this function if it's an array full of numbers or strings or of person objects. Whatever it is, what I want to do in this function is I want to create a new array, for example by using the spread operator and copying the existing array. That's a standard modern JavaScript feature, also supported by TypeScript. And then in front of that old array, I want to insert the value. And then I want to return this new array here. That could be a utility helper function which we create to have a function which we can easily call to add a value in an array without changing the existing array. So the advantage of this function could be that the original array never changes, but instead we're getting a brand new array. Now for this, I could of course have a demo array with, let's say, 3 values. And then I get my updated array, where I call insert at beginning and I pass in the demo array and then a value of -1, let's say. With that, I know that the updated array will be this array with -1 inserted at the beginning. So this will give me -1, 1, 2, 3. And hence, thereafter, I might want to do things with that array, which I can do with an array full of numbers. But the problem is that updated array, if I hover over it, is inferred to be of type any array. So an array full of any kind of values. TypeScript here doesn't pick up that it's an array full of numbers. Why? Because here I have any as a type. And I can't say that I only want to allow numbers here, because what if I want to use this utility function with an array full of strings? So we need any, but at the same time, that kind of removes all kind of TypeScript support we might be getting after calling this function. We're not getting any good TypeScript support for updated array thereafter, because that is inferred to be an array full of any kind of objects or any kind of values. And that's not useful. If I then, for example, try to access the first element and call split here, which I could call on a string, I don't get an error here. I would get a runtime error instead, because I can't call split on a number. But again, TypeScript doesn't know that the first value in updated array is a number. We know it as a developer, but because of our type definitions here, which we need, TypeScript doesn't know it. And to work around such problems, we have this feature of generics. And that's why I had this lengthy introduction here, because it is important to understand why this feature exists. With this generics feature, we can convert this function to a generic function. For this, we use a special syntax here. After the function name, in front of the parameter list, we add angle brackets. And that's now not a standard JavaScript feature, but really only a feature we can use here since we're using TypeScript. And in here, we can define a generic type, which will only be available inside of this function. Typically, that's called T for type, but any identifier of your choice is okay. Now you can use this type in your function, including the parameter list. And here I'm saying, I want to use this for my array. So my array will be full of t's and my value. This should also be of type t. But how does this help us? Well, like this, it of course is just very cryptic. But now when we call this function, now TypeScript actually is able to understand that it should look at the concrete values of the arguments here. And it understands that this is an array of numbers and this is just a number, and therefore it understands that updated array will be an array of numbers. Because of this generic type feature, because we're telling TypeScript that the type here is actually not any type. It's not any kind of value. Instead, we tell it that the type of this array and of this value should be the same. Just that this is an array, but it's an array full of the same types of values as this single value has it. And that's an important piece of information. Therefore, TypeScript is able to look at the type of demo array, which it knows. It knows that this is an array of numbers. It's able to infer this. And it looks at this type. And then it knows that logically, the array which gets constructed here has to be of the same type as the input array. It's able to infer this here. And hence, it's able to infer that what we get back here has to be an array of numbers. And if I would call insert at the beginning here with an array of strings, like this, and I then pass in a string here, and I have my string array here, TypeScript is also able to infer this correctly. Because again, it looks at this type, and it knows that the return type is of the same value as this type, as the input array, and hence it again infers this correctly. And therefore, for the updated array here, where it knows that it has to be an array full of numbers, it's now able to warn me when I try to call split. it tells me that this does not exist on type number. So that's this important feature of generics. It simply helps you write functions, in this case, which are type safe yet flexible. They are flexible, they work with any type, but then once a certain type is used, for that function execution, that type is locked in and known. And that allows you to get the best of both worlds, flexibility and type safety. Again, I am fully aware that this generics feature can still be tricky to wrap your head around, but we'll also see it in action soon when we start working with React and TypeScript, and then, combined with what you learned here, it should become clearer and clearer how it works and why it's important. And speaking of that, let's now leave this basics file and this non-React project, and let's instead move towards a React project which is using TypeScript. Now that we covered these basics of TypeScript, it's time to actually dive into React and TypeScript. And for this, we need to create a new React project where we get this development server and this build process, which we can run if we want to deploy our application. But we need a React project that is configured to use TypeScript instead of vanilla JavaScript, which is the kind of React project we used up to this point in this course. Now, the great thing is that we can still use Create React App for that. If you search for Create React App, you should find the Create React App docs here on createreactapp.dev. And on this page, you find instructions on how to use Create React App, and there you will also find instructions on how to integrate TypeScript. For that, if you click on Building Your App here, you find the Adding TypeScript document. Now, this general page structure can, of course, change over time, so the way you find those instructions might change, but you can also Google for Create React App TypeScript, and that should then directly lead you to that Adding TypeScript documentation you're looking for. And here you can learn how you can add TypeScript to a React project that is using Create React App. And it's of course easiest if you simply start a new project with TypeScript integration. Though you also get instructions on how you can add TypeScript to an existing project. Now, we will simply create a new project here though, and therefore I will just grab that command here, npx create react app, then my project name, my app name, and then this important --template flag, which we add on this command, and which we then set to TypeScript as a value. And that will use a special template for creating this project, which gives us a project configured for TypeScript. So if we grab that, we can run this command. And here what I'll do is I'll open a terminal in my project here, and I'll run this command, but I'll rename this to React-TS, this project name, and then hit enter, and this will now create this new project, this React TypeScript project in my existing folder here. Now let's wait for that to finish, and then we'll continue. Now here it did finish, and with that I got this new React.TS subfolder. And what I'll do now is I'll create another folder in my overall project, which I'll name TS Basics. Basics. And then I'll just move that old configuration into that TS Basics folder here. So those files on which we worked in the previous lectures. And I'll delete that Node Modules folder there. And now we have these two folders side by side, and it's of course the React.TS folder in which we'll work now. And for this here, I'll first of all cd into this React.TS folder, and then with npm start we can still bring up that development server, just as we do it throughout the entire rest of this course. But now, here, we actually got a React project configured for TypeScript. If you visit localhost 3000, you should still see that starting page, this default app we get here out of the box. But if you have a look at that source folder, then you will notice that instead of .js files, we have .tsx files in there. And that indicates that we're using TypeScript, and it's .tsx instead of just .ts because we're using this JSX syntax in there. And if you are doing that to avoid unnecessary complaints by your IDE, you should be using .tsx as an extension if you're using JSX in those files. And other than that, it's basically just the same code we saw before in this course. There's really nothing special about that. Now, one important word about that dev server, which we started here again, this works as we're used to, but of course, keep in mind that it's now doing one more thing behind the scenes. It's actually compiling our TypeScript code to JavaScript code, which then is taken and optimized further. Before, with just React and vanilla JavaScript, we just had this dev server which takes our JavaScript code, bundles all the files together, and provides certain optimization steps. Now we still have all of that, but in addition, we have that extra TypeScript to JavaScript compilation step, which also takes place behind the scenes. So we don't need to convert our TypeScript files manually to JavaScript here. We don't need to compile them manually or call the compiler manually. That happens behind the scenes. It would also happen automatically if you build your code for production by running npm run build. That's just a little side note, which I wanted to add here. Now, before we dive into that code and clean it up a bit, I want to talk about our dependencies in the package.json file though. In there, we generally got the same dependencies as before, React and React DOM and React scripts, but we also see a couple of extra dependencies. Specifically, we find TypeScript in there and also these types dependencies. Now, TypeScript, of course, is the language, the compiler for TypeScript, which is installed into this project so that we can use TypeScript in this project. That's also what we had in this TS basics part we worked on in the last lectures. There we also installed TypeScript. But we now also have these extra types packages, and these are important packages. These add types packages act as translation bridges between vanilla JavaScript libraries and TypeScript projects. So, for example, we're using React and React DOM as libraries in this project, and these two libraries are, of course, written for just JavaScript. After all, we worked with React and React DOM throughout this entire course with just JavaScript. Now, in order to also work with them in TypeScript and get great TypeScript and IDE support, great auto-completion, and so on, we need translations between these raw vanilla JavaScript libraries, which are written for JavaScript, and a TypeScript project. So extra type annotations that are added to these JavaScript libraries, you could say. And that's what add types React and add types React DOM provides. Not all libraries need such translations because some libraries actually already have built-in type annotations, even if you can use them with just JavaScript as well. But some libraries do need these extra annotations, and that's why here we got some extra annotations. Now, with that, we can leave that, and with that, we can now dive into writing some React code with TypeScript. Now let's write some TypeScript code, and for this you find my created React TypeScript project attached so that we all have the same starting point, even if that default app which is created by Create React App should change over time. Now, I didn't change anything here yet. At the moment, I have all these starting files, and therefore I'll first of all clean them up a little bit. I'll delete the app test file, the logo file, the report web vitals and setup tests file here. I'll delete all these files. The React app env file here, that's a file we should keep around to have TypeScript linked into our project, so to say. But in index.tsx, I now want to remove that web vitals import. And I'll actually also get rid of strict mode here. We don't need that here. And get rid of that part down there. And then here in app.tsx, I want to get rid of that logo import. We can get rid of the React import. In modern React projects, you learned that you can omit this, and TypeScript projects are no exception here. And we can get rid of all that JSX content except for the div for the moment here. And then app CSS, I'll now also delete all that code here. And then index CSS, I will actually keep that default setup here. I'll just get rid of the code selector, but I'll keep the body selector here and keep that default font family, which is assigned. That is actually fine from my side. And with that, we cleaned up this project. We can save all these files now. And now that it is cleaned up, let's write some React TypeScript code. And the most important part here, and the good news, is that generally, you still write the same code as you did it throughout the rest of this course. It's not like everything changes all of a sudden. And that hopefully makes a lot of sense if you have a look at this app.tsx file or the index.tsx file. That code here is exactly the same code as you saw it throughout this course. There's no difference here. No special type annotations because we don't need them here. We're generally using TypeScript's built-in type inference feature here, but in general, this code here simply doesn't use a lot of types. But that's something we're going to change throughout this module now, and you are going to see where you can use TypeScript to actually enhance your React code. Now, to dive into React and TypeScript, I want to keep it fairly simple, and we'll simply build a basic to-do app. A basic to-do app where we can add to-dos and delete to-dos. That will not be a super complex or fancy app, but it will allow me to show you all these core TypeScript features you should know. And for this, I'll start by adding a new components folder in the source folder. And in there, let's add a to-dos.tsx file. And that will simply be a file that should hold a new React component. Now, a React component still is a function or a class, but as we did it in the rest of this course, we'll focus on functional components here. So here we can add this to-dos function, and then of course also export it to make it available outside of this file. Now, just like all the React components we built thus far, we need to return some renderable content, and that will typically be JSX. And that, again, does not change at all. So in here, let's say we want to have an unordered list, because we have a couple of to-dos here. And in there, we have a couple of list items, of course, with our different to-dos, like learn React or learn TypeScript. And we'll later make those to-dos dynamic, and we'll make sure that a user can enter them. But for the moment, I'll just create this functional component like that with the hard-coded JSX code. And now we can use this to-dos component here in the app component, simply as we always did it by importing to-dos from components, to-dos. You can omit the file extension here. And then here in that div, or even without the div, doesn't matter, you can output to-dos. And we can actually also get rid of app CSS here now that I think about it, since it's empty anyways. But with that, if we save everything and we go back and reload this page, we see our to-dos here. And that shouldn't be too exciting, of course, because that's a very basic React component, but it shows us that we build React components generally as we learned it. But it gets a bit more interesting if this to-dos component actually does not have hard-coded to-dos, which we output here, but if it instead receives to-dos through props, which we want to output. So let's delete those hard-coded to-dos here. And now let's say we get some props here. And now my goal is that the props should have items or a to-dos prop where I can then map through all those items to then output the list items. And you can already see here that now I'm getting those red squiggly lines here. And if we hover over that, we see that props is declared, but its value is never read. So we're getting a warning that we're not using props. And that's a little extra help we get in this TypeScript project, which we don't necessarily get in a vanilla JavaScript project. We are warned if we have some unnecessary code that we're not using. And we also get this warning that the parameter props is implicitly of type any. And that means that we did not assign a type here. We're not making it clear which kind of type this is, and therefore we're basically not getting any TypeScript support. And that's why you can configure TypeScript such that it warns you if you are implicitly using any. If I now explicitly set this to type any, it would be okay. I'm now explicitly saying I don't have any more specific information about this props argument. It is of type any. It could be anything, and that's then fine. But if you don't set this type explicitly, you are implicitly assuming that you don't know anything about that type, and that's why TypeScript is warning us here. We shouldn't make this implicit assumption. By the way, you can configure the strictness of TypeScript here in the tsconfig.json file, but I'll come back to that a little bit later. For the moment, what we need to do here is we need to make it clear which kind of props we're getting here, what the type of props in this function should be. And of course, we can do this with a type assignment here. And now we could actually say that props is an object type. So we add those curly braces. And again, that's not a value here. That's a type definition. It's an object type. And we know that props in React will always be an object with all the attributes we added on our own element here in app.tsx as key value pairs. So here we could say that we expect to get some to-dos or some items, and that then in turn could be an array of strings, let's say like this. That's how we could say that props is an object with the items key, which then itself holds an array of strings as a value. But that would actually not be 100% correct. Props does not just have the key value pairs we added on our component when we use it in JSX. Instead, props is an object which does have those key value pairs, but remember that there also always is a special prop, the children prop, and we don't even know the type of that yet. Now we could find out which type that should be and then add it like this, but it would quickly become cumbersome if for every component that we're defining that is using props, we have to always add those built-in props to that object and then also our custom props. And because that's cumbersome, and because we have that base prop object, which we get in every component, which for example includes this children prop, React gives us a different way here, or React and TypeScript gives us a different way here. We can use such a generic type, which you might remember. We can use such a generic type, or to be precise, a functional component out of the box can be converted into a generic function. Which then simply means that in the end, our functional component will be configured such that we make it clear that it will be a React component function and that it will have all those base props like children, And we can then define explicitly our own props, like the items prop, for example, here, that should be combined into the props object. And if that's not 100% clear yet, I'll show you how it works. We can actually write this a little bit differently and use this arrow function syntax, which we used throughout this course all the time, so that our to-dos constant here holds this React component function. And now we can assign a type here to this to-dos constant. And the type here should actually be React, for which we need to import React from React, like this, .fc. Now that's a type defined in this React package, or to be precise, by this types React package, but we can just import React from React and the rest will be done behind the scenes. So this is a type definition here. Now, if I hold Command and click on this, or Control and click on this, I see the type definition here, and I see that it's a function component, which is yet another type definition built into this React package. Now, what React.fc in the end does as a type definition is it makes it clear that this here is a function that acts as a functional component. That's what FC stands for, functional component. And you see that now the red squiggly lines for props are gone. And if I now try to use props here in my JSX code and I add a dot, I see that I now get this auto-completion for the children props. So now, simply by adding this type annotation, TypeScript and my IDE therefore, which is very smart about that, understands that this is a function that receives a props object as an argument, as a first argument, which will be an object that always has a children property, a children field. And it understands this, it knows this because of this type assignment here. Now, I mentioned that generic types would be important because this is actually a generic type. And we can now merge our own type definition for this props object, so our own props this functional component will get, with those built-in base props like the children prop. And for this, we add angle brackets after FC here, and then between those angle brackets, we define our own props. Now, when we use angle brackets here, we actually use them slightly differently than we did before when I introduced you to generic types. There, we used angle brackets to create our own generic function that has this generic type parameter, if you want to call it like this generic type t here, which then could be used inside of the function, and which in the example I gave you then was inferred by TypeScript when we used that generic function. Here we're using it slightly differently. Here, React.fc already is a generic type. It describes a type defined by the React package that is actually generic. So that type internally is also defined with those angle brackets. And here, when I also add angle brackets in our code, I'm not setting up a new generic type with some placeholder type t, but I'm plugging in a concrete value for that internally used generic type. So for that type t defined by that React FC type. And I'm doing that here because here we can't let TypeScript infer that generic type as it did it in the example I showed you before. We can't let TypeScript infer the type here because here we're not calling some generic function with some parameters where the values then could be used for the inference, but instead we're defining a function and we want to let TypeScript know how it should then treat this function internally. That it should get some props defined by us and merge those with some base props like the children prop, which all functional components have. And what you see here, therefore, is the other side of generic types, that you use a generic type and you explicitly set the concrete type that should be used for this usage of this generic FC type. Here I'm saying this FC type is generic and the concrete value I'm plugging in now is my own props object where I describe my own props for this specific functional component. And it's generic because different functional components have different props definitions. And that's how we do that with React and TypeScript here, how we can also use this generic types feature. Now, this angle bracket syntax is the generic type syntax here. And by adding it here, we actually unlock a feature built into this FC type, which we're using here, which will merge whichever object type we're defining here with that base object type with the children property. And here we could then say that we want to have items, which is an array of strings. And what this does now is that here, if I again type props dot, it still knows that there will be a children property, at least that there could be a children property, but that we now also have this items property, which will be a string array. And it knows that because we now merge our own prop object definition with that base prop object definition. And that might all sound super complex, but it's just sounding like this because I'm explaining the behind the scenes stuff here. In the end, using it is super simple. You build functional components with React and TypeScript by using this React FC type here on your functional component constant here. And then you use those angle brackets, and between those angle brackets, you define your own props, your own prop object type if your component gets some custom props. And then in the component, you can use those custom props. And here we can then use props items, use map, and we get auto completion here for this array method because TypeScript knows that items will be an array because here we defined that it will be an array. And we can then map all our items and turn every item into a list item here where I output item and where I set the key equal to item. So for the moment, my key will just be the string inside of this items array. And now I'll reformat that. And that's now this finished to-dos component with proper type annotation. Now, the great thing about using TypeScript with React is now not just that this is now more descriptive and we get the auto completion here when we work inside of this component, though that's already pretty good, but that now you also see we have an error in app TSX. Because of our type annotations, React now understands, or this project setup to be precise, now understands that we're using this to-dos component in an incorrect way. Because I'm making it clear here in this type definition of the to-dos component that this component will have a items prop. And this is not an optional prop. We could make it optional by adding a question mark here, but then here we need to handle the case that we don't necessarily have items. But here it's also not optional at all, and therefore we have to add it here. And that's another strong reason for using TypeScript. We can now really describe the shape of our components and which props they need, and therefore using our components incorrectly, and for example, not passing in all the props a component needs, is pretty much impossible because we get errors like this directly in the IDE now. So here I can now add my items and for the moment just add some dummy to-dos here like learn React and learn TypeScript, reformat this, and now all errors are gone. And we now see that output again, but now thanks to our props, and those props now work properly thanks to our type annotations. And I did spend a lot of time talking about this type annotation, but I hope it's clear how it works, and even more importantly, it's clear how you use it. And as you see, using it is super simple. It's this type annotation which you want to add to every custom component you're building, and then if you are using your own props, you add this generic type and you describe your props between those angle brackets. Now we got started with our own components with props. Now let's refine this. At the moment, a to-do is simply a string, and hence a list of to-dos is an array of strings. That could be what you need, but it would also not be unrealistic that every to-do is an object with an ID maybe, with the to-do text, maybe a title and a subtitle, and maybe then also more metadata that is attached to a to-do, like the author, the time when it was created, if it's currently active or not active. There are endless ways of describing a to-do. I don't want to incorporate all those ways right now, but I definitely do want to refine it a little bit. And therefore, I'll add a new subfolder in my source folder here, which I'll name models. You don't have to name it models, you can name it however you want, but I name it models because I want to describe my different data models, my different kinds of data I'm working with in this project. And in there, I'll add a todo.ts file, not tsx, but ts, because I'm not creating a component in there. It's also not in the components folder. And in this todo.ts file, I want to describe how a to-do looks like. And for this, I want to create my own to-do type. Now we can do this with the type keyword. There also would be the interface keyword, which we can use as an alternative. Or we create a class, which we then even could instantiate. And I'll do the latter here, but either approach would work. With that, I create a class to-do, and we create this class basically just as we would do it in vanilla JavaScript. Modern JavaScript has classes built in, and I'm just using that feature here. It's also supported in TypeScript. And now here we can describe how our class should look like. And here we now got some slight differences compared to how we do this in just JavaScript. Because when working with TypeScript and classes, if your class has different properties, different attributes which you want to add, then you don't have to do this in the constructor as you do it in vanilla JavaScript, but instead you can add them directly here in the class between the curly braces, as you're used to from some other programming languages like C#, for example. And here I want to make sure that a to-do object will always have an ID and a text field for now. And for this here, I'll add my ID field, and then assign the type for that, which will be string here. And then I'll add my text field, which also will hold a string. And then I'll export this to-do class. And we're now getting some errors here regarding ID and text. And we're seeing that the property text has no initializer and is not definitely assigned in the constructor. What this warning is telling us is that I'm defining a class here, which is meant to be instantiated. That's the main idea behind classes in general. But that those properties which I set up and describe in there, where I set the types, never receive a value. And we can make sure that they do receive a value by adding a constructor. This constructor could then also want some arguments. And here I want to get the to-do text as an argument, because I'll generate the ID dynamically in the constructor then. And the to-do text will also be of type string, hence the type annotation here. So now we got type annotations on the properties, and then here also on the constructor on the argument. And inside of the constructor, I'll then set this text equal to to-do text. To-do text here. And I'll set this ID equal to an ID which I want to generate here. And I'll just use a date here and convert this to a string. That's not a perfect unique ID, but it's good enough. So now whenever we create a new to-do, this ID gets created automatically. And now we have this to-do object definition, this class definition here in this TypeScript file. And that's very close to how this would look like in just JavaScript. In just JavaScript, we would basically not have these two property descriptions, and we would just have this code. which would work in just JavaScript. But in TypeScript, when using TypeScript, you also have to define those properties ahead of time to make it clear which types of values will be stored in there. And with that, we can now use this to-do class. And we can use it in app.tsx, for example, to create some dummy to-dos. Here we can have our to-dos, and that is an array. And in that array, I want to now instantiate my to-dos based on this to-do class. For this, I'll import to-do from /models to-do. Again, you can omit the file extension here. And then we instantiate and create those objects based on the to-do class, just as we do it in vanilla JavaScript. We can use new to-do here twice to create two to-dos. And then we need to pass in that to-do text, like learn React and learn TypeScript. And now our to-dos, this here is no longer an array of strings, but instead an array of to-do objects. Now I want to pass that as a value for the items prop into to-dos, and to accept this array of to-do objects instead of array of strings, we have to change the type annotation here in the to-dos component. Because there I currently want an array of strings. Now, the great thing is that if you are defining a class, this class also acts not just as a constructor function which you can call to create new objects, but also as a type. You can use your class name as a type. And therefore, in the to-dos component, I can import to-do from going up one level, diving into models, to-do, and we can make it clear that items will be an array of to-dos based on that to-do class, which means items will be an array full of objects that fulfill the description, the definition of this to-do class. So full of objects that have an ID property, which is of type string, and the text property, which is of type string. Or to be precise, objects created with this class as a constructor function. That's what we now want as an array here for this items prop. And that, of course, also means that if we map through the items, we no longer want to set the key equal to this object, but instead probably to item.id and the text equal to item.text. And with this now, we updated to-dos TSX. Now in app.tsx, we just need to use our to-dos array as a value for this items prop. So here I'll now pass to-dos as a value to the items prop to the to-dos component. And if we do that, again, the visual output does not change, but our code definitely changed. And please note that with all those type annotations and all those classes we're using here, we are making it very clear which shape our data should have, which shape our components should have, and that simply allows us as a developer to ensure that this code is clean, that it has a clear structure, and that it's way harder to misuse our components or our data, and that errors can be prevented during development instead of at runtime when we test the app. Because if we pass in incorrect to-dos here, we get a warning right in the editor instead of an error, which we would then get at some point in the running app. And that's the benefit of TypeScript. So lots of TypeScript concepts are already at work here. And as mentioned before, if you want to learn about all those concepts in depth, you definitely want to check out the official TypeScript docs or some other TypeScript resources. For example, of course, also my complete TypeScript course, which I have. But now let's dig a bit deeper here. We got this basic to-dos component here, which outputs these to-do items here. Now, very often for that, we would now have a separate to-do component, so that this list item here is in a separate to-do component, because in reality, it often might be more complex than just a li opening and closing tag and some text in between, even though that is what we have here. Now, I got a challenge and a little practice for you at this point. I want you to outsource this into a separate component, and you should keep the JSX code as it is. Don't make that more complex, but make sure you create a new component and configure it correctly regarding the type it needs, the types it receives, the type of component it is. Make sure you do that such that you can continue working with that array of to-dos. Here's a short pause for you to pause the video and try this on your own. Thereafter, we're going to implement this together. Were you successful? Let's build this together. And for this, I'll create a new component, the todo.tsx file or the todoitem.tsx file. And I'll go with todo-item so that we have no confusion or clash with the to-do class we have here. Now, in this todo-item component file here, I want to create my todo-item functional components, and I'll write it as an arrow function here, and then export this, this todo-item here, todo-item, like this. Now here we'll get this props object, we know that already, because we'll ultimately return a list item with props.text as a content. The key will not be added here because the key should be added directly in the list, so where you call map, and therefore I will add the key once we use the todo-item component here in the to-dos component. But the key is not our primary problem at this point. Instead, the problem which we got here is that we have those red squiggly lines because props is implicitly of type any. And it is implicitly of type any because we have no type annotations here. Now, when you create a new functional component, you learned that you should add this React.fc type annotation. And that's what I'll do here. I'll make it clear that todo-item is a React functional component by adding this type annotation. And for this, we can import React, though we don't even have to do that in modern React project setups. You can still add the React import if you want to, but you don't have to. So now we make it clear that this is a functional component. But now I get an error here because we now use a text property which doesn't exist. Because out of the box, a component gets props, but it only has this children prop, maybe. And it definitely does not have a text prop out of the box. That's why we need those angle brackets here. That allows us to merge in our own prop definitions with those base props. And here we now want to set up an object type, because props is always an object, and we always merge an object with those base props. And we now want to make it clear which kind of prop we can expect here. And here it's now really up to you. You could expect the entire to-do as a prop, so the full to-do item, including the ID, so an object based on this model. But that is actually redundant here, because in this component we're not using the ID. We're only using the text. And therefore we maybe just want to get this text or the to-do text, however you want to name it. I'll go with text here, which will be a string, because that's all we need here. And if I set it up like this error is gone, and this component is ready to be used. If you came up with a solution where instead you expect to get the entire to-do, and you import to-do from your models folder, that's also fine. But here I'll just build a very minimal component and just expect the text. And now we can go to to-dos tsx, and here I'll now import todo-item from this todo-item tsx file. And here I'll output to do item for every item in this in this items prop here. And I'll set this key. We can set this even though we're not expecting a key prop here in our to do item component, because we are using this FC base type. That does not just give us the children prop here, it also actually makes sure that we can add these special props like the key prop on our component when we're using it. So we can add the key prop here to do item, this key attribute, so to say, and set this to item.id. And now, very important, add the text prop. And I'm also getting auto-completion here. If I press Control space, you see that this text prop is wanted. It's suggested here. And then here I'll set this equal to item.text. And that's one way of building this to-do item component and using TypeScript for it. And with that, if I save everything again, we still get the same output as we did throughout the entire module, so that's not too exciting. But now we're using yet another component which again embraces TypeScript. And I'm really emphasizing this because this is the bread and butter of using React with TypeScript. Now that we built a lot of components that dealt with outputting to-dos, let's make sure our actual to-dos no longer have to be hard-coded dummy to-dos, but that we instead let the user enter new to-dos. And for this, I'll add yet another component here, the new to-do component, which should display a form that handles user input where we get the, to-dos a user added. For this here, I'll again create a functional component by using const and then the arrow function syntax. And I'll export this new to-do component here, new to-do, like this. And here, I now want to return my form. I want to render a form that allows the user to enter a new to-do. Now, this will be a very simple form which I built here. I want to have a label where I say to-do text. Below that, an input of type text where the user should enter the concrete to-do. And below that, a button for adding that to-do, for submitting that form. That's the JSX code I want here. We can refine the styling a little bit later. For the moment, let's just add it like this, and let's focus just on React and TypeScript. Now on that label, I'll add the HTML4 attribute, so to say, this prop here to point at the text input, which is this one here. So I added ID text here to connect the label to it for accessibility. But now with that, that's the finished JSX code. And what I want to do now is I want to handle the form submission and prevent the browser default, as we learned it in this course. And in addition, I want to, of course, then get the user input. And for getting the user input, we, of course, learned about two main approaches. We can either listen to every keystroke with use state, or we use a ref to then get the user input once the form is submitted. And it depends on what you want to do, if you want to validate with every keystroke or not, which approach you want to use. And here I'll go for the ref approach because we're going to see use state in action later anyways. Now let's start with the form submission function. For this, I'll add a new function in this component function, and that will be the submit handler function, though the name is up to you. In there, I expect an event argument so that I can call event prevent default, but we can already see that I'm not getting any auto-completion and that we got red squiggly lines here. Now we're getting red squiggly lines because TypeScript has no idea which type of data this event thing will be. We as a developer know that it will actually be such an event object, which is emitted and passed automatically when we connect this function to the appropriate event listener. But that's not something TypeScript can know. So we have to add a type annotation here. And here, since we'll add this function to the submit event through React, so with help of React's onSubmit property later, since we'll do that, the type here will be the React.form event. And you can actually omit this import, as you learned. That's a special type provided by the React package in the end, which is this event object type, which will get automatically when listening to the form submission. There also is a mouse event, for example, which you would get if you add an on-click listener. That's then the event object you get. But for the form submission, it's the form event. And then here we can call prevent default. You now see I get auto-completion because now I'm clearly describing which type of data we'll get here. Now we can connect this here and pass the submit handler to onSubmit. By the way, if I would be using mouse event here, you see I'm now getting an error down there with a very long message, basically telling me that the type of function I'm pointing at here for onSubmit is not the type of function React is expecting. Because for the onSubmit prop, React is expecting a pointer at a function that actually gets an argument of type form event, not of type mouse event. So that's an extra little check which we get here, which is great. And now with that turned back to form event, everything is working again. Now we want to extract the entered input, and we'll do that with help of refs here. Now we learned how we can use refs in a functional component. We can import the use ref hook here from React. And once we did that, we can create a ref, like the to-do text input ref here, for example. And we call use ref like this to create such a reference. Then we can go to the HTML element to which we want to connect the ref, typically an input element or a text area or something like this. And we set the special ref property on that element and point at our ref. In this case, we point at to-do text input ref. Now, if I do that, you see I get an error down there though, again with a very long text, that in the end, ref is receiving the wrong type of data. Now, ref wants a ref created with use ref. That's not wrong, but we're not explicit enough about the ref we're creating here. In vanilla JavaScript, this code works because we don't have the concept of extra type annotations. But when working with TypeScript, TypeScript actually wants to know a bit more about our ref. When we create it here, TypeScript actually has no idea that we eventually will connect it to an input element. That's only clear down there. But since it's not clear in this line, we could use this ref in any possible way. We can connect it to any HTML element. And that's in the end the kind of error we get here. We're passing a ref as a ref to this input that is not clearly focused on this kind of HTML element. This could also be a ref that wants a button. So we have to be more explicit about the kind of data we will store in this ref eventually. And we do this again with a generic type. That's why useRef actually is a generic type out of the box. We can add the angle brackets here now to explicitly set the concrete type of ref we want to create in this instance. So useRef is able to work with all kinds of data we will store in this ref here, all kinds of HTML objects we could connect with this ref, but we now have to specify which concrete value or HTML element we plan on storing into this specific ref object we are creating here. And here I know that I want to store such an input element. And that has a built-in type. And that's the HTML input element type. All those DOM elements have built-in types which you can use in TypeScript to refer to them. And for the input, it's the HTML input element. For a button, it would be the HTML button element. For a paragraph, it would be the HTML paragraph element, and so on. You can also always visit the MDN page of an element, like here the input element. And even though that, of course, is not focusing on TypeScript at all, on that page, you will find information like this. Like here, you find that the input element is based on the HTML input element interface. And that's why we use that as a type here. So now we are making it clear that the ref we're creating here will actually be connected to an HTML input element. But I'm still getting an error down there. And we're getting this error because actually we have to set a default value here, because this ref could already be assigned to some other element, maybe out of the box by default. And that's why we should provide a starting value here. And at the beginning, we have no connection, and therefore the starting value is null. But once we add this error goes away, because now we are creating a ref which will eventually be connected to an HTML input element, but which has no initial value. And we have to be explicit about this in case of use ref. And that's how you then create a ref when using TypeScript, and how you then connect it to an element. And that then again just works as you learned it. Now inside of the submit handler, we can of course get the entered text by referring to the to-do text input ref .current. That's how we always do it for refs. They always have this current property, which then holds the actual value. And now the great thing is that since we explicitly set this ref to hold an input element, an HTML input element, we get great autocompletion here. And we get all those input element object properties as suggestions here. So all the properties input element objects can have in JavaScript. And hence we, for example, also get this value auto suggestion. You will notice this question mark after current though, which in my case was added automatically by the IDE. Where is this coming from? This question mark was added automatically by my IDE here because the ref is not necessarily set to a value yet when we use it. Of course, here, as a developer, we know that when the submit handler is called, to-do text input ref will be connected to an element, because this function can only be called when this form was submitted, and that form can only be submitted after this ref was connected. But of course, theoretically, I could also try to extract a value right here after defining this ref, and in that case, the ref would not be connected yet. And TypeScript doesn't deeply analyze our code. It doesn't know that this technically can't be called before this connection is established. In that case, this question mark addition here signals to TypeScript that it tries to access value, and if that succeeds, the entered value will be stored in entered text. But if that fails, if the connection should not be established yet, null will be stored in entered text. And that's why here the inferred type of entered text actually also is string or undefined, which is basically the same as null here. So that means that TypeScript doesn't necessarily know that it will be able to extract this value. Now, if you as a developer are sure though that at this point of time there will be a non-null value, so here in this case you know that the connection has been established, you can use an exclamation mark instead of a question mark. This special annotation tells TypeScript that you know that this possibly nullish value will never be null in this spot. And therefore, of course, you should only use this annotation if you are 100% sure that this can't be null. So in this case, that this connection will have been established. And then the inferred type here is just string, not string or undefined, because you are sure that the connection will always be established and that extracting the value will therefore always succeed. And we can definitely do that here, since we know that technically submit handler, the way we write our code, can't be called before this line of code was parsed and this connection was therefore established. But that is an important concept which I definitely also wanted to briefly explore here. Now, it is worth pointing out, though, that these question mark and exclamation mark operators are not related to refs specifically. This is also not a React specific feature. Instead, these are regular operators which you can use in TypeScript when you are working with values that could be null. With question mark, you're always saying, try to get me that value, and if it's null, store null in the constant or wherever I want to store that value. With the exclamation mark, you're saying, I'm certain that here we won't be dealing with null, so therefore drill into this object, into this property, and give me the actual stored non-null value. And therefore then you will always get that value. But of course, as explained, that only works if you are certain that this can't be null. So these are two generally important operators in TypeScript, which here are very important when working with refs, since refs could be null or could not be connected to any value at this point. And with that, we now got the entered text, and we could now validate it and check if entered text, once we trim it, maybe is empty, which would mean that nothing was entered in the end, just a bunch of blanks, or anything like that. So here we could throw an error. I'll just return though. If we make it past this if check, we know that we have a valid input. And just to make this clear, this is not about whether the ref is connected or not. This is just validating the text entered by the user, which has nothing to do with TypeScript. But once we made it past this if check, we now want to add that to-do to our list of to-dos. And we probably don't do this here inside of our new to-do component function. Instead, we're managing the list of to-dos in the app component, and hence we'll need a way of communicating back to this app component to add the new to-do there. And we're going to do that in the next lecture. So with the new to-do component added, let's go to the app component. And there I actually want to use this new to-do component. So here I added the import, and now I'm using new to-do here in the JSX code. And of course, the to-dos array here should now be managed with help of this new to-do component. Whenever a new to-do is added there, it should be added to this array here, so that this array is not hard-coded but dynamic. For this, we got a couple of steps we need to take. We need to use state to manage this array with state, so that this app component will re-render when this array changes, so that the to-dos component updates when it changes. And we need a way of communicating back from new to-do into this app component. And that's what I want to start with. For this, in the new to-do component, here in the submit handler, I actually want to call a function which will be stored in app component. And that's of course a pattern we used a lot in this course. We learned that we can pass pointers at functions as props to our components. And that's exactly what I need here. In new to do, I want to get my props object. And then here in the submit handler, I want to call props on add to do, for example, expecting that on add to do is getting a function as a value so that I can execute it as a function. And then to on add to do, I want to pass my entered text, so my string here, which I extract from the to do text input ref. That's how I want to write this. But we now get an error up here. And that's of course an error we had many times before already. I actually never clarified that new to do will be a functional component. And we should absolutely do that. I should add React.fc here to make that clear. And then, if we need our own custom props, as we do here, I should embrace that generic nature of this FC type to define my concrete prop object definition of my own props, which I want to add in here, that will be merged with the base props. And here I want to make it clear that this new to-do component will actually get a onAddToDo prop, which will be of type what? Well, which will actually be a function. And for this, we can define a so-called function type in TypeScript. And that is actually quite straightforward to do. For this, you can add an arrow function here, but just as curly braces in this spot would not create an object, using this arrow function syntax here does not create an arrow function. Instead, we're here in a part where we want a type definition, and this is TypeScript's syntax for defining the shape of a function. So for describing a function type. And here we know that onAddToDo should be of type function, so here I'm describing how this function should look like. And between the brackets, we would describe the parameters this function will get, and after the arrow, we describe the return type of this function. Now here, onAddToDo shouldn't return anything, because when we call this function, we're not doing anything with the return value. We're not storing it in a constant, we're not outputting it, so we don't need a return value here. Hence, we can set void as an expected return value of this function we get as a value on onAddToDo. But onAddToDo should be a function that gets an argument, a parameter, because I'm passing an argument down there when I'm calling this function. And currently we're saying that onAddToDo is a function that gets no parameters. That's my function type definition up there at the moment. That's why we're getting the red squiggly lines down there. This onAddToDo function currently expects 0 arguments, but it gets 1, entered text in this case. And of course it should get 1, so we need to update this function type definition up there. We should get an argument here, which we can give any name we want. In this case, I'll just use text, which should be of type string. And now all the errors are gone, because now I'm making it clear that onAddToDo will be a function, and that's a function that returns nothing but takes one parameter, which is of type string. So now calling it the function like this works. If I would set this to type number, it of course fails because entered text is a string and not a number. But that's okay because here we want a string. So let's switch this back. Well, and now with that, just as all the times before, in the place where we use new to do, so in the app component, we now have to make sure that we pass in this prop which we're expecting. So onAddToDo should now be added as a prop here, and the value for that should now be such a function that has this shape. Now that's a function which we now have to define here in app.tsx. So here I'll add a new constant and I'll name it addToDoHandler, and that's now an arrow function, let's say. And that arrow function needs a specific shape. Now that's a concrete function definition here now, not a type definition, because here we got some regular JavaScript code in the end. Now the shape of this function is that it shouldn't return anything, so not having a return statement here is fine, but it should accept a parameter. It should get the actual to-do text or just text, you can name it however you want, which, and that's important now, should be of type string, because that is the function shape we are expecting in the new to-do component. So if we want to pass this function through the onAddToDo to new to-do, we have to make sure that this shape is correct. And here it is correct. So now we can pass a pointer at add-to-do handler to new to-do. And now it's in add-to-do handler where we want to manipulate this to-dos array. So this state managed array, as it soon will be. So it's time for use state, because of course we need to manage this to-dos array with state so that when we change it, this component re-renders and therefore this to-dos items also re-renders and is updated. And for this, of course, we do what we learned in this course. We import use state from React like this. And then to-dos actually will be converted. I will get rid of those dummy to-dos here. And instead, I will call use state here. And we now don't just get back to-dos here, but we get back an array, as you learned, which we can destructure, where we get our to-dos and this state updating function. And thanks to TypeScript, we now, for example, see that set to-dos, if we hover over it, is actually of type React dispatch, which might not be 100% clear, but which is actually that state updating function which we can call to change our state, to dispatch a state update, so to say. Now, use state, of course, can take an initial value, and that could be an array, an empty array initially, because initially we have no to-dos. But here we actually now introduced a subtle problem if we write it like this. And do you see which problem that is? The problem is that I'm just passing in an empty array as a default value here. But TypeScript is not able to infer which types of values should be accepted in that array eventually. That's why to-dos at the moment is of type never array, which basically means it always must be an empty array. No values are allowed in there. That's what this strange never type means here. And that's of course not what we want. But TypeScript infers this type because it's not able to infer that this should be an array of to-dos, for example, eventually, because the initial value has no information about that. To make it clear that we initially have an empty array, but that eventually we want to have an array full of to-do items here, we again need to tell TypeScript somehow. And we can tell TypeScript because use state, this use state function, out of the box is a generic function. It is generic for exactly this reason, so that we can set the type of data we eventually want to store in this state. So we add angle brackets again, and now we want to make it clear that the kind of data managed by this state will be an array of to-dos. We do this by using our to-do type from that models folder, and then square brackets. That means that this state will manage an array of to-dos. Initially, it's an empty array, because that's also fine. That does not conflict with this type definition. But if we do add items to this array eventually, they have to be to-do items, not strings, not numbers, to-do items, which have the shape of the to-do object class here we created here. And now that's the proper way of defining this state. Now in add-to-do handler, we then want to create our new to-do by calling new to-do and passing in the to-do text as a value to the constructor. And then we want to call set to-dos and update our state. Now here I want to use my old to-dos state, so the existing array, and add this new to-do. And you learned that if you want to update your state based on the previous state, you should use this function form of updating your state. And in this function, you get the current state, so to say, or the previous state, depending on how you want to look at it. And then you need to return your updated state here. So in this case, I'll return previous to-dos, concat new to-do. Concat is a method which we can call that will create a new array, which we should do. We should not mutate the existing array. We should return a new array here, which then will be used as a new state by React. And this new array, thanks to concat, contains this new to-do. That's how we can properly update this state here. And with all that in place, if we now save this and I reload, I got this unstyled form here and no to-do list at the moment. But if I then enter learn React here, then this is added. And if I add learn TypeScript, this also is added. So that is working. Now let's continue, and first of all, I want to add some styling. For this, I prepared free.module.css files, which you find attached. The to-dos module CSS, the to-do item, and the new to-do.module CSS files. And we will simply add them like we did it before in this course. There is nothing TypeScript specific about adding CSS files to your component files, no matter if you use global CSS or CSS modules. Here I am CSS modules, hence the naming of these CSS files. Since we are in a project created by Create React App, we got that built-in CSS modules support. And here we can now import the classes, for example, from todos.module.css. So just as we did it without TypeScript. And then here on this unordered list, we can add the list class. That's, the todos class. That's the class I defined in that todos module CSS file. And we'll do the same in the other files as well. In the to-do item tsx file, we can import classes from /todoitem.module.css, and then we add class name.classes.item to this list item. .item, because in this to-do item.module CSS file, I have this item CSS class. And in the new to-do tsx file, we also import classes from ./new-to-do.module.css, and with that imported, we can go to the form and on it add class name classes.form. And if you do all of that and save everything, you should have that look here on your screen, where you can learn React and then learn TypeScript, and that works just like that. And that's now the same app as before, just with some styling. Now, adding to-dos is great. I also want to make sure that we can remove to-dos by simply clicking on them. And that's again another challenge I got for you. Add the code to this little demo app that ensures that if we click on a to-do, we remove that to-do. You will only need things you learned up to this point. After a couple of seconds, which you can take to pause the video to try it on your own, we will do that together. So, were you successful? Let's now make sure we can remove to-dos. For that, I want to go to the to-do item and make sure that we can click that. And when we click it, we remove a to-do. For that, on this list item here, our to-do item, I want to add the onClick prop, this built-in onClick prop, to trigger some code when that is clicked. And then here, in the end, I want to point at a function which I expect to get through props, because that is how we typically do this and how we did that up to this point in the course in most demos. So therefore here, upon a click, I want to trigger some function which is received through props, and hence here we could, for example, expect a prop named onRemove_to-do. The name is up to you because it's your component. But of course I'm getting some red squiggly lines here. And why am I getting this? Because I'm using a prop here, I'm referring to a prop which I'm not describing here in my type definition for this functional component. Here I'm clearly just saying that this component function will receive a props object which has these base props, the children prop, and then my own props here merged into that. But there, I only have a text prop, nothing else. No on remove to do prop. Now, since I want to accept such a on remove to do prop, we should also describe it here. So we should make it clear that we will get a on remove to do prop here as well, and then set the type of that prop value. And here that should be a function which I'm binding to onClick. So therefore we can describe a function type here. We are not interested in the return value, so here that can be void, so the function doesn't return anything. And regarding the argument, the parameter, we actually also don't need one. Now in case of onClick, so since we're passing this function on to onClick, we could actually expect an event argument here, which would be of type React mouse event. That would be a type we could set here. This would describe the kind of function we can pass to onClick accurately. But actually, describing this argument type is optional, because we might not be using it here, and therefore, thankfully, we can also omit it and just shorten this function definition to just this definition. So now we're passing this function, which we receive on remove to do, which has this shape, to onClick. Now we need to go to the place where we use to do item and make sure that this prop with such a kind of value is set. And that's the todos.tsx file, of course. Here we're currently only passing in the text prop, and we should now also pass in the on remove to do prop. And thankfully, because we use TypeScript here, we get this auto completion again. So now we want to set on remove to do to such a function which we're expecting. Now in the to-dos component, I actually don't want to define that function though, because the to-dos are being managed in app.tsx. So here again, I just in the end want to forward some prop value which I get in this component. So we're building such a prop chain. So therefore here we can also accept another prop in this to-dos component, which is maybe also called on remove to do, but that name is up to you, but which then also will be a function that has no parameters and that then actually also doesn't return anything. And here we then pass props.onRemoveToDo as a value to the onRemoveToDo prop of to-do item. And that's again all just what we learned in this course about passing functions to different components and about building these prop chains for forwarding props through multiple layers of components. And then here in app.tsx, ultimately, we have to add on remove to do here on to-dos as well. And now here I want to define the function that should eventually be called. The remove to do handler function, which has a function that looks like this, no arguments and doesn't return anything. And now it's this remove to do handler, which we pass as a value to on remove to do. But this function definition is actually not correct. How would we know which to do to remove? In the end here, I need some identification criteria. And for to-dos, since every to-do has a unique ID, getting that ID would make a lot of sense. So in app.tsx, this remove to do handler should actually get the ID of the to-do that has to be removed. This to-do ID, which will be of type string. It will be of type string because that's the type we use for our IDs in this to-dos object. And then when we get that, we can actually call set to-dos and use this function form, since we're updating the state based on the previous state. And then there we could return priv to-dos filter to filter out the to-do which we want to remove, and go through all the to-dos and remove the to-do where the ID is equal to to-do ID, and not filter out the other to-dos. That's how we can do that. So that's how we can remove a to-do from this list of to-dos, and how we remove the to-do with that ID which we're getting here, we are checking for inequality here because we want to keep all the to-dos where the IDs do not match, and that's the way we have to look at this. But we now have a problem. Remove to-do handler now wants this to-do ID of type string. But that's not the type of function on remove to-do is giving us here. In this to-dos component, after all, I said that the function we get here takes no parameters. And that's simply incorrect. Indeed, here we should expect that ID, which is of type string. But now on remove to do on the to do item is having the wrong definition, because there I'm still saying that we have no parameters. And again, that's simply incorrect here. And we can now either update that here and make sure that we do set the correct ID here, though for that we also need to accept it here as a prop. Or we go to todos TSX and we actually bind on remove to do. Bind is a default method in JavaScript which allows us to pre-configure a function for future execution. We also saw that a couple of times in this course. And here we first of all set what the this keyword will refer to in this to be called function, and we don't care about that here, so I'll set that to null. And then we set the first argument on remove to do will then receive later, and that should be that ID here, so item.id. And with that, all the errors are cleared because now on remove to do will indeed receive that ID here when it's being called. And that then allows us to properly remove a to-do. If we now save everything, if I click on a to-do, it is removed. So if I add all my to-dos here, I can delete them by clicking on them. And that's now working, as we see in the console, also without any errors or warnings. And that's how we can use React with TypeScript. Now, to finish this module, this introductory module here, I also want to show you how you can use the context API with TypeScript. And then we'll wrap this up and I'll show you which other resources you can check out to learn more about React and TypeScript. So let's now wrap up this module by also exploring the context API with TypeScript. For this, I'll add a new folder, store, which is not a must-have, but the convention we used typically in this course. And there I'll add my to-do-context.tsx file. A TSX because I'll write some JSX code in there. Now in there we can start by creating the to-dos context by calling React create context. And for this, even though it's technically not required, it's not a bad idea to import React to make it a bit more transparent where React is coming from here. Now I'm calling create context here, and create context actually wants a default value. It wants one argument. And here that can be an object where we describe the shape of this to-dos context. And there we'll have our items, let's say, which will initially be an empty array. And then we also have the add to do function, which will be a function that does nothing here, and the remove to do function, which gets the ID of type string and then does nothing. Now at this point already, we can add more TypeScript logic. Because, for example, items is an empty array here, and we again would have the problem that it's not clear which kind of values should eventually end up in this array. For that reason, create context also is a generic type, so we can add those angle brackets here after create context in front of the parameter list to better describe our context object. Because here, between the brackets, we're not setting up some type definition. This here is some concrete JavaScript code where we create a JavaScript object with some properties. So here we're not setting up some type. The only type we're setting up here is this argument type because I'm creating a concrete function here. To define the overall type of this object here, we need to use this generic type feature between the angle brackets and then describe our context object type here. And here we can now make it clear that items will now be a to-do array, For that, we import to-do from the models folder and the to-do file there. And now here we have a pure type definition. So here I'm making it clear that items will be of type to-do array. And then I'm making it clear that add to-do will be a function type that returns nothing. So that's the difference to down there. That's a concrete function definition with an empty function body. That's a function type definition where I'm just defining the return type of that function here, void, and no parameters. And then remove to-do, which is also a function that returns nothing, but that gets an argument of type string. And that's now my to-do's context. Now I'll create such a context provider component, as I also did it multiple times in this course, which will be responsible for managing that context state. So here I'll add the to-do's context provider, to-do's context provider component here. And that will be a functional component. So we should set this to React.fc as a type to make it clear that we'll store a functional component in there. Therefore, we need to return some renderable content here because that makes up a functional component. And hence here I'll return some JSX code. To be precise, I'll return to-do's context.provider. And then between that, I want to output props children. And children is a default prop, so we don't need to describe this shape of props for that. Like this. Now, of course, here in the to-do's context provider, I want to manage my state for this context. So therefore, in there, we want to call useState. And for that, make sure you import useState from React. And manage the to-do's state here as we did it in app.tsx before. And therefore, I'll actually copy or cut all that code from the app component, this state management code and the functions there, and add that here into this to-do's context provider component like this. Because that code is still valid and still fine to be used like this. And now that I added this here, we can construct our context value here, which is an object of that shape here. So of these types and values. And therefore here I can add my items and set this equal to to-do's, which is this to-do's state I'm getting here. And I set add to-do equal to add to-do handler and remove to-do equal to remove to-do handler. And now I can set the value here equal to context value. And if I do that, I get red squiggly lines here. I'm getting red squiggly lines because actually my context value object here does not have exactly the shape I describe up here when I create my context. Now what's the difference? The difference is add to do, and I introduced this on purpose. I define here, when I create my context, that add to do does not take any parameters. But clearly it takes a parameter when I then create the concrete function for this object. Here I'm expecting the to-do text. And then I'm setting this add to do handler function as a value for add to do. That's why I'm getting this error down here. Now I'm getting this error down here because here, when I create this context value object, I'm not saying anything about the type of data that's expected in this context value object. We might want to do that to already catch the error here though. And for that, we can add a type assignment here as well to be clear about the type we want to have in there instead of inferring it. That's a scenario where setting the type explicitly could make sense so that we're not inferring a type that's incorrect as we're currently doing it. And the type I want to set here is of course the same type as up there. So I can copy that and add that down there. Now we see that we catch the error here already. Now before we fix it though, copy and pasting is always not ideal. So instead of copy and pasting this type definition, I'd rather set up this type definition only once to then use it in all the places where we need it. And to implement that feature, we can of course create such a type alias again. We can create our to-dos context object here, for example. This name is up to you. And store this type definition in this type alias. Now we can use this alias here between the angle brackets and use that same type down there to avoid this copy and pasting. So here I'll now also use this alias. And now we also, of course, should fix this error. And we fix this error by updating our type definition, which we now, because we're not copy and pasting, only have to do in one place. And here, add to do is actually a function that should get some text instead of no parameters. So that's an important fix. And with that, we're setting up the correct context value, and we're setting this as a value for this value prop on this provider component then. Now we're setting up this to-dos context provider. Hence, we can now export this here, export this as a default maybe, and also export the context itself, not the type definition, but the context, because we'll need that for the use context hook later. And actually, not later, but now. Now I want to connect my created context here to the different components. And for this, first of all, we don't need to manage to-dos in the app.tsx file anymore. Here we can get rid of on-add to-do on the new to-do component, and we can get rid of these props here on the to-dos component. We can get rid of the to-do import from the models folder and of the use state import. This app component can be way leaner now. Because now in those components, we can use the context. For example, in the to-dos component. Here, we can now import use context from React and also import our to-dos context actually as a named import between curly braces from going up one level, store to-dos context. And I'm importing the context here, not the provider, so that I can tap into that context here. So that we can call use context as we learned it in this course and tap into this to-dos context here. And that will give us access to the to-dos context like this. And if you hover over this constant, you now see that it automatically knows the type of value that's managed by our context, thanks to TypeScript and us linking everything correctly. And now here we can use to-dos context to go through all to-dos context.items, which are my to-dos now. And instead of props on remove to-do, I now want to call to-dos context remove to-do. And I'll still call bind though, because I still want to pre-configure this function to get the right ID eventually. Now, of course, we can get rid of the props argument here, and therefore we should also get rid of our own props type definition here on React FC. Because this to-dos component doesn't use props anymore. Instead, it now uses context. So we should simplify that and remove that unnecessary type definition. That, of course, also means that we can get rid of that to-do type import from the models folder. That's now the cleaned up to-dos component using the context API. Now we also, of course, want to use the context API in the new to-do component. There we add a to-do, and now we also don't want to leverage props anymore for that, since we're not using the parent component for managing to-dos anymore, but we want to use context. So from React, we import use context, and then here I'll import to-dos context from going up one level, store to-dos context. And just as in the other component, and just as in this entire course, we now call use context and point at to-dos context, and that gives us our to-dos context. And with that, here, instead of calling props on add to-do, I now call to-dos context add to-do and pass in my entered text. And that's the change we need to make here. The rest of this component internal code stays the way it is. Now, what does not stay the way it is the component definition though. We don't get props anymore, so we should remove that parameter, and therefore we should also remove that prop description here for this functional component, because we don't have any special props anymore. Hence, we should remove that here and clean up that component. And now there's only one missing thing, and that's the usage of our to-dos context provider component. Because using use context is fine, but it only works if we somehow wrap these components that use the context with that context provider. And we can do that in the app.tsx file, and for example, replace that div with the to-dos context provider, which you need to import from store to-dos context. That's super important. Without that, it would not work. But with that, if you add this, I can again learn React and TypeScript and more. And I can, of course, also still remove things without any errors in the console here. So that is working. And that's how we can use the context API with React and TypeScript. Now that's it for this module. We learned a lot about React and TypeScript here. It was quite an in-depth module with lots of examples and concepts. But of course, we're only scratching the surface of TypeScript in general here. And of course, we kind of went through that entire content rather quickly, because this is just a summary of TypeScript and React. If you want to learn more about that, for React, you got this entire course, and for TypeScript, I got a couple of resources that could be useful. If you search for TypeScript lang, or actually also just for TypeScript, you find the official docs. And those are, of course, a great place to learn more about TypeScript. There you can dive into the docs or the handbook, and you learn about all those core TypeScript features, and you also find examples there. And that site, therefore, is really a good resource for learning all about TypeScript in the greatest detail possible. But it can also be overwhelming. Now, for React and TypeScript, if you search for Create React App in TypeScript, you find that setup article from before again, and in there you also find more resources on getting started with TypeScript and React. You get an example project, for example, a cheat sheet, and a link to the official docs. Now, I also got a TypeScript course which you could check out as an alternative. This course does not focus on React and TypeScript, but just TypeScript. And of course, taking it is optional. You get all the knowledge you need also with those free resources. But if you want to learn all about TypeScript from me in this course, that course could be very helpful. It also does have another React and TypeScript introductory section, but the core content and focus of that course is just TypeScript, and we're going to dive into all the key features there. And these are possible next steps which you could take to build up on the knowledge you gained in this module to build React apps with TypeScript if you prefer that over just JavaScript with React. Now, as a bonus in this module, I want to have another look at this tsconfig JSON file, since I promised that, and since it is important to at least understand the basics about this file. This is a file which you can add to any project where you are using TypeScript, so where you are compiling TypeScript code to JavaScript code, and then this will configure this compilation. Now, speaking of the compilation, in this React and TypeScript project, the compiler is invoked automatically when we start the development server or when we build this project for production. We are using a behind-the-scenes build workflow setup where this TypeScript compiler is integrated. So here we configure this compiler, and in there you got various options. To understand all those options, of course, check out those official docs or my course. I do dive into greater detail there, and the official docs also explain all those options. But you can also hover over an option and you will get at least a short description here and a link for the more detailed explanation. So that's very helpful. This links to the official docs. And I'll also walk you through the most important options here. And that starts with the target. This in the end controls the target JavaScript version to which your code will be transformed. And in this case, that's ES5 JavaScript, which is quite an old version, but which of course means that you should generally have a broad browser support. Though I will say that depending on your project setup, this target option might not be the only thing that influences the output. There also can be project setups where your TypeScript code might be compiled to JavaScript, and then you might have yet another compilation step, for example, with other tools like Babel that take that output JavaScript code and transform it even more. So that's not necessarily the last step in line, but it often will be. And that then simply controls to which kind of JavaScript code your TypeScript code is transformed. Now here we see some default TypeScript libraries that are included, and that influences which kind of types are known out of the box by our TypeScript code. And these are some libraries which are actually built into TypeScript, so we don't need to install some extra packages here, but to unlock them in this project, we still need to list them here. Now, the DOM lib, which is added here, for example, ensures that some default DOM types are understood by TypeScript. And a great example here can be found in the new to-do TSX file, this HTML input element type. I mentioned that this is a built-in type, and it's actually such a built-in type that's unlocked because we have that DOM lib added here. If I would remove DOM here from lib and save this, then eventually here you see I'm getting an error down there. That value does not exist on this type because it actually doesn't fully understand this type then. So that's an important lib which we should have here. So in here, I'll bring back DOM. Now, for those other settings, allow.js controls that we could also include just .js files, so plain JavaScript files in our projects, and import from such a plain JavaScript file without causing an error. If we want to mix and match TypeScript and JavaScript files, that's possible with this option. Then we get a couple of options which are not that important for us here. Very important though is the strict option. This is set to true, which means that we have the strictest possible settings for this project. And that, for example, influences that we can't have implicitly any values, as we had it with parameters in the past. If we had a parameter somewhere where we didn't set the type, for example, if I remove the type here, then we get those squiggly lines that it implicitly has the any type. And with strict mode, that's not allowed. We have to explicitly set a type in places where TypeScript is not able to infer it. Strict true also unlocks a couple of other strict features, but this non-implicit any type feature is the most important one for us here. Now then we got more options which are not that important for us here. The JSX option is interesting. It basically controls that JSX code is supported and which output code should be generated. And in general, the default settings which we got here, of course, should work, and you should only change them if you know what you're doing. But you can configure TypeScript's behavior here, and you now have a rough understanding of what this file does. Again, you can always dive into the official docs to learn more about those different settings. This course section here is entirely optional, and you can skip this course section and just mark the individual lectures as completed manually if you want to get that completion certificate at the end, if you did go through the entire rest of this course. Because this course section is about React hooks and exploring React hooks. And if you reached this section after going through the rest of the course, you already learned about all those React hooks, how to build custom hooks, and so on. But this section can serve as a great summary section where you again learn about all those key React hooks and how they work in a couple of hours. And in addition, this section is absolutely for you if you completed my old React course, which started with class-based components for state management, so which did not focus on functional components only, or if you completed some other React course or you went through some other React resource which focused on class-based components and you now want to upgrade your React knowledge and you want to learn all about this amazing React hooks feature which React has to offer. Now for this in this course section, I am of course going to explain what exactly React hooks are, why we have them, which problem they solve, and most importantly, how you can use them. And we're going to dive into the different built-in React hooks React has to offer with functional components, of course, since React hooks are limited to functional components. And we're also going to explore the rules of hooks and how you can build custom hooks. So what are React hooks? If you completed this course before I updated it entirely in 2021, or if you finished some other React resource which did not focus on React hooks and functional components, then you don't know about React hooks, but you do know that there are two main ways of building React components. You can build functional components and you can build class-based components. Now, functional components, historically, without React hooks, were limited to outputting content. You could only use functional components for outputting something. They received props and returned JSX. You were not able to change some internal state in those components in the past. Nowadays you are, but in the past this was not possible. That's why we had two different ways of building components. That's why we had class-based components. And we still have those, by the way. You can still write class-based components, and there's nothing wrong with that. But with React hooks, you actually don't need to create class-based components anymore. But in the past, we had to do that because in the past, only class-based components could contain and manage state, which of course is important to change what your application shows on the screen. But the downside with class-based components was and is that they have more overhead, more extra code than functional components. Functional components are very lean. It's just a function that returns JSX. Class-based components need a constructor maybe to initialize a state. You might add extra lifecycle methods, and therefore class-based components can quickly grow in size. They also suffer from other potential problems, but they definitely are more code to write than functional components. But because class-based components were the only kind of components that could manage state, you had to convert functional components to class-based components if you wanted to manage state or if you wanted to add lifecycle methods prior to React 16.8. But with the release of React version 16.8 in 2018, React hooks were introduced. And React hooks is a feature that now allows you to manage state in functional components and to kind of add lifecycle methods there as well. And I'm going to teach you all about React hooks throughout this module. But as mentioned, of course, if you already know what React hooks are because you completed the most recent version of this course, up to this point, then you don't need this module. Now, React hooks are just special JavaScript functions provided by React.js, though you can also write your own hooks, and you will see this as well in this course section. And these special functions can only be called and used, therefore, in functional components. You can't use React hooks in class-based components. Now, to mark those special functions so that you don't accidentally use them in the wrong place, they all start with the use word. The built-in React hooks are all called useState, useEffect, useRef, and so on. And if you build your own custom hooks, they also have to be named like this, as you will see later in this module. Now, these extra functions, when called in your functional components, then add extra functionality, extra capabilities to your functional components. For example, with the useState hook, you can add the functionality to manage and change state in a functional component. And that's why React hooks are amazing, because with them, you don't need to switch between functional and class-based components. Instead, you can build your entire React application with functional components only. And in this course section, we're now going to dive into all those built-in hooks, how to use them and how they work, and we're also going to learn how to write our own custom hooks. Now, to get started with hooks, you find an extra project attached to this lecture here, which acts as a starting project for this course section. It's this starting project which we're going to use to dive into the different hooks, to use them, to learn how they work, and to then also write our own custom hooks. So this is a simple React project created with Create React App. It runs on a version later than 16.8, and that's important. You need to have React 16.8 or higher, otherwise you can't use React hooks. Well, and other than that, there's nothing special in here. It's just a normal React application with a couple of components I already built for you. So let me quickly walk you through what we have here before we start working with that and before we start using React hooks. We have our index.js file, which is pretty trivial. I'm importing index CSS, which sets up some global styling, imports a font, sets up some, well, global styling for the font, for buttons, and that's it. And then here I render the app component, which is living in the app.js file. It's a very simple component, doesn't do much. It will do more later, which is why I have this extra component. But for now, it just returns the ingredients component, which we get from the components folder, there from the ingredients subfolder, and then from the ingredients.js file, which would be this file here. Now in there, I in the end have a div. I render an ingredient form component, which lives in the ingredient form.js file. And then I have a section where I render the search component, which unsurprisingly lives in the search.js file. And if we have a look at the ingredient form, then we see that this is a component that uses a custom card component, which lives in the UI folder. We'll have a look at that folder in a second. And in the ingredient form here, I do have my form here. I have a section, which is a normal form with a couple of inputs, 2 inputs to be precise, for a title and amount, with a button. And I'm also using React Memo here to wrap this component to avoid unnecessary re-renders, so that this component only re-renders when the props it depends on changed, and not always when the parent component changed. So not always when ingredients changed, but only when ingredients changed, and we're passing new props to ingredient form, which right now we're never doing. So right now ingredient form won't re-render when ingredients re-renders. That's just a tiny side note. You'll learn about React Memo earlier in the course in the component deep dive module. Now that's the ingredients folder. Well, almost. We also have ingredient list. There I'm just rendering a list of ingredients. Right now we're not getting any ingredients from anywhere, and therefore, well, we're not using this. We'll use it throughout this module, of course. And in the search.js file, well, there I also use React Memo for the same reasons I do it in the ingredient form, and I just output a search box, this input here in a card. And that's, of course, this box here at the bottom. I got a couple of CSS files there too. You can, of course, go through them if you want. Just a bit of styling to make this all look good so that we have a nice looking app to work with. Now in the UI folder, I prepared a couple of UI components like the card here, which simply wraps whatever we pass between its opening and closing tag and gives it this nice card look with these styles here. I got the error modal, which I'm right now not using, but which we will use throughout this module. And this is just using React fragment. Then I render a backdrop there and the modal itself, where we can output a custom content, like a custom error message. We got a button to close that. Clicking the backdrop should also close the modal, but it will be up to us to wire up this logic. I'm also using React Memo here, and here I got some styles for that modal. And I have a loading indicator, which is just a spinner, which we can render to indicate that we're, well, loading data. So that is what we have here. These are the components I'm giving you, and right now this app doesn't do anything. You can enter something here, but hitting this button won't do anything, because now it's up to us to wire this up. And if you watch closely, you'll see that all these components here, they're all functional components. There's not a single class-based component in there. And we'll leave these components as functional components. So we'll not change that because, as you will now learn in this module, we can build an entire React app with just functional components with the help of hooks. Therefore, let's dive right in and let's learn about our first hook, the most important hook probably. Now, it is worth mentioning that I also touched on hooks throughout this course. So some of the hooks I'll dive deeper into in this module are hooks I already mentioned throughout this course, but then I always mentioned that we will dive into it later. Well, now is that later. Now we will dive in more detail. And let's start with the ingredient form.js file. There we have a couple of inputs. And one thing we typically would do here is that we bind the input the user enters to some state property, and we update that state on every keystroke and then send the value back into the input, right? That's that two-way binding you'll learn about in this course, and we did this multiple times when we work with inputs. I want to do the same here because ultimately it all starts in this app here with us gathering the user input so that we can make this add ingredient button work, so that we do something useful when this button is pressed. Now, if you wouldn't know about hooks, or if you would use React 16.7 or earlier, then you would have to transform this to a class-based component and use state and set state there. Now with React hooks, you don't have to do that. Instead, you can import something new from React by not just importing the default export, which is that React object, but by importing a named export, and that is use state. I mentioned that all these hooks start with use, and then they have various names. So here it's the use state hook. And this is a crucial, probably the core hook provided by React. It allows us to manage state in functional components. It works a bit different than state and class-based components, but we'll see the difference in a second. So how do we use it then? Well, we go into our functional component, and that's important. You have to use it in your functional component body. So let's say here, and we call use state. Now that alone doesn't do much though. Use state can be initialized with a default state, and that state can be anything. Can be an object, can be an array, can be a number, can be a string, a boolean, can be any value. It doesn't have to be an object, it can be any value. So here we could create a new state that should manage the input for the title and the amount. So let's create an object here. Again, doesn't have to be an object. I choose to use one here because I have two values which I want to manage. And that would be title, and initially it's an empty string, and amount. And let's set amount also to an empty string. Now, you could argue that this should store a number, and hence you want to set it to 0 or something like that initially. But actually, managing this will be easier if we set it to a string, because input elements, the values of input elements, are always strings. Even if it's of type number, we'll always get a string. If we would want to work with a number in our app, then we would simply have to convert that value whenever we use it. But when we fetch it, when we manage it, managing it as a string avoids some strange side effects where we might not be able to edit this value in the way we want to. So both values here are strings. And now, of course, the question is, what does this get us? What does this use state call do? Because just that alone, of course, won't set up a connection between, well, our state we're trying to manage here and our inputs. Now, use state actually returns something. This here might be complicated to read, but this in the end describes how this function, the use state function, is defined. And after this colon here, we see the return value. And we see that the return value actually is an array, and it's an array with exactly 2 elements. And that's important. Use state, this built-in hook, always returns an array with exactly 2 elements. The first element then always is your current state snapshot. And whenever your state updates, to which I'll come back in a second, this component will rebuild, so this component function is re-executed. And use state, of course, therefore also is executed again, but React internally saves that you already configured a state with the help of use state for this component and will not reinitialize it, but instead use state manages this state detached from your component, so to say, so independent from your component, so that the state survives re-renders of this component, so that the state survives when this component function gets executed again. And therefore, use state, this first value which is returned here, is your current state snapshot, and it's the current state snapshot for this re-render cycle of this component. This means that when you update the state, you'll get the updated state here. So you get back an array in use state, and that array has 2 elements, and the first element is always your current state snapshot, either the initial state, or if you changed it, the updated state. That, of course, leads us to the question, how do you change the state? How do you update the state? And that's where the second element in this array is helpful. As I mentioned, this array always has exactly 2 elements. First element is your current state snapshot. Second element is a function that allows you to update your current state. So this here, this strange looking thing, this dispatch thing here, that's a function that will always be a function which you can call with a new data for your state to update that state. So therefore, what we can do here, we can store this array with exactly 2 elements in a variable, or in a constant here actually, because for this render cycle, it's not going to change, hence it can be a constant. And I'll name this input state. The name is totally up to you, but in the end here, we manage everything we need to manage for our, well, state for these 2 inputs here, hence the name input state. Now that we store our array with the state snapshot and the state updating function here in input state, we can connect it to our inputs. And there I'll use a similar approach I showed you earlier in the course with 2-way binding in the end, where we bind the value of this input to the current state snapshot so that we pass the current state back into the input, so to say. And I do this by simply referring to input state and then the first element. Remember, input state is an array with exactly 2 elements, and the first element at index 0 will be your current state snapshot. So that will be, well, what we want to feed back into the input. Now, of course, our state is an object though, not a string. So for the title input here, I want to access input state 0.title, because our state is an object with a title and an amount property to manage, well, input for these 2 inputs. And for the amount input here, I'll therefore set value equal to input state for the first element, which is our current state snapshot amount. Now we feed the current state for the respective inputs back into the input elements. Of course, we also want to update the state when we type into these inputs though. And for that, just as we do it always, also in class-based components, we can listen to the onChange event, which fires for every keystroke. And there we get this event object. So here I'm executing an anonymous function in the end. We get the event object automatically, and we want to update our state. And as I mentioned, we do this with the second element in this array use state gives us back. So here we access the element at index 1, which is the second element. And this is a function. So we can execute it as a function by adding parentheses here. Now here I'm on the title input, so I want to update the title. So what we do here is we simply pass a new object to input state to update our current state with this new state object. And there we can set the title property to event target value, because event, that's the change event, the target is our input field, and the value property then holds the value the user entered. So let me reformat that, and now repeat that same logic here for the amount input down there. So there we also add on change, but of course we update the amount field. So with that, if we save this and we go back to our program here, and now I enter apples 5 here, well, we see this generally works. We can type here, which is a good sign, which means we're feeding the state correctly back into these inputs and so on. But we also get a warning that a component is changing a controlled input of type number to be uncontrolled. So what's the reason for this warning? What's wrong about the way we're saving our state here? And why am I getting a warning about the input of type number, which is our second input, if I type into the first one? The way we use state is correct. We're passing in a state, we're getting back this array which we're storing in this constant. But the way we update the state is not correct. There's one super important difference when you compare use state and how you work with state and functional components to how you worked with set state and the state and class-based components. There's an important difference between these two concepts. For use state, as I mentioned earlier, you can manage any state. It doesn't have to be an object. You could just manage some text here. But here I decided to work with an object because I have, well, two types of state or two input fields which I want to manage. Now in class-based components, you always had to use an object, but there, whenever you call set state, whichever object you passed into set state was merged with your existing state. So there, if we passed in an object with a title property, it would be merged with our current state, and the amount property would not be lost, but simply the title property would be updated and all old state would be kept. With use state, that's different. This updating function, this second element of our array, does update the state, but it does so by replacing the current state with this, which in this case means if we type into the title, our new state simply is an object which only has a title property, and we drop the amount property. Our new state is an object that simply doesn't have an amount property anymore. That's why I'm getting this warning that the input of type number is uncontrolled. That's our second input, and I'm getting a warning regarding that input when we type into the first input, because the second input, this amount input here, which is of type number, this of course refers to the amount property in our state. Now if we type into the first input, we update this state to now be an object which only has a title property. Hence the property we're trying to access on the second input, the amount property, simply doesn't exist anymore, and that's exactly what's causing this error. The solution is simple. When we update the state, we have to ensure that we don't lose any old data. That's now our responsibility because React doesn't merge that automatically for us. And whilst this might sound like a bad change, whilst this might sound like it should do that for us, you'll later learn why React actually doesn't merge this for us anymore. Because now we actually have more flexibility regarding how we manage state. If we decide to manage some object state though, which very well might be the case in many situations, we have to ensure that whenever we update it, we don't lose any old data. So when we update the title here, we also have to set the amount property and simply set it to our, well, current amount state, so to the unchanged amount state, by accessing input state 0, so the current state snapshot.amount, for example. On the other hand, when we update the amount, we should also make sure that we don't lose the title by also setting this to input state 0.title. Now if you do that, if you make sure that when you update the state, you don't lose any information, now if I type here, you see I get no warnings anymore. And of course, this button doesn't do anything because we haven't connected it anymore, but these inputs are now working correctly. Nonetheless, our code here, the updating code, is not 100% correct yet. Reason for that is that I'm accessing the current state snapshot on the first array element, and of course that does hold the current state snapshot for this render cycle of the component. But the way React updates the state, we are not having a 100% guarantee here that our current state snapshot actually is the latest state we committed. And this might sound strange, but due to the way React re-renders components upon state updates and so on, you could theoretically have a case where there's a lot going on your page, let's say a lot of animations or a lot of stuff, that React decides to defer a state update until there's less work going on, and therefore a user might be typing here into the title input before the latest amount input, because the user also typed in the amount input field a second ago, before that state change has been rendered to the screen. Now, it's very unlikely for this to happen, and in this simple application here, it will never happen actually. But in more complex apps, you could have a case where you're changing some state and your latest state change hasn't been committed yet, hasn't been rendered to the screen yet. Hence, if you have a new state change that also depends on your latest state snapshot, then you don't have a guarantee that this state snapshot has already been, well, committed or created, and therefore this here, accessing our latest state value like this is not the ideal way. Instead, this updating function, so this function stored as a second element in your array, has an alternative form which you can use. Instead of just passing a value to that update function, so to that function that sets a new state, you can also pass a function to that function, an anonymous function, for example, but it could of course also be a named one. And if you pass a function here, which of course has to return your new state value in the end, and I'm wrapping it at brackets here so that I can use this inline notation here, this inline arrow function notation, that after the arrow, this is the value we're returning, and we're returning an object here without the extra brackets. This would be treated as the function body, and this would simply be an incorrect function body. Now we indicate to JavaScript that this here is our function body, and this is actually the return value, which is just an object. So now we're returning that object, but in this function which we're passing to this setState function here, so to say, there we get an argument passed in automatically by React. And that's our previous input state, or whatever you want to call it. And we can omit these brackets here. So here, this function will actually tell React that we want to get the latest state that we set, even if it hasn't been fully committed yet for this render cycle. So now previous input state allows us to access this previous input state like this. And the difference to using input state 0 is that we're now not using the latest state which has been fully committed and which is used in this render cycle of this component, but that we're using the latest state we set with an updating function, no matter if React already recreated the function or not based on that last update. So now here we have the guarantee that we get the latest state at all times. And that's of course what we want here. And here I'm missing an extra bracket, by the way, to close that input state 1 function. So now this is the approach I also want to use down there for the amount input. We get our previous input state, and then here we're returning a JavaScript object, and in that object I can use that previous input state to set the title or the amount. Now with that, if we save that and we go back, you'll actually notice a strange behavior though. If you start typing, you'll get an error. And that error tells you that you reused an event, essentially. Now, the problem here is that when we're passing a function to this function here, to this setState function in the end, then we're having this anonymous function here, and that's a closure. So that's simply a function that closes over surrounding values. And in this case, it closes over our event here. The event is fed into this onChange anonymous function, and in that function which we have here, upon a change, we're calling the setState function, so we're calling a function, but then I'm also defining yet another nested function here. So we have function 1, which is our event function, and function 2, which is our updating function. Now the problem with that is that if in this inner function here, I use something from the outer function, which I'm using the event, then this event will be locked in for the first keystroke, essentially, which means that for subsequent keystrokes, we don't use the new keystroke event, but the previous one, which of course is then reused and which causes this error. Now, normally that wouldn't be a problem, of course, because yes, this inner function, this state updating function is a closure, and therefore it closes over the event object, which means it saves this event object for its execution so that when this inner state updating function runs, which happens asynchronously, we're guaranteed to use the event that was triggered for that keystroke, so that was created for that keystroke. The problem with events, and that's not really exclusive to events in React, just is that React events are not the native DOM events, but special synthetic events created by React, which basically replicate the native DOM events you would normally get, but React adds a special factor to that. It pulls these event objects, which simply means it reuses event objects. So instead of creating a new event object for every keystroke, it instead reuses the previous object. And the consequence of this is that for the second keystroke, since we have a closure and we locked in the event for the first keystroke, for the second keystroke, we still reuse that same object we had for the first keystroke. And that simply is the problem here. We're reusing the wrong event object because of the way React handles event objects. Now, I'm aware of this sounding very confusing. In the end, this is really a special case because of the way React handles these event objects. The solution is that outside of this setState function, we create a constant, for example, which we here on the title could call new title. And there I store event target value. Now this will be recreated whenever we're typing. And now we need a real function body though. So we need to wrap this into curly braces because now we actually have more than one line. We're not just returning something. We're not just executing one expression, but we have two statements here. So now here I'm storing the new title for every keystroke. And now this here, this setState function with this nested inner function can use new title. And this will therefore now close over this new extracted title for every keystroke instead of using that same event all the time, that same event object. Of course, we do the same for the amount. There, we now need curly braces around this entire function expression here. Then we get our new amount from event target, not title, but value here. And the amount now is simply new amount. Again, simply because we're using a closure here and we want to make sure that we're generating a new amount for every keystroke, and then this will automatically be considered by this inner function instead of reusing that same event object all the time. Now with that, we can save this, go back, and now start typing here, and that now all works. Now let me get rid of that dummy title output, and let's work on the overall syntax we're using here. Thus far, we're storing this array we're getting back in input state. And we can absolutely do that, but it means that we have to use input state 0 if we want to get the values, and input state 1 if we want to get the function to update the values. Of course, we can do that, but it's a bit of a hard to understand syntax. For example, that this is a function is not immediately obvious. We can use a modern JavaScript syntax to make that easier to understand. We can use a feature called array destructuring. How does it work? It allows you to pull elements out of an array and store them in separate variables. So here where you know that you get an array with exactly 2 elements, you can add square brackets on the left side of the equal sign. So by adding them on the left side, you're not using them to create a new array or anything like that. That would be the case if you use them on the right side. But instead, this now is a JavaScript syntax that allows you to pull elements out of that array and store them in variables. And you add as many variables here, variable names of your choice here between the square brackets on the left side as you have elements in the array. So here we have always exactly 2 elements. So we can add 2 values here with any names you want. The first element will be our data. So here that could be input state. And the second will be a function to update that data. Typically you name this set input state or set whatever you named your data because you're, well, setting this to a new value. You're not merging it, you're not updating it, you're overriding it. So you're setting some new data. So now we're using array destructuring, and our input state will be our data, and that will be the function to update the data. That's way easier to use now. We can use input state here without the 0 to work with our data, and we use set input state instead of input state 1 to update our data. And I think that's much easier to read and to understand than it was before, to be honest. Now, if we save that, it works just as before, but now we have a syntax that's way easier to understand. A side note, of course, this button still doesn't do anything because we haven't hooked up any logic, but we'll do that step by step. So this is the syntax we'll actually use, and the syntax you see in the official docs, you'll see throughout the rest of this course, and the syntax which is much better to use when working with the use state hook. I hope it's clear how the use state hook generally works now. One thing which I'm not liking too much, however, is how complex it is for us to update this state. Of course, this is not a complex state here. It only has two properties, only two things, title and amount. But still, we have to ensure that when we update the title, we don't lose the old amount, and when we update the amount, we don't lose the old title. Now, obviously, that's doable here, but imagine that we had a longer form here. You would have to write a lot of code just to always save all the old state when you update something new. So whilst you can of course manage state that is an object, and whilst this often might make sense, you should also be aware that there is a huge important difference when you compare the state added by useState to the state you used in class-based components. In class-based components, state had to be an object and React merged it for you automatically. In functional components with useState, state doesn't have to be an object and React doesn't merge it for you. But what you can do is you can register multiple states. So what would make much more sense here is that you don't have an object, but let's say just a string here, and that this is your title, maybe your entered title to make it really clear what you are saving here, and then you have the set entered title function. And then we add another state here, which is our entered amount, and we have set entered amount here. And that's use state with an empty string initially too. So now I have two states which are both managed independently by React for this component, which are stored in different variables and which I can set with different functions. So now I don't have to manually merge anything because these are managed independently. So if I update one, the other one will be kept around and vice versa. Because as I mentioned already, these states survive re-render cycles. So they survive updates of other states. But we don't have to merge it manually because it's now an object anymore, but instead we have two separate strings which we're managing as state. So now here, when we're working with the title, we could just output the entered title here. And here we're not calling set input state, but all we're calling, and that's so much easier, is simply set entered title. And we can pass in the new title here. However, we no longer have to store this in a separate variable. We don't have that closure problem anymore because there is no inner closure in this function anymore. Instead, we just call set entered title and set this to event target value. We don't have to manage anything, merge anything, because we manage this as two separate states. So the same here for on change on the amount. We just call set entered amount and set this to event target value. It's as easy as that. And if we save this, we still have the same behavior as before, but now in a much easier way. And this is actually my recommended way of doing this. Split your state into multiple states. That is how use state is intended to be used. And only use objects or arrays as values for your state if you really have data that changes together or where you need to change multiple things together. Otherwise, manage your state independently. It's so much easier. It's so much easier to write. You don't have to merge anything manually. It's a breeze to use it, as you can see. So we spend a lot of time on use state, but it is the most important state React offers. React offers more hooks than just use state, but it really is an important hook. If we analyze it, then it's clear that the idea behind use state is that we can manage state in a functional component by calling use state with some initial state, which we can set up. You don't have to pass an initial state, by the way. If you want to have null or undefined as initial state, you simply pass no argument at all to use state. And this creates a state which is managed by React behind the scenes and which survives re-render cycles. And what you get back by useState is that array with exactly two elements. A pointer at your state, that's the first element, and a state update function, that's the second element. This is how useState works. Now there are two important rules when you work with hooks, with any hooks, not just with useState, but also with any other hook you'll learn about in this module. For one, you must only use the hooks in functional components or inside of other custom hooks, which we'll build later. The second important rule is that you always have to use the hooks on the root level in your component. Now, what does this mean? It means that you can't use a hook in some nested function. Here I have the submit handler, which isn't doing much right now, but we can't use useState in here, for example. And actually, we already get an error here because modern React projects already have code checks which determine that this here is using a hook in something that's neither a React function component nor another hook, and therefore it's not allowed to use it here. You're also not allowed to, for example, use a hook in some if statement. So if you had some condition and then you want to create some state, that's also not allowed. Here, unfortunately, my project doesn't determine that this is wrong, but this is simply not allowed. You must not use your hooks in a for loop, in an if statement, or in another function. Use it on the root level of your functional component or on the root level of other hooks. So that was a lot of talking about useState, but of course, as I said, it is important. But now let's continue and let's make sure that we actually can press that button and we do add this ingredient somewhere. So for that, in the submit handler, I want to submit my data. Now, let's say we're managing our ingredients not in the ingredient form, but in the ingredients.js file, in the ingredients component there. And just because I'm seeing it, here I'm creating that component with the function keyword like this. In ingredient form, I'm creating it like this, storing it in a const, and then by using an arrow function on the right side of the const, it's totally up to you what you want to use. Both creates valid functional components. Both has nothing to do with React hooks. So back in the ingredients function here, which we, just to avoid confusion, could also write like this. In this ingredients function, I have the ingredients form, and here in this functional component, I want to manage my ingredients. I guess that makes a lot of sense because there I will also later output the list of ingredients. So it is a component that has access to both our input and to our output later. So I want to manage the ingredients in there. This of course means that we want to add useState here because our list of ingredients, our array of ingredients, of course, will be some state that should survive re-render cycles that will change over time and where every change should re-render this so that once we do add a list to output our ingredients, well, we can actually see some change there when we add an ingredient. So in the ingredients functional component, I'll again use array destructuring to manage my ingredients and to have a set ingredients function. And in there, with useState, I start with an empty array. Here I use an array because ingredients, of course, will be a list of ingredients, and we will always update that list as a whole when we add an ingredient or when we later delete an ingredient and so on. So we got our ingredients. Now we can also import the ingredient list component from the ingredient list.js file, which I prepared for you. You can just add it here, ingredient list. And ingredient list, this component actually takes a property, ingredient, which is then output. And there, besides the title and the amount, I also want to have an ID. That ID is then used as a key. So in ingredients.js, I want to pass ingredients, this prop, which ingredient list expects, to ingredient list. And the value here will be my ingredients up there. Now, can be confusing because it's always the same name. So maybe we name this up here user ingredients and name this here set user ingredients. You don't have to rename this just because you renamed that, but to really make it clear that these two belong together, I like to have the same names just with a set in front of our updating function here. And now user ingredients is what I pass here to the ingredients prop. So I hope this is clear which ingredients is what. That's the prop of the ingredient list. So we're passing this in here. Now the ingredient form should be able to add a new ingredient. So let's define a function here in the ingredients functional component, add ingredient or add ingredient handler maybe, and that's a function which will ultimately receive a new ingredient here, which should store this in our ingredients array. So here the idea will be to call set user ingredients, and now important, we'll need to update the existing list of ingredients and add a new one. Now that means we depend on the current state, and therefore it's best if we use the function form where we're guaranteed to get the latest state. So we get our previous ingredients here, our old array basically, the current state, the most recent state of this list here, and we return a new array where I use all previous ingredients. This is a spread operator taking all elements of our old array and adding them as elements to this new array, which I'm constructing with the square brackets. And then I add one new element here, and that's the ingredient we're getting. Now important, the ingredient we're getting from the ingredient form will have a title and an amount, but probably not an ID, because the ID should be somehow auto-generated. Now I'll later use a web server which does this for us. For now, let's create a new object here with an ID, which for now can just be mof random to string. And that's not truly a unique ID, but unique enough for our cases here. It's a good dummy ID. And then I, of course, want to keep my title and my amount from ingredient. And we can again use the spread operator on ingredient now. So on this argument we're getting, because this argument will be an object, let's say, the spread operator then takes all key value pairs from that object and adds them as key value pairs to this new object. So now we're adding a new object with an ID, title, and amount to our list of ingredients here. That's the add ingredient handler. Now we need to pass a pointer at that add ingredient handler to the ingredient form, because that is where we want to trigger the addition of an ingredient, right? Because that's where we have our button that, well, submits this form. This button is of type submit, therefore it triggers the on submit here and the submit handler. And in here, I now want to, well, call something which I'm getting from the ingredients component. So let's say we pass in a prop which could be named on add ingredient, and the name is totally up to you. And there we point at the add ingredient handler. So this is how you pass function references down to components, right? You learned that throughout the course. Hasn't changed, has nothing to do with React hooks. So now we'll have an on add ingredient prop in the ingredient form, and that will have a pointer at this function. So in the ingredient form, in the submit handler, we can call props on add ingredient as a function, because again, this will hold a pointer at that function in the ingredients.js file. And there I will pass in an object, because here I expect to get ingredient as an object. I pass in an object which has a title and amount. So here, title is my entered title, and amount is my entered amount. Just like that. So this is getting sent to the add ingredient handler. This will add a new ingredient and update our ingredients array. And we're passing this ingredients array to the ingredient list. So now our hope would be to see changes in that list when we add an ingredient. So here's our ingredient list. Now let's add 5 apples, and we're getting an error. Now this error is coming from the ingredient list. There I'm registering a click on the ingredients to bind to on remove item. That is something we'll need later to remove ingredients. So for now, let's simply go to the ingredient list component we're using in the ingredients component and pass the on remove list prop in there. And this should point at a function which for now simply doesn't do anything, just so that the ingredient list does receive a function and bind therefore does work. So with that, let's try this again. Let's add 5 apples, and here they are. Now clicking on them doesn't do anything for now, but we can now add our ingredients. So enough about use state for now. Let's now send this to a web server so that we can also dive into some other hooks, for example, hooks that help us replace class lifecycle methods. For this, I'll again use Firebase as a dummy backend. We'll just create a new project here, React hooks update. You can name this whatever you want. Create this project here, and I'm just using Firebase here because I don't want to write any complex server-side logic. I just want to have a server we can talk to, which automatically has a database attached to it, so that the data also gets stored there. So let's wait for this to finish and then dive into this newly created project. And in there, go to database, and now make sure to set up a new database there. And don't use Firestore, but scroll down a bit and use the real-time database. Click on Create Database and start in test mode, which means that everyone is allowed to read and write. Because here we'll just use this as a dummy backend. This is the URL you can now send requests to store data in that database. And to send requests, we can use Axios, as we did in this course, or we use the built-in fetch API, which is built right into JavaScript. It's totally up to you what you want to do. To mix things up, I'll use the fetch API built into JavaScript. So when we're adding an ingredient, besides updating this locally, I also want to send an HTTP request. And I do this by calling fetch. And again, this is a function the browser understands. It's not a React function, not a React hooks function. It's a browser function, so to say. The fetch API, as it's called, is built into modern browsers. This will send a behind-the-scenes HTTP request. And fetch takes a URL you want to send the request to, which is a string. In our case, that's not just this URL, but let's say we want to store the ingredients in an ingredients node, and Firebase then also requires a .json at the end. That's just a Firebase thing, nothing to do with React, nothing to do with React hooks. So this is where we want to send our data to, and you gotta know that fetch by default will send a GET request. Firebase wants a POST request though, if we want to store data. Hence, we pass a second argument to fetch, and that's an object that allows us to configure this request. And on this object, we can set the method property to post. Default is get, and you never need to set that, but we want to set this to post. You then also can add a body property to define what you want to send. And that has to be JSON data, which means you can use JSON, which is another thing built into the browser. It's a class in the end built into browsers, which has a stringify method. This will take a JavaScript object or array and convert it into valid JSON format. It's a convenience feature built into the browser. Also has nothing to do with React. So here, I want to pass that ingredient we're getting. Basically, ingredient like this without an ID, because now Firebase will generate an ID for us, so we don't have to do that manually. Now, one other thing you also need to set now is headers. This allows us to set our own headers, and that in turn is a JavaScript object, a nested JavaScript object. And there you can set headers you want to append to this request, and there Firebase expects the content type header and set this to application JSON. With Axios, we didn't have to do that because Axios did it for us. Fetch doesn't do it for us, just as it doesn't convert data to JSON for us. So we have to do the data conversion manually. We have to add this header manually to inform Firebase that we got some incoming JSON data. And fetch will now return a promise, which will eventually resolve once this request successfully was sent, or of course once it fails. That could be an option too. Now, let's say we want to update our data locally when this promise is done. Then we can use then here and get the response inside of this nested function. And in there, I then want to update my ingredients, because as you learned throughout this course with promises, the thing is that the function you're passing to then will not execute immediately when this gets executed, but only when this request is done in this case. So then I want to update my ingredient. You could also use async await here if you wanted to, of course, but I will stick to this then approach because I think it makes it really clear that this executes at a later point of time. Now, the good thing is here, by the way, this response actually will get some data back from Firebase which contains that automatically generated ID. Response itself, however, is a more complex object. We're interested in the body of that response, and you get that by calling the JSON method there. This will extract the body and convert it from JSON to normal JavaScript code. However, this also returns a promise, so we'll actually return response JSON here and move this code into another then block, which I change here, which will be my body or my response data. I get this in this function here, which I pass to the second then block, which executes once this body has been parsed. And now response data will be an object which has a name property which contains this automatically generated ID. That's just how Firebase works. So here we can now set ID equal to response data.name. Again, that we can access .name here has nothing to do with React or with the fetch API. That's just Firebase. It returns some data, which in the end is a JavaScript object, which has a name property, and that name property will have that unique ID which was generated by Firebase. If you're using a different API, this will probably not be named, but for Firebase it is. And now we're creating our ingredient locally, and we're updating it there based on our previous ingredients with that ingredient we got here and with our name, with our ID generated by Firebase. So let's see whether that works. Let's save that. Let's go back to our application. Let's add 5 apples. And you see it takes a while until it appears here, which makes sense because we're sending a HTTP request. And then here we indeed have ingredients added, and this is this unique ID. And if I add bananas, 10, again, it takes a while, not that long because Firebase is very quick, but a short while. And we also see it here. So that's working. As soon as we reload, though, all data is lost. So the next goal is to fetch our data whenever we reload. So whenever our app starts or whenever ingredients gets rendered, so to say. And for that, we normally would have used lifecycle methods. We would have used component did mount. And we can't use that anymore here, unless we transform this to a class-based component, of course, which is not the goal. But React hooks got us covered. So we want to fetch all ingredients whenever this ingredients component gets rendered in the end. Now, as I mentioned at the end of the last lecture, normally we would have used component did mount for that to fetch something when this component mounts. But this is now not an option anymore, unless we transform this to a class-based component. But there is another hook that helps us with that. It's the use effect hook. How does it work? Just like use state, the same rules apply. You can only use it in functional components or other hooks, and you have to use it on the root level. So let's maybe use it here. Use effect. Use effect has the name because it is there for you to manage side effects. And HTTP requests are a typical side effect. Side effect basically means that you have some logic that runs that does affect your application. For example, we are fetching some data here, but it's not getting finished in this current render cycle, or maybe it affects something which is outside of the scope of your JSX code down there. Maybe you're setting the document title, anything like that. So anything you cannot manage with your normal this component is getting rendered flow. Use effect, and that's important, by default gets executed right after, important, after every component render cycle. So after this component has been rendered the first time, the function you pass to use effect, because you have to pass a function there, will get executed. So this runs whenever this component got re-rendered. And that's really important to keep in mind. After and for every render cycle. These are the two important pieces. Not before, not simultaneously, but after and for every render cycle. Now, why do we need use effect though? We could just call fetch to get our data, like this, outside of use effect, right? We could call fetch, point at this URL, it will automatically send a GET request, and indeed, therefore, we will get our data back. And then we can add a then block, we'll get our response, and we can return response JSON to get access to the response body. And we can add another then block, which is our response data. And yes, we also should handle errors, we'll do that later. So here we got our response data. This gets executed when this component renders, and that is what we want, right? When this gets rendered for the first time, we want to fetch this. So here we got our response data, and response data in Firebase case will actually be an object, not an array. So we'll have to transform this. Our loaded ingredients, let's say it's an empty array. That's a helper constant here I'm creating. And then I use a for in loop to go through all my keys in that response data, because again, response data will be an object. Every key will be, and you can basically see that object here, every key will be such a unique ID, and the value for that key will be the actual data for our ingredient. So we'll have that overall object with these ID keys here, and then these nested objects. So here a key will be this unique ID, and the value for response data key will then be our concrete ingredient data. So therefore here I can use loaded ingredients, that array I'm creating here, and push a new ingredient onto it. It's constant, but with push, we're not editing the value stored in loaded ingredients. We're editing the array stored in memory. And if that's not clear to you, attached you find a resource on JavaScript reference and primitive types, which have something to do with that. So here I push a new object onto this loaded ingredient array. The ID is that key, and the title is response data for that key with this dynamic syntax here, dot title, and the amount is response data for that key dot amount. So this is how I load my ingredients, how I transform this object to an array, and once this transformation is done, so after this for loop here, we can of course call set user ingredients and set this equal to the loaded ingredients, so to this array we generated. This approach has one huge issue. If you save this, you actually end up with an infinite loop here. You can see this if you access the network tab. You're sending tons of requests, and therefore I'll quickly comment out this set user ingredients line here so that this reloads and we stop sending this. So why are we entering an infinite loop here if we're fetching data like this? If you fetch data right here in your render function, then whenever ingredients renders, you're sending a HTTP request. And when you then, as a result, after this HTTP request, update your state, what happens if you update your state? Well, the component renders again. So ingredients renders again. And what does this mean? We send another HTTP request. What does this mean? We update the state at some point. What does this mean? We re-render. We send another request. We update the state. We re-render, and so on. So that's the infinite loop. That's why sending this here is not an option. So let's cut this here, and let's instead move it into this useEffect function here. Now if I comment this back in, now we're executing this after every render cycle, but still, by default, for every render cycle. And hence, unsurprisingly, if I save this and we go to the network tab, we still have an infinite loop. So again, let's comment out this here and save this to update our page and stop that loop. So how can we fix that? useEffect actually also takes a second argument. The first argument is this function which it executes after every render cycle. The second argument is an array with the dependencies of your function. And only when such a dependency changed, only then the function will rerun. So this allows you to control how often this function runs. By default, for every render cycle, but you can change this. Now here, we actually have no external dependencies. And with external dependencies, I mean variables or data you're using, which you define in your component outside of the useEffect function. We're not using anything of that. This URL is hard-coded. Response is a variable created here on the fly. Response data, loaded ingredients. It's all created on the fly. Set user ingredients, that's actually a function stored in a variable coming from outside. But that's a special function since it's generated by useState. React automatically creates it such that this function never really changes and doesn't have to be considered as a dependency. So that's an exception because it is a function generated by useState. And therefore, this useEffect function here actually has no external dependencies, and so we can add an empty array. But we have to do that. Omitting it is not an option. Then this runs for every render cycle. If you do add an empty array, though, what happens is that this now runs when this component gets first rendered. So it runs this one time. It's not omitted entirely, but it runs one time, but it never runs thereafter. So with an empty array, it's like component did mount. You can kind of memorize that. With an empty array as a second argument, the function you pass to useEffect is like component did mount. So if we save this, now if we go to the network tab, We see no ongoing requests down there. And we see our data was loaded though. So if I again save this, you see our data gets loaded. So this is now working with the help of useEffect. So we learned about useEffect. Just like with useState, you can have multiple useEffect calls in one and the same component. You can have as many as you want, just as with useState. So here I could have another useEffect call, and in this function I just want to console log rendering ingredients. I'm not specifying a second argument, and therefore this will run for every re-render cycle here. So if I now save this, you see it runs twice. Reason for that simply is this component gets rendered, and then this first effect also executes and goes ahead, fetches data. So that's the first render cycle. And then once this data fetching is done, which happens in the future because it takes a while, only a few milliseconds, but still, then we update the state and hence we re-render this component again. And therefore we have another render cycle. And that's why we see rendering ingredients twice here. So you can have multiple useEffect calls and you can control how they execute with this second argument, with this array. Now, you should configure this array in an honest way though. So you should really specify your dependencies. If you have a dependency, like for example, here I'm outputting user ingredients, then you should specify it. You can of course omit the second argument if you know you want to run this for every re-render cycle. But if you know you only want to run this if this changed, then you should specify that in this case, user ingredients is a dependency of the second effect. And this means that this function here will now only run when user ingredients changed. Right now in this app, that's the same as running it on every render cycle. But if we had something else that could be executed, which also re-renders this, let's say we had some other value we're managing in there, which we can change with a setState call in the end, then this function would only execute if user ingredients changed and not if that other value changed. And we'll see that concept of having arguments here throughout this module because it is very important. So that's useEffect and how you can configure it, or at least the basics about useEffect. But there's more to useEffect than what we see thus far. Let's go to our search component. The search component should be responsible for this input field where we, for example, can enter apples and then we only see, well, the items that match this name. And we're doing a full name search here, so we'll not search for app, but apples gives us all apples, bananas gives us all bananas. That's the idea here. Right now this doesn't work, of course, because the search.js file is pretty empty and has no meaningful logic in there. It's time to now change this with the knowledge we gained thus far. First of all, let's make sure we manage the user input. So we can, add an import to use state here, like that. And then here again use array destructuring to have the entered filter, let's say, and set entered filter. And then use state with an empty string and bind this down there, bind the value to entered filter, and bind on change here to a function that updates set entered filter. We get the event automatically passed in by React in the end. And then we call set entered filter and we set this to event target value. So that's something we did before already. It's just saving the value here. But now the idea is that whenever the user types something here, we try to fetch filtered data from Firebase. How could we make this work? Well, you could register a function for onChange, which basically sends a HTTP request on every keystroke. Would work. Here, however, I'm updating the saved value on every keystroke, and instead what we can do is we can use useEffect here, add it here, and pass in a function that should make that HTTP request. And we simply specify entered filter as a dependency. And this means this function will execute whenever entered filter changed. So it's having the same result, but in my opinion, it's a bit more elegant because we're really embracing the idea of hooks here. We're splitting our logic. This function only updates what the user entered, or only updates the state where we store what the user entered. And then useEffect will automatically execute thereafter and do whatever we want to do for every change. So here I want to send a HTTP request. So I'll go to ingredients.js and basically fetch the logic I have in here for fetching the requests. So let's grab that, copy it, and add it here into useEffect. URL is the same, transformation is the same, but of course in the end I don't call set user ingredients, but instead I want to trigger something in ingredients.js, right? Because that is where we manage our ingredients. That is where we also use the search component. So in the end, we should establish a connection between search and this ingredients component to update the ingredients here whenever we fetch new ingredients in search.js, let's say. Now, of course, typically for that, we would use props. So we can specify, let's say, props onload ingredients. Name is totally up to you. Call this as a function and forward our loaded ingredients like this. So onload ingredients is now a function I expect on my search components. So in the ingredients component, we have to specify this prop on the search component and there forward a pointer at a function that should execute when onload ingredients is called in the search component. We have no such function yet, so let me add a new one, maybe here at the very top. I'll name this filtered ingredients handler or whatever you want to call it. We get our filtered ingredients or whatever you want to call that as an argument. And the idea here is simply that we call set user ingredients and we set this equal to our filtered ingredients because these should already be in the right format. So a very simple function, and I'm passing a pointer at this function to onload ingredients on the search component so that we can call this function from inside the search component. So now back in the search component, we're calling this. Now with that, we have an effect that runs whenever entered filter changes, but now here we're getting a warning. In the end, the problem is that we're relying on props here, but we haven't specified them as a dependency. And that means that if props changed, this component will re-render, but this effect won't rerun because we haven't informed the effect about the fact that props are a dependency. Now you might say, well, I'm only pointing at a function here. That function shouldn't change. So actually that shouldn't rerun if props change. Well, you should never cheat regarding your dependencies. It's a good practice to always be clear about all dependencies you have. And here, props is a dependency, but still we'll have a problem with that. Now this effect will rerun whenever props change. That basically is the case whenever anything passed to this component here changes, or whenever anything in the parent component changes. That's also not what we want. We only want to rerun this function if onload ingredients, so if this function we're pointing at, if that changed. And for that, we can use another modern JavaScript syntax, maybe right here at the very top. We saw array destructuring. There also is a concept called object destructuring. Works in a very similar way. We have curly braces in this case on the left side of the equal sign. On the right side, we have the object, which we want to destructure or from which we want to extract properties. And then here between the curly braces on the left side, you specify the names of the keys in that object, which you want to extract and which you want to store in separate variables. So in my case here, that would be onload ingredients. I know that this will exist as a key in props. I'm calling it here. And now I'm simply pulling that out and storing it in a separate onload ingredients constant. So this is now a separate constant. And here we can just call onload ingredients. And we can specify onload ingredients as a dependency now. And now this will only rerun this effect if exactly this value changed. So if anything else in props changed, this will not rerun. Only if this function changed or if the entered filter changed. In these cases, we'll send a request here. And this request will get our data, then call onload ingredients in the end, and that should set our ingredients here. Now, our request right now, however, is not taking the entered filter into account. It's fetching all ingredients. Of course, it should fetch filtered ingredients instead. Thankfully, Firebase supports filtering. We can append some query params, which I'll store in a separate variable here, to the end of this URL. And I want to have different query params depending on whether we entered something or not. So if entered filter length is equal to 0, then my query param will be nothing. I'll not add any query parameters. So it's just an empty string. Otherwise, it'll be a string for which I use backticks here. So these are not single quotes, but backticks so that we can use string interpolation to dynamically inject values here. And then you should add question mark order by, written like that, equal, double quotes, opening and closing, and between the double quotes, the field for which you want to filter. In our case, that's the title field. Then ampersand equal to, written like that, equal sign, double quotes, opening and closing. And now with string interpolation, which is done with $sign and then opening and closing curly brace, the value entered in entered filter. This sets up query, which is either an empty string or this string here. And this is simply a syntax, a combination of query params understood by Firebase to in the end filter the title field for the value entered here. We have to append this at the end of our request here. So we can simply add plus query here in the end. And that's either that empty string or that valid query setup. Now to make this work, we need to also make a tiny adjustment here on Firebase. Go to rules in your database. Now we need to add an entry here to unlock filtering. Add double quotes here after this read-write thing. And there add ingredients. So basically the name you have as a node here, you're sending your data to. Ingredients. Then the value is another object in the end with opening and closing curly braces. And in there add another string with double quotes, dot index on, which is a command understood by Firebase. And then this is an array, again with a string value in there, which is basically the field name by which you want to be able to filter. So you need to add this setup here to your Firebase rules. With this setup, we can filter for the title. Now we can send requests here. Now a request should be sent whenever we type something here. So let's now save that. Go back to our app. And you see, oh, we seem to be in an infinite loop again here. So to leave it, let's comment out onload ingredients and save this and reload. What's causing this infinite loop? In the end, this infinite loop here is caused by this onload ingredients dependency. This effect, which fetches all our data, will run whenever entered filter or onload ingredients changed. That will be the case for the first time search is rendered, so it will definitely fetch our data whenever search is rendered. But thereafter it will rerun whenever entered filter changes, which we never changed because that would only be the case if you type here, or if onload ingredients changed, which we're extracting from our props. That is the case if the parent component is re-rendered. The parent component is re-rendered because in the end, the first time we loaded data, we were calling onload ingredients, which calls this filtered ingredients handler function. And in there, we're calling set user ingredients, which changes the state, which re-renders this component, which means that here, of course, we're also creating a new filtered ingredients handler function because this entire component reruns. And in the end, this is just a JavaScript function, right? So even these functions you have in there, they still rerun, they're still executed again. In the end, this is just a variable which now receives a new value. Of course, we know it has the same logic as before, but technically it's a new function object in JavaScript. So it's a new object, we pass that to onload ingredients, and since it's a new object inside of the search.js file, this is different to the last time the effect executed, and therefore it will re-execute the effect. Because we re-rendered the parent, all these functions are created new, and, well, we got a different value, we rerun the effect in the search component. To prevent this from happening, we can use another hook provided by React. That's the use callback hook. The use callback hook allows you to wrap one of your functions with it. Let's say this function. So on the right side of the equal sign, you use callback and simply wrap this around your function definition like this. And now you also pass a second argument to use callback. First argument is your function. Second argument also is an array with the dependencies of this function. This function has no dependencies because set user ingredients is this special dependency since it's in the end returned by use state as this updating function by use state. So that's special, and other than that, we have no dependencies here, so we can specify an empty array here. By the way, you could have also passed set user ingredients as a dependency here. It still wouldn't rerun because this never changes. That's guaranteed by React. That's why you can omit it here. You can also specify it. But this will now never rerun, and therefore what React does is it caches your function for you so that it survives re-render cycles, and therefore when this ingredients component re-renders, this specific function is not recreated, so it will not change. So what we pass to the search component to onload ingredients will be the old function, the same function as on the previous render cycle, and therefore in the search component, on the use effect here, on this check, onload ingredients will not have changed, and therefore this effect will not rerun. So now let's comment onload ingredients back in, and if we now save this, we see no infinite loop. Still one extra render cycle, to which I'll come back in a second, but if we have a look at the network tab, no extra requests sent. Only if I type here, we're sending extra requests with every keystroke. We see filtering is also working. For example, if I enter apples, we only see that. If I enter something which makes no sense, we see nothing. For bananas, we see bananas. That's working. We're sending a request with every keystroke, which might not be ideal. And we have an extra render cycle initially. So we should probably fix that. But we certainly have no infinite loop anymore. Before we ensure that we don't send a request with every keystroke, let's ensure we don't have this extra render cycle initially. And this is actually coming from a redundant HTTP request we're sending. If I open my developer tools and there the network tab, if I reload, I get a bunch of requests, but in the end you see there are two requests fetching our ingredients, these two requests. They're both sent to ingredients.js on Firebase. Now why do we have two requests being sent there? Well, because we send one in search.js, here in use effect. When this component gets rendered, this effect executes. That's how effects work. They execute when this component gets rendered, because all these dependencies, of course, have changed compared to the previous render cycle, because there hasn't been a previous render cycle. So this gets recalled. And there, of course, entered filter is empty initially, so we have no filter set. Hence, we fetch all data, and then we call onload ingredients to, well, use these ingredients. And in addition to that, we're also fetching data in the ingredients component. There we also have use effect, which we only execute once when the component loads, but we do that. And there we also fetch ingredients. Now, since we already are guaranteed to fetch ingredients because we're doing that in search, we of course don't need that extra use effect thing here in the ingredients component. So we can get rid of that because we are fetching ingredients with search component. So with that, we're still loading it, but now we got rid of the extra render cycle. Now let's tackle the problem, kind of a problem I guess, that we're sending a request for every keystroke. We might not want to do that because we're spamming our server with requests if we do that. So would probably be better if we set some timer, and if the timer expired, we check if the current input in this, well, input here, is the same as at the beginning of the timer, and only if it's the same we know that there has been a pause and the user paused typing, and therefore we probably want to send a request. Not clear what I mean? Well, let me show you. Here's our effect, and in the end, here we're fetching data. Now at the beginning of the effect, I'll now actually use setTimeout, which is a normal JavaScript function, has nothing to do with hooks of course, to set a timer. And let's say the timer is 500 milliseconds, and you can use any value you want. Now I want to wait for the user to pause typing for 500 milliseconds, and only if that happened, I want to send a request. So in this anonymous function I'm passing here as a first argument to setTimeout, which is the function that executes after 500 milliseconds, there I want to send that request. So I'll move all that logic for constructing that query and sending that request into that setTimeout function. So that will happen after 500 milliseconds. Right now, of course, we're only deferring this, where we're not really doing anything else. Instead, we'll have to make sure that we also check after these 500 milliseconds, so inside of the function we pass the setTimeout, if entered value, entered filter, is the same as the entered value 500 milliseconds ago. Now, how can we do that? For that, it's important to understand how closures work in JavaScript. Entered filter here will actually be locked in when we set the timer. So it will not be the value the user has entered after this timer expired. It will be the value the user entered when we set this timer. That's important. That's how JavaScript works. So entered filter here will not be the current value the user entered. It will be the old value 500 milliseconds ago. Basically when use effect executed and when we then set the timer therefore. So that's what entered filter will be. It will not be the current input, but the old one, so to say. Now, I also need the current one to compare what's currently in the input with what the user entered 500 milliseconds ago. And only if it's the same, I know, okay, seems to be the value the user wants to go with. At least the user paused typing, so now is the time to send the HTTP request. So we need to compare it, but how do we get the current value? Well, we get that current value with something you also learned about in this course, with a reference. For that, React also has a hook, useRef. This allows us to create a reference simply by calling useRef, and you can store this in a constant, let's say the input ref, just like that. Now you can assign this to a DOM element by simply going to the element, in our case the input here, and there add the ref property, the ref prop, a special prop supported by React, and point at input ref. Now we established a connection between this input here, this input element, and the input ref variable or constant up here. We can now use this here and compare it. Input ref, current is the element. Current is a property the ref simply has, this ref object simply has. This will be an input element, therefore here we can check the value. If that value, and that will be the current value, because input ref is defined outside of the closure, so that's not logged in or anything like that. So that's the current value currently entered in the input. If that's the same as the entered value when we set the timer, then we know the value hasn't changed in between, or at least it's now the same as it was at the beginning of the timer. So it's actually there, and hence I'll cut this one more time. It's actually there inside of this if statement, where we want to construct that query and send the request. Now, one important note here. Input ref, therefore now, of course, also is a dependency of our effect here, because I'm using input ref in the effect. And therefore, let's also add input ref here to make sure that we also rerun the effect if we should change what's stored in input ref. With that, let's save this. And now let me try typing, and that seems to work. I can filter, but we'll see something interesting if we have a look at the network tab. If I clear this, you see as I type, as long as I keep typing, no request is getting sent. Only if I make a short pause, a request is sent off. So if I type apples, it's only sent once I stop typing for 500 milliseconds. We'll have a problem though. Right now, we're not doing this in a perfect way. We're setting the timer, but keep in mind that we set a new timer whenever the effect runs, and the effect still runs in the end whenever our input changes. So we're setting a bunch of timers, which are all managed independently. That's not really what we want here. Instead of setting a timer for every effect, therefore having multiple timers in the end for every keystroke, we want to make sure we always clear the previous timer because it doesn't matter to us anymore. If there is a new keystroke, the old timer can be dismissed. We always just want to measure a change from the latest keystroke to, well, after the pause. We're not caring about an older keystroke. So we want to clean up that timer. The good thing is, set timeout in the end gives you a reference, a pointer at that timer, which we can store in a constant timer here. And I'm doing this in the function we're passing to useEffect. So this is the currently active timer. And now there's something on useEffect which I simply haven't shown you before. useEffect takes a function, and this function can actually return something. Let me shrink that if statement. It's still there, it's just shrunken so that we don't see it. After the if statement, and most importantly, after this timer, but still inside of that function we pass to useEffect. So at the end of this function, we can return something. And thus far, we haven't returned anything in useEffect. Now, you don't need to return anything, but you can return something. But when you do return something, it always has to be a function. And this is a cleanup function. It's a function that will run right before this same useEffect function will run the next time. So not after this function is done, but before the next time it will run. So on the first render, this executes, and this does not execute. But then, on the first keystroke, we clean up the old effect, run a new one. On the second keystroke, we clean up that previous effect, run a new one, and so on. That's how this works. And here in the cleanup function, we can call clear timeout, and pass in timer. This is how you clear a timer in JavaScript. To clear that previous timer. Again, cleanup will run for the previous effect before the new effect is applied. So this cleans up the old timer before it sets a new one. And this ensures that we always only have one ongoing timer, which is of course better because we don't have all these redundant timers in memory. We have only one timer instead. So if I now save this, we won't see a strong difference here. Still the same behavior as before. Still works as before, but it's more memory efficient because we don't have all these old timers going on behind the scenes in memory. Instead, we only have one timer at a time, like this. So this is how this works. This is how we can work with that. And this is how you can clean up your effects, which you might need in situations like this, but also, for example, if you're setting up some subscription to a web service or anything like that. Anything which might emit values regularly, you want to clean up your old subscription in that case, for example, if you're setting a new one with use effect. And here it's the same with the timer. We want to clear our old timer when we're setting a new one, so that we don't have all these redundant timers in our memory, which ultimately will take up a lot of memory and make our app slower. So the filter is working. Let's go back to the ingredients component, which is where we, for example, add new ingredients. We also have a logic for removing ingredients, but right now we're not doing this in Firebase. We're only doing it locally, which of course means that, yeah, it's gone here, but if we reload, it's back. Now, to delete ingredients on the server as well, we of course need to send another request here. So let's copy that fetch request and move it in here into remove ingredient handler. There we send a delete request, which is understood by Firebase to delete data. You don't add a body here, don't need to add headers, but what you need to do is you need to specify in the URL which item you want to delete. Therefore, I'll use backticks here so that I can use string interpolation at string, because now after ingredients, before .json, I'll add another segment, so another slash, and then string interpolation with $sign and curly braces. And here I'll simply add the ingredient ID. And that's a good thing. The ingredient ID is in the end what we get when we click on an item here anyways. In ingredients on Firebase, if we have a look, there in ingredients, ingredient IDs are the next nodes we have there. So we target one of these nodes with this delete request, and then this entry will simply be deleted. So that should be all we need. Here in the then block, we get the response. I don't really care about the response here though, but I only want to update my ingredients here in the UI once this response is there, which is why I moved that updating logic into this then block. Let's give it a try. All ingredients are there in Firebase. Let's click on apples. You see, it took a bit longer for them to be removed, but they're now also removed here. We only have bananas here. Therefore, if I reload, we of course only load the bananas. Obviously, I can re-add my apples, and they're back here as well. But now deleting works the way it should. But that's of course nothing too fancy or new. It's also not using React hooks. But what we can handle with hooks now is whenever we wait for something to complete, whenever we wait for data to be added or to be deleted, we could show a little loading spinner. And on the same hand, if we have an error, we might show that error modal, which I prepared. So these are the next things we'll tackle. So let's make sure we show a loading spinner if we are, well, waiting for the HTTP request to complete. To do that, we of course need to manage an extra piece of state. Maybe isLoading and setIsLoading are appropriate names. With use state, and initially that's false. I need to manage state here because we'll change this, and every change should lead this ingredients component to re-render so that we can update our loading state and show something in the UI. Now, when we're adding an ingredient, let's say, then I want to set isLoading to true. We do this right before we call fetch. Once we got a response, however, I want to set it to false because now we're done. So I'm updating my state here with these calls to set isLoading. This of course will also mean that we re-render the component. And now we can use our loading indicator to, well, output whether we're loading or not. We could display this indicator in all kinds of places. I like to display it in my ingredient form, but it's up to you. I will add a loading prop here and point at is loading here. So forward the is loading state to the ingredient form. And in the ingredient form, there we can import the loading indicator from UI loading indicator. So that's a component I prepared for you. It's a little spinner. And then down there, next to the button, we can check props loading. And if that's true, then I want to render the loading indicator. Otherwise, I want to return nothing. By the way, a shortcut for this is that you replace the question mark with and, so with 2 ampersand signs, and then you omit this colon else case. And now this means this will only get rendered if this is true. It's a little JavaScript syntax where this is checked, and if this is true, this gets rendered, or this gets returned, and in this case, since we're in React, this gets rendered. So now if loading is true, we should see an indicator. We're setting loading when we add ingredients. Let's also do it when we remove ingredients. There I call set is loading, set it to true initially, and only once it is deleted. So here in the then block, I'll set it to false because we're not loading anymore. So if we save this, now if we add chocolate 1, we should see a loading spinner here, and we do. And if I now delete something, we also see one. So that's a bit better. And of course, we could do something similar when we're loading all ingredients initially. We'll take care about this later. For now, this is what I wanted to show you though. Let's next handle errors. Things also could go wrong. Let's say for removing, we get an error. And Firebase, unfortunately, kind of is really stable, so we probably won't get an error there. But if I remove the S here in JSON, we'll force a technical error. Therefore, now if I click on chocolate, actually this keeps on spinning, this doesn't get removed, and here we see we have an erroneous request. We got an error, but we're not handling it. And that's not a great user experience because it's not obvious to the user, who hasn't the developer tools open, what went wrong. So we want to handle errors like this. Now with fetch, since it returns a promise, we can handle errors by adding catch here. And catch will get the error and then allows us to do whatever we want with that error. Now here, I want to output my error modal and show a nice error message if something goes wrong. Therefore, I'll import the error modal from the UI folder and their error modal.js and render this if we have an error. Hence, we need to manage an extra piece of state. Error and set error with use state. And initially, I pass no value in there because we have no error. Initially, it's just undefined or null initially. But now we can call set error whenever we got an error. So let's say, because here I know that we'll have one, in the remove ingredient handler, in the catch block here, we call set error, and I set error.message as a value. Every error object by default has a message property. So I'm setting this message as a field or as a value for error. And you can, of course, manage whatever you want in here. You can also set your own message, like something went wrong, anything like that. And I'll do that here because the predefined message might be really cryptic to users, so I showed this one. Now we can output the error modal if error is set. So if that error state is set. For this here, in this div, I want to check if error is true. Remember, error is my error state. So if error is true, and if it is, using the same shortcut as before, I'll render the error modal. So this only gets rendered if error is set. And then to the error modal, I pass my error message, and that's just what I store in error. Now, error modal actually is a component which tries to call on close if we click the backdrop or the OK button. So I'll add on close here, and there I want to execute a function that clears the error. So I'll add a new function, clear error, or whatever you want to name it. And in the end, what this does is it calls set error and sets this back to null. And if that is null, this error modal will also disappear because this condition will not be satisfied anymore. Null is treated as false, and therefore this won't get rendered. So here on close, I will point at clear error, so at this function, which should get executed if onClose is triggered. In addition to setting the error here, I also want to set isLoading to false here, because even with the error, we are not loading anymore, so the loading spinner here should disappear. Otherwise, that will keep on going. Now, if we save this, and I click on that, I get that error modal. If I click OK, we're done. That's also another important thing you have to understand regarding how React works. React also batches state updates. I'm naming it set state here because whenever you call a set, whatever it is, function from use state, this will of course trigger a state update. And there React has a mechanism for batching multiple updates together to avoid unnecessary render cycles. So when you set your new state, no matter which approach you use, React batches these state updates. So that also means that right in the next line after calling set new state, you can't immediately use the new state because React won't go ahead and update the state and skip all the other code. Instead, it will execute all the other code in the same function and batch all state updates you scheduled there together. So all state updates from one and the same synchronous event handler, that's important, synchronous, are batched together. That's a bit theoretic. What does this mean? It means that here in clear error, for example, I have set error and set is loading. This is in the same function. These two steps are executed synchronously after each other. So even if that were in a then block, if both are in the same then block, then these two always run right after each other, and then React batches these two state updates together. So this will not mean that set error causes a re-render cycle and set is loading causes another one, but we'll only have one render cycle here, which updates both states, or which reflects both state updates to be precise. And looking at that, set is loading is actually wrong here in clear error, or not wrong, but you might also argue that you want to move it here where you set the error initially, then this spinning icon also disappears right when the modal opens, of course, because we're setting loading at the same point of time we're setting the error. But these two, again, will be batched together, so it's not two render cycles that are executed to show the error modal and to remove the spinner, but it's one and the same render cycle, which already has both state updates taken into account. So that's how React batches state updates and how you can handle error with a separate state, of course, where you store errors and then react to them appropriately. Now, in a scenario like this, we have three different states we're managing, and they're all kind of related, if you're honest. They're all related to us interacting with an HTTP request. Our user ingredients change whenever we send a request because we either loaded data or we deleted data or we added data. And we're waiting for this request to be done right before we change user ingredients, or we might also have an error. So these three states are actually closely related. We're managing them kind of independently, but also we sometimes update two at the same time, like here, where we set error and set is loading right after each other. Thanks to React's batching mechanism, that's no problem, it works just fine, but still it might be a bit annoying to manage these states independently. By the way, that would get worse if one of the states would depend on another state, which arguably kind of is the case already. When we set our ingredients because we added a new one, we're depending on our old ingredients. It's not really a different state, we're not depending on loading or error here, but it's an older snapshot of the same state. So in such cases where you depend on the older state, or you need to update new state based on maybe also some other new state of another state object, then there is a better way than using useState. You can instead call or use useReducer, another built-in hook. Now, if you followed through the Redux section, the word reducer already tells you something. Reducers are functions that take some input and return some output in the end. And useReducer uses that to give you a clearly defined way of defining state changes and state updates, and it will then also manage that state for you. So React will do that. It all starts with you defining a reducer, and you typically do that outside of your component so that this reducer function isn't recreated whenever the component re-renders, because the reducer function often is decoupled from what's happening inside your component actually. So here we can have our ingredient reducer, let's say, and we'll actually build two reducers, by the way, but let's start with the ingredient reducer. And this in the end stores a function. This function will automatically get two arguments passed in by React. The state, and you could name it state, but I'll name it current ingredients. So the ingredients currently stored by React, and an action. That action will become important for updating the state. Now, you also know that concept of actions if you watch the Redux section. An action is an object which could have a type, and then we can use a switch statement to define different cases for different code we want to execute for different types of actions we're getting. For example, we could have a case to set our ingredients. We could have another case for adding an ingredient, and we could have a third case for deleting an ingredient. Now, these are all just identifiers I came up with. You can use any identifier you want. You typically also should have a default case here, but we should never reach this, so here I'll just throw a new error. Should not get there, because we should actually handle all cases that we can have. Now, a reducer, as I said, needs to return something, and will return different things for all these cases. Here we throw an error, which also, well, cancels this function. Here we're not returning an error, but we return something new, and that should be our new ingredients. Now, if we call set, then I want to override my current ingredients with a new list, a new array of ingredients, and that should be part of the action object I'm getting. So there I expect to get an ingredients property, which should be an array of ingredients which will replace the old state. Now, in the add case here, we also want to return a new state snapshot. And our state here is an array, right? Because ingredients is an array, so we should return an array. But here, of course, it should be our old array plus the new item. So the logic is the same as we have it in our add ingredient handler in the end. There we copy our old ingredients, then we add a new one. So here in add, I copy my old ones, which are the current ingredients here, which I get automatically. And then we add a new item, and that has to be part of the action we're getting. And now it's up to you whether you expect to get that all already merged into one object on the action, like ingredient, or if you got three different properties. You will be the one dispatching these actions later, so you can decide which data is in there. And here I expect to get my ingredient in the action. Now, in the delete case here, we need to return our updated list of ingredients. So I'll take my current ingredients and then again use filter, run some logic on every ingredient and compare the ingredient ID with, let's say, the action ID. So I expect to have an ID field on the incoming action, which is the ID of the ingredient that should be deleted. And therefore, all ingredients where this is not equal should be kept. The one where it is equal will be dropped from the new list. And the new list is returned. What we return here replaces the old state. So that's our reducer, the reducer function. That alone doesn't do much. We now need to initialize it by calling useReducer, or utilize it by calling useReducer. UseReducer takes our reducer function, so the ingredient reducer in this case here, and useReducer also takes an optional sect argument, which is the starting state. And in our case, that's an empty array. So that's what will be passed in as current ingredients the first time this reducer runs. And for subsequent runs, current ingredients will be our current state. Initially, it's an empty array. And useReducer, like useState, returns something. That something also is an array, but now not with state and set state, but with state, so our user ingredients. So we can comment out this use state call here, user ingredients. But the second argument is now not a method to set our user ingredients. Instead, we're doing the setting in our reducer. Instead, it's a dispatch function. It's still a function which we can call, and you can name this whatever you want. The name dispatch is just one that makes sense because it's a function which you'll call to dispatch these actions later. So where you dispatch these action objects, which are then handled by the reducer. So I'll temporarily, again, still import use state so that the other code still works. But let's now utilize dispatch in the places where we previously called set user ingredients, because we can't use that anymore we're not managing the user ingredients with useState. Instead, here we now dispatch for setting the ingredients, and now here you need to dispatch an action. The action could be anything, could be a string, but typically it's an object, and here it's an object where we want to have a type property describing what action we want to do, and then maybe, depending on which action we're running, some extra data, like for setting our ingredients property here. So here, I'll dispatch an object with a type property. Type is set here, and of course this has to be one of the identifiers you're handling in the reducer. So here it's the set identifier, and then this set action needs an ingredients property to work correctly. So here I add ingredients and set this equal to the filtered ingredients I'm getting. And with that, we're using dispatch to update our user ingredients. Hence now already, if we save this, this would work, but of course we got two other places where we previously called set user ingredients, like here, where we add an ingredient. We now instead call dispatch an action object where the type is add. Again, that's the identifier we're using in the reducer. And there we expect to get an ingredient property. So I'll add ingredient here. An ingredient is constructed as I'm constructing it here. So it's an object with my ID, and with the ingredient data I am getting here as an input to this function. So now we dispatch this. And finally, for deleting, instead of running this code, we also dispatch an action where the type is delete. Again, because we have the delete type here. And there I expect to get an ID field in the action object. You could have multiple fields. You don't always have to just have type and one other field. You can have as many fields in here as you want. Here, however, it will be the ID, and that will simply be the ingredient ID I'm getting here as an input to my remove ingredient handler. So that's now forwarded. With that, if we save this, this works. Our data loads. And if I add, for example, apples, that works. And to show that deleting also works, I'll fix that error in my delete HTTP request by adding that S again in JSON. And now if I click on, let's say, chocolate, this is removed and it stays away if we reload. So that's how we can use reducer. Now here I added use reducer instead of use state, not because we replaced so many state things with it. Actually, we only replaced this one user ingredient state. But because we have multiple ways of changing that state, and some of these ways depend on the previous state. And whilst the previous approach there, of course, also worked fine, using a reducer often is cleaner, because you have all your updating logic in one place, in the reducer, and then you just dispatch these actions, which is a very clear and easy to understand flow for how you manage your data. So whenever you have more complex state that can change in different ways, instead of just, let's say, setting a boolean from true to false, but like here where we can add ingredients or remove ingredients, whenever you have such a state that is a bit more complex and that might also depend on previous state, then you should strongly consider using a reducer to have a cleaner logic, to have all in one place, basically. And ultimately, it's of course up to your personal preference, though. Another scenario where using use reducer could make sense is if you have multiple connected states. Like here, is loading an error? They're both related to us sending HTTP requests, and whilst we manage them independently, they're kind of related. Now you can of course manage it like this, but also here, often a reducer makes your code easier to reason about, easier to understand. So I'll add another reducer, again, outside of my component. Doesn't have to be outside. You could move it in there, for example, if you use props in your reducer, but if you don't need to, put it outside of the component to avoid unnecessary recreations of the reducer. So here, I'll name this HTTP reducer maybe. Again, get my HTTP state and my action. And just as before, you can name these arguments whatever you want, of course, but this will be your old state basically, and that's the action you're getting. And just as before, we can switch the action type, because there will be different actions we'll dispatch. And now let's think about which actions might we have when we work with HTTP requests. Well, if we have a look at our code, then we always start by sending the request, right? We start off by sending a request. So sending a request probably is one action. Another action we then have is when the response is there, in this then case, or when we have an error, in this catch case. So we have three possible states here that make sense. Three different cases, I should say. So the first case is send, or send request, or whatever you want to name it. I'll just name it send. The second case is response. So the response is there. Again, you can name this whatever you want. And an error case. And just as before, a default case where I, however, will only throw a new error. Should not be reached. Because we're the ones dispatching these actions, we should of course make sure we only dispatch actions with these identifiers. If we ever see this error, then we dispatched some action we're not handling. And then we should either fix a typo we have or add a case for that action. Now what happens if we send a request? Now it's important to understand that here we'll not send the request itself. We're doing that down there. Here I just want to manage the state that is related to that request being sent that influences our UI. So the state there is basically whether we show a loading spinner or whether we show an error. That's essentially the state I want to manage related to that request. So here, when we initialize this with use reducer and we point at our HTTP reducer, then the initial state could be an object where we have two fields, and that is loading, which is false initially, and error, which is null initially. Here I'm using an object because a reducer could also just manage a single string, but here I want to have multiple connected fields, and therefore I have an object to connect them. Now when we send a request, we want to set loading to true, and the error probably to null, because we have no error yet if we just send the request. And this is the new state we'll return. Of course, it should match the signature of our general state, like the initial state we're managing here. And that is the case here. We have a loading property and we have an error property. If we got a response, then I'll set loading to false and I'll set error to null, or actually I just don't want to change the error. A common pattern therefore is that you actually set the property you want to set, but before you do that, you simply take your existing state and use the spread operator to pull all key value pairs out of it, merge it with this new object, which will be returned as your new state, so that you don't lose anything from the old state. And whatever you set thereafter will override any properties of the same name that were pulled out of the old state. So if the old state, we have a loading property in there, we're pulling that out and adding it to the object. But since we also define it here, we then override that value with that new value. Other properties, which we don't override here, will simply be kept in this new object. If we have an error, then I want to set loading to false, because we're still not loading anymore, even if we have an error, and set the error to action error. So we probably should get it here, or error data, or whatever you want to have here. You're the one writing the code, you can define what you expect on your actions. Here I'm not using the spread trick or the spread approach, because here I'm setting both properties which my state here has. So no need to spread existing properties. I would override all of them anyways. So that's the HTTP reducer. Use reducer therefore returns our HTTP state, or whatever you want to name it. I'll name it HTTP state. It's the same name as I have up there. So to avoid confusion, you don't have to change any of the two because they're in different scopes. But to avoid confusion, I'll name this priv HTTP or cur HTTP state, because it's the current state before the update up there, and here it's just HTTP state. And again, we get dispatch. Now I already have a dispatch variable though, so I'll rename this to dispatch HTTP so that we have no name clash here. And here we need to rename it because they're in the same scope, hence we can't use the same name twice. So now we can get rid of these two use state statements and now fix all these errors we're getting. For example, here for loading. In the end, what's happening here is that I want to dispatch an HTTP action, and that action is of type send. So that's the identifier I defined here. And that will then automatically set these state values. We don't need to pass any extra data to that action because that action doesn't need any external data to work. So we send a request here. Now, when we got a response, I'll send the response request here. Down there, in remove ingredient handler, again, it's the send request, which I'm sending. And then here, if we got a response, it's the response request. Only here, if we have an error, well, then I want to dispatch my error action. And that's the only action here that then takes an extra argument, because in our reducer, we're accessing error data on the action to get the error. Actually, I'll rename this to error message, because I want to get the message and store that in error, so that error always is a message. And then down there, I pass error message as a key, and that is error.message, or again, a message of your choice, like something went wrong. Now in clear error, there we actually need to dispatch an action we don't have yet. So let's register a new case, and that is clear maybe, where I return my current HTTP state, but I set error to null, because that's what we're doing here. We're keeping all the old state in this new state object we're returning, but we're setting error to null. So now we can dispatch this clear action here. So dispatch HTTP with an object where the type is set to clear, so that this clearing is happening. Well, and then here, instead of error, we access HTTP state. Remember that HTTP state is now what we're extracting from the result of use reducer here. So that is in the end this object with loading and error, which we're constantly updating. So we got our HTTP state, which might contain an error. HTTP state error is what I output here, and HTTP state error also is what we need to check here. And then here it's HTTP state loading. With that, if we save this should again work correctly. If I add a new item here, we see the spinner, so loading works, we see that here. And now if we add an error again, for removing, let's say, by again removing that S from JSON, if I now click here, we see that, we see the error modal, we can close it. So that is now all working. Let me re-add the S. With that, we're using a reducer for this too. Here, we're doing it because we have multiple connected pieces of state, which we now can manage in one place and still make sure that we always get the old state, that we update everything correctly, and that again, we take some logic out of our component here and move it into the reducer functions, so that we have cleaner code where we have a clearly defined flow of data and of where we change our data. Now we can also get rid of the use state import here in the ingredients.js file, because now we're managing all our state with use reducer, which is an alternative to use state if you got more complex state that relies on the old state, or if multiple state values work together and you want to manage them in one place and update them correctly. Now that we had a thorough look at use state, use effect, use reducer, we also used use callback, let's have a look at how we can use the context API, which is also an exciting feature about React, together with functional components and hooks. And for that, I got my auth.js file, which we haven't used thus far, which is a very simple login form. Well, it doesn't even have inputs, but it has a login button at least, which we can click. And I want to show that if we're not logged in yet, and alternatively show my ingredients if we are logged in. That's where the app.js file will come into play. Right now, it always returns ingredients. The goal is that now this does not always return ingredients, but instead it returns either ingredients or the auth screen. So here in app.js, I'll import auth from ./components auth. And well, we could now always return auth, of course, which means we would always see this. But now we got no way of, going to our ingredients. So the goal will be that we switch between those. Now, of course, for that, we can manage all the auth logic here in app. You use an if statement to render different content. We could do that. But in a more complex app, of course, you might be interested in whether the user is authenticated or not in a couple of components, maybe deeply nested into other components. And therefore, passing data about the authentication status via props might not be what you want to do, because you build very long chains of props which you have to pass around. That's where context can help us. For that, I'll create a new folder, context, which is optional, but I like to store my context in there, and name this off-context.js. This is the file name in there. Now in this off-context file, we can create context by importing React from React. And then we create our, let's say, off-context. Name is totally up to you, but should start with a capital character, actually, by calling React create context. And this is also something I covered earlier in the course already. This is the context API offered by React. So go back to that component deep dive section if you're not entirely sure what this means. Now, we can initialize this with a value, and there I want to manage whether we're authenticated or not. And I want to provide a login function, which here is just an empty function, but which I still add here to get better auto-completion. We'll override this with a concrete value soon. I will also export this context object, but I will also use it in that same file to create a component there. I'll name the component off-context-provider. It's a normal React component, a functional component, as you can tell. And in there, I return off-context.provider. So I'm using off-context up there, and this automatically is a valid React component, or at least with .provider, it gives you a valid React component. And between there, I want to allow anything. So I'll add props children there so that we can use the off-context provider, pass anything as a child to it, and it will be wrapped by our context. Now it's in here where I want to manage that login status. And I'll do this with the help of useState now. useState because it's a really simple state. It's a simple state because I only want to track whether the user is authenticated, and I want to be able to set is authenticated or not. And initially the user is not authenticated, which is why I initialize this with a false value. Now I'll also add a function here, log user in, or whatever you want to name it, or login handler. Name is totally up to you. This takes no arguments here because it's just about showing how to work with context, not about really taking inputs here and validating that. And then I'll call set is authenticated and set this to true. That's what I do here. Very trivial function. Now, the off-context provider gets a value, which will automatically be distributed to everyone listening if it changes, which describes our context. Initially, we have this starting value, but now I will immediately override it with a new object where I have login. And that's my login handler pointing at this function. So now we have a real function behind it. And is auth, where we have is authenticated, so this state value. And again, if this changes, so for example, if we call set is authenticated, everyone listening will get this updated value. So now we just need to export, maybe as a default, this off context provider, so this component which we built here. And now I have this default export, and here we have a named export. And now we can use that, and we can use it in the index.js file, so the root of our application. There we can import the off-context provider from .context, ./context, off-context, and wrap our entire app with it. So wrap the entire app with off-context provider, like this, so that the entire app receives our context or is able to receive it. You can listen to the context from everywhere in the app. That's the right way of putting it. So off-context provider is wrapped around our app. In app.js, I'm already interested in it. And that's the thing which could be problematic with functional props. We can, of course, import our off-context, so not the provider component, but the context object itself, from ./context off-context. However, here I mean the named export, so we have to wrap this in curly braces. And what we can do is we can wrap this here with off-context.consumer now to set up this render function in the end in there. This would be how you can use context in functional components. This means that if you need data from the context anywhere else but in your JSX tree, you have no way of getting it. You would need to transform this into a class-based component so that you can add the static context type thing, which you might remember from earlier in the course. Well, thankfully, there is a hook to also fix this. The use context hook, you use it like this, you pass in the context you want to listen to, so to say, off context in my case, and you get a handle to that context, which is then stored in this constant. And you can name it whatever you want here and name it off context. And now here in app.js, I can listen to off context.isOff, or not listen to it, but check it, and this will be rebuilt whenever the context changes, whenever the value in there changes. So whenever we change isOff, for example, then this will rebuild. So here I'll listen to it, and then I want to output a different content. Let's say my default content here is the off component like this. But if we are authenticated, then content, of course, is the ingredients component. And then down there, instead of hard coding context, I return content, which is changed depending on the value in context. Now we just need to make sure that clicking on the login button also does reach the, login handler function here. Keep in mind that a pointer at this function is stored in login in the context. So all I have to do is I have to go to the place where the button is, which is in the off component, and also import the off context there, off context, the named import, from the context folder off-context, and import the use context hook here as well. And now here, I can get access to my off context with use context pointing at off context. And the login handler, I'll call off context.login as a function. And now with that, if we click that button, we're logged in and we see the ingredients. So this is how we can work with context, with functional components and the use context hook. Now that we had a look at so many different hooks, let's take a step back, or actually stay in the hooks world, but see how we can optimize our project, how we can avoid unnecessary re-render cycles, because that's of course something we might also be interested in doing to ensure that we have an app that performs well. And for that, let's have a look at the ingredients.js file. There we're managing a bunch of logic. We have two reducers in there. We're changing the loading state, for example, and we update the UI in this case. And one thing I can already see there is that, for example, I'm passing the add ingredient handler to the ingredient form, and add ingredient handler in the end is just this function. This means that since it's a function defined inside of this functional component, whenever this functional component rebuilds and therefore this whole function gets executed again, this function will be recreated. Now, a side note here, by the way, use reducer and so on will not be recreated. Of course, this is called again, but React detects that this reducer is already initialized for this component and uses that already initialized value. So that's no problem. But here for add ingredient handler and so on, we're creating a brand new function. This brand new function is therefore passed down to the ingredient form. And hence in the ingredient form, even though I'm using React memo, this will rebuild. And I can prove this to you. Can throw in a console log rendering ingredient form, and theoretically that should only be rendered whenever we type in there, because these are the only things that change the form, and of course when we initially load it. But what you will see is that, for example, if I add something, test5, let's clear the log, I hit add ingredient, you see it's re-rendered a bunch, and that makes sense because it's re-rendered when we change the loading state. Well, actually that makes sense because we're outputting the loading indicator here. But it's also re-rendered once the data is there and we're outputting the data down there. And this is not what we want. There is no reason to render this form if we're just outputting some data down there. So that should be one render cycle too much we have here. 2 makes sense because we switch loading from false to true and then back from true to false once we're done. So we definitely will render twice because the loading spinner is in the form. But the third output here makes no sense. We can get rid of that by wrapping add ingredient handler with use callback, which we already saw before. And for that, you need to import use callback from React, of course. And then you wrap your entire handler function with that. And then you add square brackets where you define the dependencies of this function. The dependency here is dispatch HTTP, which you don't need to specify because just like the updating function from use state, this is guaranteed by React to not change between render cycles. So you could add it, but you don't have to. Ingredient is a local argument we're getting in the function, not an external one, so nothing we need to do there. And therefore, overall, there's nothing in here on which this would depend. So this function actually should never be rebuilt. It's always the same function. It has no external dependencies other than dispatch HTTP, which, as I said, is managed by React such that it won't change. So it's not really a dependency. If we do that, then if we log in here and I add another ingredient here, we only see 2 render cycles. The third one is gone because this function, add ingredient handler, is now not rebuilt. We're passing this function into ingredient form, but since it doesn't change between render cycles, React Memo detects that the new function we're getting when the parent component rebuilds is the old function and therefore doesn't rebuild this component. That's how it works. Loading, when it changes, of course, breaks through that, as it should, and triggers a rebuild on the ingredient form if it changes. If loading would not change, if we had false before and false for the next render cycle as well, this would not be rebuilt. So now we're taking advantage of React Memo here. The same for the ingredient list. When we change the ingredients, this should rebuild, but it will now also rebuild all the time because we pass in the remove ingredient handler, and that's also not wrapped by use callback. The result of that is that the ingredient list will also rebuild too often. If we add a console log statement in there, rendering ingredient list, something like this, then you'll see, of course, it loads initially a couple of times because of the loading state change. It loads initially and then loads once the data is there. But you will also see that it also loads in cases where it shouldn't. For example, if I click on test here, it renders way too often. Of course it should render once the data is gone, but it should not render just because we're showing a loading spinner up there, and that is the first thing we're doing. So, same logic as before. The dependencies of ingredient list are on remove item. Please note I'm not using React Memo here, so the following change will not alone have a result. But still, it's a first step. Remove ingredient handler, we use callback here, and wrap this entire function with it, and then specify the dependencies. Dependencies are dispatch HTTP, which, as mentioned, doesn't have to be specified. Ingredient ID is an internal value, not an external one. Nothing else in there which matters, so it's an empty array. Now again, as mentioned, this alone won't make a difference. If I delete test here, we still see a bunch of ingredient list re-renderings. Now, it makes sense because in ingredient list, I'm not using React Memo. So of course, we can do this. We can use React Memo here, wrap this entire component with it, like this. And if we do so, we log in, clear this, and I click bananas, we only render it once. So we're having the effect we want. We're only rendering this when this changes, not when something totally different changes. And there's nothing wrong with doing this, and actually this is the approach you'll typically use. Still, I want to show you an alternative, because there also is another hook you can use, and that's the use memo hook. Use callback was a hook to save a function that doesn't change so that no new function is generated. Use memo is a hook where you can save a value which is saved so that the value isn't recreated. And that is another way of memorizing a component. So here, that would be our ingredient list. Let me cut it from there and add it here. Ingredient list maybe like this. And now use memo here. Pass a function to it. This is not a function that's now memorized though. Instead, it's a function that React will execute for you. And that function should return the value which you want to memorize. Ingredient list here. Now use memo also needs a second argument, which is a list of dependencies you have. This tells React when it should rerun this function to create a new object that it should memorize. And we know it should rerun this function whenever the user ingredients change. So let's add this here. Or whenever remove ingredient handler changes. And that shouldn't change because we wrapped that with use callback. So only changes to user ingredients should really rerun this function and rebuild a new ingredient list. And now ingredient list is of course something we can output down there. Ingredient list like this. If we save this and we log in, ingredients are getting rendered. Now let's add bananas here. 10. Add this. We updated the ingredient list once. If I delete them, we updated it once. It's an alternative to React Memo. Now, if we're talking about storing components, you typically want to use React Memo instead of use memo. But keep in mind that with use memo, you can store any data which you don't want to recreate on every re-render cycle of this component. So if you have some operation that calculates a more complex value, calculates a value which maybe takes a bit longer to calculate, then you want to consider wrapping it with use memo so that it's not recalculated whenever the component re-renders, but really only recalculated when you need to recalculate it. That's the idea here. Now, last optimization I want to apply is here on the error modal. On close, we call clear error. It's this function. And there again, we can use callback to make sure that the error modal isn't re-rendered unnecessarily. We have no external dependencies here, so it's as simple as that. And now we also make sure that the error modal, which already uses React Memo, isn't re-rendered in cases where it shouldn't. So these are some optimizations you can apply and you should think about. Now, it's not the end of the world if you forget one, because re-rendering sounds like a super intensive work. If it's a small component, an easy update, it might be super fast to re-render. And re-render always means re-rendered in the virtual DOM, right? You learned that earlier in the course. Does not mean that whatever changed is automatically written to the real DOM. But even that virtual DOM re-rendering can be avoided with use callback, use memo, and React Memo. But if you have very trivial components, it might even be worth not adding React Memo, so you shouldn't wrap every component with React Memo or with use memo, because React then always needs to check whether props changed, and if it's a super small component, re-rendering it might just be faster than performing that check. So it's always something you have to evaluate and think about. For example, for the error modal, we could probably get away with always re-rendering that and not using React Memo. So these are examples, and these are things you just have to play around with, test, and also check how fast your application is to get a feeling for this, where it makes sense and where it doesn't make sense. So we're almost done with this module, but one very cool feature is missing, and that is custom hooks. You can build your own hooks. You're not restricted to the built-in ones. So let's do that. I'll add a new hooks folder where I want to store my hooks. And there I'll add one custom hook, and that's my HTTP hook. Because I have that HTTP functionality in Ingredients.js, for example, where I send HTTP requests. I do this multiple times, and the pattern always is the same. Dispatch send at the beginning, dispatch response once the response is there, dispatch error if we have an error. It's always the same pattern. So we have logic that we want to share across components, but, and that's the important thing, logic which also influences the state of the components where we want to use that logic. So we can't use a normal function, because of course we could build our normal send request function, which simply has all that send request logic in there. But from in a normal function, we couldn't dispatch events which then change the state in a component that calls the function. That's something only hooks can do. And that's why we build our own hook now. So in the HTTP.js file, in the hooks folder, I want to build my own hook. And the first very important thing there is your own hooks should always be named use something. In my case here, use HTTP or use fetch or whatever you want to name it, but use something written like this. And I'll go with use HTTP. Then your hook is just a function. It's a normal JavaScript function, just treated in a special way by React. That's the core thing. So now we have this, and I will export use HTTP here. So that's a very simple hook, which doesn't do anything, but it's a start. The cool thing is, in this hook, you can now use stateful features. You can use state, use effect, use reducer, anything. You can use any hook in there. And any component that uses your own hook will then run this hook as if you had the code written in here directly in the component. So it's not like you have one function shared by multiple components and then they run the same code with the same data. No, each functional component gets its own snapshot of this hook, so to say. So that's a cool thing. You can have stateful logic in there, but the stateful logic will then be different for each component where you use that hook. so that you can share the logic, not the data. That's the idea behind hooks. So what do we want to have in this custom hook? Well, I'd say it makes sense to move our HTTP reducer into there. So let's go to ingredients.js and fetch this HTTP reducer, cut it from there, and let me close the UI folder, move it here into HTTP.js. And I'll define it outside of the hook, because again, this doesn't need to rerun with every re-render cycle, and your hook will rerun with every re-render cycle. That's important. Your hook will get called whenever the component where you're using your hook gets re-executed. And then you can use techniques in your hook, of course, to make sure that nothing happens to the state or that something does happen, depending on what you want. But in general, it will get re-executed. I don't want to recreate the reducer all of the time, so I'll move that out of there, just as we did it for the component. Now, of course, since the reducer function was removed, I'll also remove the useReducer call from ingredients.js and move it into HTTP.js, now inside of my custom hook, here. Now to use useReducer, we have to import it. So let's import useReducer from React. We don't need to import React itself here because we're not building a React component here. We just want to use some features from the React package, in this case, useReducer. So here I then have my state in dispatch HTTP, which right now isn't that useful, but we'll get there. Now the request itself. Let's go to ingredients.js and let's grab one of these requests. Let's grab the one where we handle the error here in remove ingredient. I'll take this entire fetch block with all the then and catch blocks thereafter, cut it, and add it to HTTP.js. This would now execute this HTTP request whenever the component that uses useHTTP reruns. And that's certainly not what we want here. We don't want to run this all the time. Instead, I'll create a new function here in my useHTTP hook, which I'll name sendRequest. Name is up to you though. And that is a function which should actually send the request, so that it's not always getting sent when useHTTP is called, but only when sendRequest is called, which right now never happens, but we'll do that soon. Now, sendRequest, of course, needs to be a bit more flexible because we don't always want to send the request to this URL here. So the URL should probably be something we get from outside. The same for the method and the body of the request. So here I'll remove the URL and use the URL argument instead. And for method, I'll use method. And we might have a body, which is the body we're getting. And because it doesn't hurt here, I'll always add the header content type application JSON. For a GET request, we don't need it, but it won't hurt. And for some requests, like POST requests, we need it. So we'll always append it. Now we have a flexible HTTP request, a fetch call, which depends on data we get from outside, which will go ahead and then dispatch our response. And at the beginning, also dispatch an action of type send. So that's the statefulness I was talking about. We're interacting with our reducer here because this custom hook will in the end be used in a component which then will automatically get all that state, so to say, or where this state will be connected to by React automatically. So here we send, here we get the response. Now, of course, what we do with the response, however, in this case that we delete the ingredient, that doesn't belong to this hook. That's something the component that uses our hook needs to do. The hook should be just caring about the HTTP request, not about what we do with the response. So we'll have to see how we manage that. For the error, I dispatch this error request. But how can we now get the response data back to, well, the component that uses our own request? Well, we can add something new to our HTTP state here. Let's start with the initial state. Besides loading an error, we can have some data in there, which initially is null. But if we get a response, besides setting loading to false, I set data equal to action.response data, for example, a key I'm expecting on the action. When we send a request, I'll reset data to null here, so that this is definitely null once we send a new request. So I get response data if we have a response. So here, when we have a response, I'll actually cut this and return response JSON, which extracts us the response body. And then the next block, I got my response data extracted. And in here, I dispatch the response action, but now we edited this action or this case here to also extract response data from the action. So we'll set a response data key on the action we're dispatching and save my response data we're getting here, thanks to response.json, in there so that it's now part of the action. So now the important thing is the data we're getting for the request we're sending is stored in our state here. That's all nice, but still, it's in the hook. How do we now connect this to our component? Well, just like some of the built-in hooks, our own hook can, of course, return something. So here, at the end of the hook, I will return an array, but you don't have to return an array. You can also return an object here or a single number, whatever your hook needs. Here, I'll go with an array, or actually, I'll go with an object to show that you can return different things than just arrays. And in that object, I'll return my isLoading key, and that is coming from HTTP state, which is what useReducer returns me here, which I'm extracting here, which will have a loading property, an error property, and a data property. So here it's HTTP state loading. Then we have data, which is HTTP state data, and we have an error, which is HTTP state error. So this is what my hook now returns. And now we can use that hook. In ingredients.js, there, let's import use HTTP. And here you also have to, you can name it whatever you want, but it has to start with use from hooks HTTP, like that. So now I want to use HTTP, and just as all other hooks, you have to use it on the root level. So we can't use it in here in the remove ingredient handler. That won't work. Instead, we have to call use HTTP somewhere here, like that. But that's okay, because use HTTP doesn't send the request actually. It just sets up the logic for sending a request. It sets up our state, and it sets up this function which sends a request. So we should probably return that function too. So in this object I'm returning, I'm also returning send request, and I point at this send request function. So now we return a handle to this function as well. Now, to avoid unnecessary re-renders, I'll already also import use callback here and wrap send request with use callback like this, and add an empty array as a second argument because this doesn't have any external dependencies. So it's good like that. So send request is returned, and it will not re-render unnecessarily, which helps us optimize rebuilds. And now in ingredients.js, use HTTP therefore returns our HTTP object, whatever you want to call it. In the end, that's our object where we can use destructuring to pull out isLoading, a potential error we're getting, the data we're getting, and send request. These are the four things, the four properties we're returning in our hook. These four properties. And with object destructuring, which I'm using here, I'm pulling them out and storing them in separate constants. Now we can use these constants. So for the moment, I'll comment all of that logic here out. We'll fix that later. And here, where we use HTTP state error in our JSX code, I just use error, because that's one of the things I pulled out of my result from use state. And for loading, well, it's just isLoading, another thing I'm pulling out from there. Now, when we're deleting an ingredient here, I therefore, in the end, just use send request to send a request to a URL. And that should be, of course, the URL of an ingredient. So it's this URL. So let's use backticks here actually so that we can inject values. Then it's /ingredients at the end. Then, just as before, the ingredient ID, and then .json. That's the URL. Then the method is delete. That's the second argument send request expects. And we need no body, so we can omit the third argument. Now, send request is now a dependency of use callback, because send request is actually a thing we're returning here from use HTTP. And if we would not wrap send request with use callback inside of use HTTP, This would actually change whenever the component where we use HTTP, so whenever ingredients re-renders, and therefore send request would change on every re-render there, and therefore a remove ingredient handler would change, and we would again lose all our optimizations. Since we use callback in our custom hook, we ensure that send request never changes, and we can safely add it as a dependency here. It will not change, and therefore this will not recreate this function unnecessarily, and hence our optimizations stay intact. So now we're sending this request here when we're clicking remove ingredient handler. Let's give it a try. Let's go here, log in, and click this. And you saw the loading state. That's great. Something changed. The ingredient is still there though, but interestingly enough, on Firebase, it's indeed gone. Now that makes sense because we sent the request and it's good that it worked, but we're not updating our ingredients here. That's of course the next thing we'll have to do. We're not done entirely. We have our hook for managing HTTP requests, but for updating our data in this ingredients component, we have no solution yet. So how can we update our ingredients here in the ingredients component when our delete request is done? Well, again, we can use a hook we already learned about, useEffect. Remember that useEffect runs after every render cycle. So useHTTP sends a request, and in that request, in the end, we dispatch response if we succeed. This updates the state, and therefore it will re-trigger the component that uses our hook to rebuild itself. So our component, ingredients component, will rebuild itself when send request is done, thanks to the logic we have in our hook, because dispatch HTTP, which is coming from user reducer, updates the state. This rebuilds the component in which it is used. It's of course used in our hook, but that hook is used in this component, therefore this component rebuilds. By the way, if we would use the same hook in a different component, that other component would not rebuild because, as I said, the logic is copied for every component. They're not sharing the same data. So if you're sending a request in component A, that does not mean that component B also sends or anything like that. You're just sharing in the sense of copying the same logic across components. Here, however, we know that this component will rebuild whenever the request response is there. Hence, we can actually turn this useEffect call here into a more useful one. We can listen, for example, to the data, because we know that on our custom request here, when a response is there, we update response data, and that means that we set data here on our state. So our data changes when our response is there. Now for a delete request, we get no data, but still we'll change something here. We'll set a new value in response data, and that alone should suffice here. So in ingredients.js, we're listening to data, because in this useEffect call here, when we have new data, then I want to call dispatch, which is now coming from my ingredient reducer here, dispatch type delete, because we deleted a component in the end here, and pass the ID. Problem is, where do I get that ID from? I need the ID here on the action I'm creating, but this useEffect call knows nothing about the ID. Well, solution again could be that we add a feature to our hook here, to our custom hook. In the custom hook, we can add another field like a request extra, which initially also is null. Now that extra can be set when the request is sent. There we can set extra to action extra, let's say. So I expect to have an extra field on the incoming action. We're dispatching the send request here, and there we can send a set a extra, and I expect to get this from outside. So as an extra argument in the send request function, I get my request extra, and I'm storing this in my state here. So back to our ingredients component, when we call send request here, I send no body, so I pass null here, but for request extra, I forward the ingredient ID. So now this ingredient ID gets added to send request. In the hook where we define this function, we then store it in the state, which is the state for this component, right? And therefore, we can now also return that request extra here in the data by getting it from our HTTP state extra. And that means that in the ingredients component, there we can also extract request extra from the result of use HTTP and now use that here in use effect, so that the ID I need to provide for the delete action here actually is my request extra, because we know that we'll store our ID in request extra when we send that delete request. Once the delete request is done, once the response is there, data will be emitted. Hence, this effect will run, and then we can dispatch this delete action, which adjusts our ingredients. So here, let's add request extra, and this should work. Now let me also step in here for a second and make it really clear that it can be strange to think about HTTP requests like this at first, that we're sending them somewhere and we're handling the response somewhere else in use effect here. Nonetheless, this really embraces the concept of hooks after all, and whilst it can be strange to look at a HTTP request like this initially, it actually makes handling it much more elegant in the long run, I believe, because you can clearly see in your code where you're handling results of your request, where you're changing your data, and where you're just dispatching that request, where you're sending it off, so to say, with send request. Nonetheless, and I want to emphasize this here, an alternative would have been that the send request function we're returning in our use HTTP hook, that this send request function, for example, returns the normal promise the fetch method, the fetch API, always gives us. So that in the places where we call send request, we can add a then and a catch block, and then simply still do our logic in these then and catch blocks instead of using use effect. This approach here of splitting the sending of the request and the handling of the response can be more confusing initially, because now you have to care about getting things like that request extra from the I send my request place to the I handle the response place, which is our effect here. Nonetheless, in the long run, as I said, I think it leads you to write cleaner code where you split your responsibilities and where you just have to switch the way you think about it, and then you'll actually have no problems with that approach. Just be aware that if you're not liking this approach at all, you could return a promise in your HTTP hook inside of send request there, and then simply chain all your response handling logic after send request in this component, in this ingredients component. You could do that, but using this approach here with use effect handling the response simply is the approach where you really embrace hooks and use them to their fullest potential. Now I ran out of ingredients, so in order to test this, let's first fix the add ingredient handler now. In add ingredient handler, thus far we're also dispatching a send request and so on. Instead now we call send request, which again is this function coming from our custom hook here. So we call send request. The URL is of course the same URL we used down there, so I'll just copy that. The method here, since we add ingredient, will be post. The body will be that body we had before, needs to be JSON, so let's use JSON stringify. And here I need no special extra, so I won't pass that. So this again calls send request, and just as before, this goes to our hook, executes this function, emits this event, and once the response is there, emits this response event where it stores the response data. So now again, we can use our effect to react to that data in the ingredients.js file and update our local ingredients based on that data we got back. So here we have use effect, which reruns when the data changes or when the request extra changes. And we then always dispatch a delete request. Now that's probably not what we want here. Well, in the end, we can find out what should be dispatched. We know that if we have a request extra in our application here, we want to dispatch a delete request because we only use that extra thing for delete requests. So if we have extra, if that's not null, then it's a delete request. And to make sure that this gets cleared for every new request, I'll go to my custom hook and actually set extra to null here when we send a request, but instead store it on the response. There I'll set extra to action extra, and that means that further down in our custom hook, we no longer append the extra when we send the request. So I'll get rid of this here. Instead, we append the extra once the response is there. So a tiny tweak here so that in ingredients.js, we know if we have an extra, then we're deleting. Else, in our case, thus far, we're adding. So here I can dispatch, well, basically what we did before. So let me scroll down. Can dispatch this here. So let's copy that and use it here. Remove all the comments. Now, of course, here I'm relying on some data from the response. The good thing is we're getting that data. So that should be data.name because we're storing whatever response data we're getting in our custom hook. We're storing that. We're sending this here along with our action, and that gets stored in our state there. So we store response data in data. So the good thing is we have access to this. But for the ingredient, which we also want, we're missing that. Now we could send this along as a request extra, of course. But then this check here wouldn't work. Still, let's use request extra here and then worry about this in a second step. So request extra should be the ingredient which gets added. So in add ingredient handler, where we get that ingredient, which just misses the ID, I now will forward that ingredient as an extra. But now since we have extras for both deleting and for adding, we need a different way of differentiating these two effects we're handling, the two results we're getting back from our hook. And therefore in the hook, I'll add a new field, the last one, here to my state, to the initial state. That's the identifier. Initially, it's null. But we send this, when we dispatch the send request, let's say, then we set identifier equal to, and I expect to get an identifier as an argument, a request identifier maybe. So I'll set this here, I pass this to the action, and in the reducer, when we send this, I'll set identifier here equal to action.identifier. So now we can append an identifier to every HTTP request in the end. And that's just what I'll do in ingredients.js when we dispatch, when we send the request here for adding an ingredient. I'll name this add ingredient. The identifier here is totally up to you. You can use any identifier you want. Can be a string, can be a number. I'll use add ingredient as a string. For removing an ingredient, I'll use an identifier of remove ingredient. And now we can use these identifiers in our effect to clearly identify our logic. So let's get the identifier from use HTTP. Let's make sure we return it there. So in our custom hook at the bottom, where we return everything, there we should also return the request identifier from HTTP state identifier. Now, since we're returning it here in the custom hook, we can pull it out of the return value here in ingredients.js, request identifier like this. And now with it pulled out, we can add it as a dependency to use effect. And then here check if request identifier is equal to, what did I use? Remove ingredient. That's my identifier here for deleting. And for adding, I used add ingredient. So here I'll check else if request identifier is equal to add ingredient. Otherwise, we'll not do anything. So this should now be all. And I know it was a lot that we need to also add ingredients. So let's log in here. And let's add a couple of apples here. And I get an error. Can I read property name of null in ingredients.js line 33? Do you have any idea what could be causing that? Well, it happened pretty fast if you saw that. So the problem is that useEffect runs after every render cycle. And when does this component re-render? Well, it re-renders, for example, when our custom hook here does something, when it dispatches the send action, which actually sets loading to true. That causes ingredients.js to re-render because we're using loading in there. Makes sense, right? Now, since that is the case, we want to make sure that we don't just check the identifier here before we dispatch actions, but we also check whether we're done with loading. Because if we're loading, then we might have data, but we're not done loading it. Yes, data will only be set if a response is there in our custom hook here. But when we dispatch the first action, we also see data for the first time. So just watching for data changes alone here won't do the trick, especially since request extra and request identifier also might have changed, and hence the effect will rerun. So here we need a more granular check. We can check if we're not loading anymore. And of course, that means that we now need to add is loading as a dependency here to use effect. And we have that identifier here. And down here for adding, it's the same. We're checking for not loading, and the identifier is add ingredient. In addition, I also want to ensure here that we got data, so that this is not null, or that we have no error. That's the better check probably. So we should also add error here. It's also a check that makes sense for deleting. I want to ensure that we have no error here. So now let's save this, log in, and let's add some bananas here. And this looks good. This looks way better. They're getting added. We can see them here too, and this works. And now if I delete, let's say, the apples, this also is looking pretty decent to me. It now works with the help of our custom hook. So now we started working with our custom hook. That now also means we can clean up this component a bit, remove some of the code we had in there before, basically everything we commented out there. Now for add ingredient handler, you will also see that we're getting a warning here. There are some green squiggly lines that we're missing a dependency, send request, and indeed, we should add this here. Now add ingredient handler, the same as with remove ingredient handler, send request, thankfully, is wrapped in use callback in our custom hook here. And therefore, this will not rebuild or will not be recreated for every rebuild of the component. And therefore, remove ingredient handler, which also uses use callback, is not recreated. And hence, our optimizations of child components stay intact. And what we're not handling is errors or clearing errors. That's not something we're doing. We want to do that with the help of our custom hook here as well. Now we're setting an error here if we're getting one, but we got no way of clearing it. I will actually register a new case in my reducer in my custom hook, which I'll name clear. And there, I'll return a new object. And essentially what I do there is I'll just return this new initial state. So I'll cut it here, create a new constant up there. Maybe name this initial state, sounds like a fitting name, and that is just this object. And then here, in the clear case, I simply return this initial state object from above. And it's the same initial state object which we can use down there for initializing the reducer. Whoops, and we need no curly braces here. And therefore, we can get rid of that old clear case. The new one does the resetting we want. Now, clear is something we can dispatch, but we're never dispatching it anywhere here. So I'll create a new function here inside of my custom hook, clear, or whatever you want to name it. It's a pretty straightforward function which uses dispatch HTTP and dispatches an action where the type simply is clear. No data needs to be appended, nothing like that. I'll also use callback here to avoid that this gets re-rendered. We got no external dependencies, so this is an empty array. And now clear is a function which we can also return here. So I'll return clear as a key value pair in that object we're returning overall from our custom hook. And now in our component, we can get access to clear by simply extracting this as well as a property from our use HTTP result, so from our custom hook. And now in clear error down there, all we have to do is we call clear like this, or we get rid of clear error here entirely. And down there on close of the error modal, we just point at clear, which is that extracted function we're getting from our custom hook, which is already wrapped in use callback. So now let's test whether that works by going again to the delete handler, removing the S here to force an error, log in, click on bananas. That's looking good. We can handle this. We can hopefully still add new apples. So that's all working. If I fix the error, of course, deleting will also work again. So if I delete my apples, that's looking good. So now we're using the custom hook here. Now another place where we can, of course, use it is the search component. In the search component, we're also sending a HTTP request. So there's no reason to not also use the hook there. To use it here, I will import it, of course. Use HTTP from hooks HTTP.js. And then just as before, call use HTTP up there, and then extract some data from there, which we're interested in. Now that might be less data than before. I'll keep it a bit simpler here. I'm interested in loading, I'm interested in data, I'm interested in potential errors, and I want to be able to send my requests. Since I handle errors, I also need the clear function. And now with all of that extracted, we want to send a request here where we previously called fetch. So I'll call send request here, and my URL is of course the same thing I had here before, so URL plus query. Method here is get, it's a get request. We need no body, we need no request extra. We also need no identifier, because in this component, this is the only request we're sending, so we will always be able to identify it. And hence we can get rid of all that logic here. I will keep that transformation logic because we'll need this in a second. And I will just cut this here. So now, for now, I'm just sending the request here if we decide that the time is ripe. Now to handle the response, I'll again use another useEffect call. By the way, the position, the order of the useEffect calls doesn't matter here. And this should of course execute whenever we got data, but it will also depend on loading and on an error. Because in here, I want to check if we are not loading and we have no error and we have data, let's say, then if that's the case, then we know we got some data back. Here I will now add this transformation logic. Response data is now just the data we got back. So we can simply replace the response data with data. And then we call onLoad ingredients. Now onLoad ingredients, therefore, of course, also is a dependency here. Oops, onLoad ingredients. That's also a dependency we need to add because we're calling it here. Now in the first useEffect call here, we depend on entered filter, we depend on the ref, of course, we depend on no more on load ingredients, but instead we now have a new dependency which is send request. So we should add this because we're using this function here. And functions are normal dependencies, just like other values. Since it's wrapped in use callback in our custom hook though, it will not trigger another call of useEffect. And that's exactly what should be the case. So now last but not least, we're doing all of that. Let's now also add error handling here. For that, I'll import the error modal from UI error modal. And if I now go down to the JSX section here, above that card, I'll check error if it's there. If we do have an error, I will render the error modal. And in the error modal, whoops, that should be 2 ampersand signs. In the error modal, I want to output my error then, which is the message. And on close of that modal, I want to call clear, right? Which is my clear function coming from my custom hook, which I'm extracting here. So now this is all being done here. Now to also show a little loading indicator, let's say between the label and the input, I'll not add the loading spinner here. It would actually distort the interface. Instead, I'll just check for is loading. And if that's the case, then I want to output a span with the text loading in there. If we save that and we log in, you see loading here as a text. And you also see this if I type here and then await. Like this. And therefore, this seems to work correctly. And if we check the network tab, we also see no infinite amount of requests there. Let's add some apples and then update the filter here. So that's all looking pretty good to me. And now we're using the custom hook also in the search component. Now I know that especially this custom hook thing can be confusing. Also because we built a quite complex custom hook here. You can definitely have simpler ones than this one, but I wanted to show one where you can learn a lot. The idea of custom hooks is that you share logic, not data. So what we do here is we share logic that we use in both the search and also in the ingredients component. And when we send the request in ingredients, this doesn't do anything in search, and the other way around as well. This is how it should be. You're able to share stateful logic across components. And it is stateful because in our custom hook, we're using useReducer to manage some state. And when we dispatch a new action here, this actually triggers React to rebuild the component where we use the hook. So we're not having a regular JavaScript function here, but a function where we can do certain things that will lead React to rebuild the component in which we're using this function, this hook. That's the idea of hooks. And whilst custom hooks can be confusing at first, they can be very powerful because we were able to move all of that HTTP logic out of this component, and instead we just send off some requests and we handle the responses in use effect. And that, of course, also is a pattern you have to get used to. Normally, you would expect send request to return a promise and then use then or async await to handle this. And you could do this, by the way. You could absolutely have send request return a promise. Here it's not returning anything. Well, we could, of course, return the result of fetch, and now send request would all of a sudden return a promise. You could do that, and you would be able to implement this in a totally different way. You would be able to simply listen to the response here and handle the response here instead of doing it in use effect. This split into a place where you send it and then use effect where you handle it can be especially confusing at first, but this actually embraces hooks and uses their full potential. Because I believe it's a very clean code in the end, where we have a clearly defined place where we change some data in our component here, and we could have multiple use effect called, of course, if we have multiple side effects. So we have a clearly defined place where we do that, and we have another place where we dispatch our actions, so to say, where we send our requests. Again, it is something that certainly takes time getting used to. It's not a must-do. You could return a promise and use your regular flow, but I think this split is very nice, very clean, and most importantly, this overall use of a custom hook and of hooks in general allows us to write very clean code with clear responsibilities, which can be challenging at first, but which ultimately will allow you to write better, cleaner, and probably also better performing applications. Now, this course section is a special section. Maybe you came here because I told you that you can come here in the first course section, or maybe you're coming here because you completed the course in the past and you want to go through the core concepts again. Either way, this section is for you because this section is a summary of what you learn in the course, of the core concepts of this course, I should say, and a refresher at the same time. This section does not replace the course. And if you came here because you want a quick summary and you don't know anything about React yet, that is okay. But if you have the time, definitely go through the full course instead. This section does not replace this course. If that would be the case, I would just have made the course 3 hours long. Instead, in this section, we're going to explore what exactly React is and why we use it. We're going to explore its most important core concepts again: components, props, state, React hooks. And we're going to practice React at a demo project and explore advanced concepts like effects and context. However, there are many variations, niche cases, behind-the-scenes pieces of information, and other concepts which are not covered here, because this is just a summary, just a refresher. This section is great if you wanna, well, refresh your knowledge or learn about the essence of React in the shortest time possible. Then you're right in this section. If you wanna get a deep dive into React, if you want to learn about all the features React has to offer, about variations of features, if you want to get a behind-the-scenes look, if you want to learn about testing and animations and deployment and much more, then go through the full course. Otherwise, let's dive right in and let's refresh and summarize what React is, what it's all about, and how you can work with React. So let's dive right into this video and this topic by answering the most important question first. What exactly is React.js and why would we use it? Why do we need it? What's the problem it helps us solve? Regarding the what, we can of course visit react.js.org, the official webpage of React.js. And there we learn that React is a JavaScript library, and it's a JavaScript library for building user interfaces. Now that's quite straightforward. It's a library for the JavaScript programming language that helps us build user interfaces. But what exactly does this nice sentence mean? React.js is a library, and to be precise, it's a client-side library. It's about client-side JavaScript. So the JavaScript code which runs in the browsers of your visitors. And that is important because we use JavaScript in the browser to manipulate web pages after they were loaded. And that allows us to build rich, highly interactive, modern user interfaces for our websites. Take something like Netflix, for example, which is actually built with React. There we can browse around, we can hover over one of the movies or series, and we get more details there. We can add it to our list, and we can go to that list page, and everything here happens very smoothly and also quickly. We never need to click anywhere and load a new HTML page. That refresh icon in the top left corner never spins. Because we never request a new HTML page, we never have to wait for a new HTML page to be generated by the server. And that happens because JavaScript is doing some work here, and it's updating what we see on the screen, the DOM, whilst we are working on that page. And that gives us that nice user experience, that nice UI, which we know from mobile apps, for example. When we work with a mobile app, we're used to things being very reactive. There we can work with the app and switch between different screens without having that latency, which we know from some websites, without requesting new HTML pages behind the scenes. So mobile apps therefore feel very reactive. Things happen instantly. We don't need to wait for new pages to load or for actions to start. And traditionally, in web apps, that was different. There, we often had to click a button and then wait for a new page to be loaded and to show up. And whilst that, of course, also does work, it is not the same user experience our users know from their mobile apps, and it's often not the user experience we want to deliver, therefore. Now, that's a problem we can solve with JavaScript in the browser, because that allows us to manipulate the DOM and therefore what the user sees without requesting a new HTML page and waiting for it. And therefore, just JavaScript would be enough. But let me give you an example of just JavaScript and why we might want to use something like React instead of just JavaScript. This is a very simple demo here. I have some content on the page, and when I click delete, I get this overlay where I can confirm or cancel. Now, both buttons don't do anything but close that overlay, as does clicking that backdrop, but what you see on this page here, or what happens when we click delete, all of that is controlled with JavaScript. I got a HTML file with some very basic HTML content, some styling, which we can ignore, and then the magic happens in this app.js file. In there, I got some code that in the end adds a listener to this main button which we got on the screen, so to this delete button here. And when that button is clicked, I fire this show modal handler function, and in there we run a bunch of JavaScript code to create various elements, divs, paragraphs, and then the cancel and confirm buttons to configure those elements and add text or CSS classes, and to add event listeners to those elements as well, to then fire that close modal handler function, which in the end removes the overlay, this modal as we call it. And then still in the show modal handler function, I got some code that combines all those created elements and brings them onto the screen. This is the JavaScript code responsible for opening this overlay here. Now it works and it's not too bad, but it's quite some code for this simple action. And here we only got one to-do in this demo application. If we would add multiple to-dos, if we would repeat this HTML code multiple times to render more to-dos on the page, or to even render those to-dos dynamically after fetching them from a database, for example, this code would become far more difficult, far more complex. For example, I couldn't just select a button on the page with that query selector, because we would have multiple delete buttons for multiple to-dos, and we would have to make sure that for different to-dos, different overlays are opened, and when we confirm the deletion, the correct to-do is deleted. We're not even doing that here in this demo, but that would be more complexity which we have to add and handle if we build a more realistic app here, a more realistic website. And therefore, just JavaScript works and can sometimes be a good choice, but it can also reach its limits. And one of the reasons is that with just JavaScript, you have to write every single step that should be taken. We want to create an element. We want to set its content. We want to add classes. We want to add a click listener. Then what should happen on that click listener? Every single step needs to be described. This way of programming and bringing something onto the screen is called an imperative approach. We simply describe action after action, step after step. And that can reach its limits. And in addition, even if we don't reach any limits, we as a developer have to take care about all the nitty-gritty details. We have to run the low-level code for creating a button, for setting its text content. And therefore, in the end, we reinvent the wheel over and over again, doing repetitive tasks. Now here's the same example with React. This works in exactly the same way, but the code looks very different. I got a React project here, and as a side note, you find both code repositories, both code snapshots attached. And here in React.js, this might look a bit more complex. We got more files involved here, but that's something we're going to learn throughout the course, why we have multiple files. But in the end, this is the main code that's responsible for bringing this to-do onto the screen. And what's very interesting here is that we have like a custom HTML component here, a custom HTML element. And indeed, React is all about those components. React is all about splitting your application into small building blocks, small components, where every building block, every component has a clear task, and therefore your code stays maintainable and manageable, and React, the library, will do the heavy lifting of rendering something on the screen and of combining all your code. So for example, if we look into the code for this custom element which we built here, which lives in this to-do.js file, then we here again see that I have some HTML code for rendering a to-do, but that we have some kind of placeholder in here, and then some kind of other code which we don't fully understand yet, but which we will understand and learn about throughout this course. And in the end, that's the code responsible for rendering such a to-do, and for rendering the modal, this overlay here, as well, and for rendering it conditionally. And what's interesting here is that even though we don't understand this code yet, and even though it's certainly strange that we have HTML code in JavaScript files, even though that's all weird, we can definitely see that we don't have a bunch of step-by-step instructions here. Instead, we kind of define what we want to have as an end result, and then we have some placeholders, some flexible elements there. And then we have very simple instructions here, which in the end then will be processed by React to change what's visible on the screen. And all these low-level instructions for creating elements and setting text content and so on, those instructions are not written by us when using React. Instead, they will be written or defined, if you want to call it like this, by the React library. We as a React developer work on a higher level, which makes working with React and which makes building complex user interfaces way easier. And that is why we want to use React.js. It makes building modern, rich, complex user interfaces easier, and it does so by giving us a higher level syntax where we write code in a declarative way, in a declarative component focused way. We define what we want to have on the screen, what the end goal is. We create these custom HTML elements, and React will do the rest. And one side effect, for example, is that if we wanted more than one to do, we could just copy that custom element, change maybe that text, that configuration, and boom, we got a second to do here. And we got a button on that to do which works as well. And that is why we use technologies or frameworks like React. Now, because things get easier with React and because we can build those rich user interfaces with React and JavaScript, when working with React, we often build so-called single-page applications. Because whilst we can use React to control parts of a HTML page, let's say some interactive sidebar, and therefore we add a widget, you could say, to a page where only a part of the page is controlled with React, it is more common to control the entire page with React, which means that we use React for everything we see on the screen and even for switching pages. So when we click on a link and we load a new page, as I did with Netflix when I clicked on my list, it looks to the user as if we switched the page, but we actually don't request a new HTML file from some server. Instead, we just used JavaScript through React.js to change what's visible on the screen. And that often leads to a smoother UI and a better user experience, as you see it at the example of Netflix. It's built with React, and there we never request a second HTML page. Hence, it's a single-page application where, after the initial request to the site, React takes over and controls what we see on the screen. Now, throughout this course, we are going to learn React in depth, and we're going to start with this basic dummy demo here to learn about some core concepts. And then later throughout the course, we're going to build this meetup project, this mini project here, where we see more React features in action and where we can practice all those basics and where we then at the end really understand how React works and which features it brings. Now, this course is about React, but it is worth noting that there are alternatives to React.js. Now, we're going to focus on React here, and React is one of the most popular front-end frameworks or libraries, however you want to call it, you can learn. It's a lean and focused component-based UI library. It really focuses on this component thing, and it doesn't have a lot of other features built in. If you need other features like routing, which we are going to learn about in this video, then you need to bring extra third-party packages. That's not horrible, but it is something to be aware of. React itself is really just focused on bringing stuff onto the screen and updating that for you and allowing you to build these custom HTML elements, these components. That's the core focus of React. Now, an alternative to React, which has more built-in features, would be Angular, another very important and very popular front-end framework. And I got a course on this as well. Angular is a complete component-based UI framework, so it also focuses on components, just like React, but it ships more built-in features than React. It also embraces TypeScript right from the start. And it can be overkill for smaller projects, therefore, since it has way more features built in. But for large projects, on the other hand, you don't need to rely on the community as much, because there's more built into that framework. So that's simply a little consideration you have to make. The syntax also looks a bit differently because whilst it is component focused, building these components works a bit differently with Angular than it does with React. Again, I got a course on that if you want to check out Angular as well. And we also have another very popular framework, another popular alternative, and that would be Vue.js. Vue.js is kind of like the mixture of Angular and React, in between those two extremes, if you want to call it like this. It's also a complete component-based UI framework, and it also includes a lot of features, but a bit less features than Angular, but more than React. It includes core features like routing, for example, and therefore with Vue, you also have to rely less on the community, and still you don't have as much overload, possibly, as you might have with Angular, depending on what you build. I also got a more detailed comparison video on these three technologies in case you're interested in that. Now, all three are super popular. React currently is probably the most popular, but all three are great. I got courses on all three, and therefore checking those out might be a good idea as well. But this course, of course, is about React, and therefore let's not lose any time. Let's dive right in. So let's get started with React, and let's dive into that React code and learn how to work with React and how to write React code. Now, in the project I showed you before, you might have noticed that I had a couple of files here in this React project, and these files are actually JavaScript files, but in those files, I then use HTML code. And that is not something you can normally do. Normally, you can't add HTML in JavaScript, at least not like this. You can add it as part of a string or of a template literal, but not just like that. That's not syntax that would work out of the box. That's not syntax that would work out of the box. And indeed, it wouldn't work just like this. That's why for working with React, we set up a project that's a little bit more complex than a vanilla JavaScript project. In the standard JavaScript project, I just have a HTML, CSS, and JavaScript file, and in the HTML file, I simply import those external files, and then they do their thing, because that is all just standard modern JavaScript. With React, to write React code in a convenient way, we can't just set up a project like this, because we want to use this HTML in JavaScript syntax, and the browser would not understand this syntax out of the box. That's why a React project is a bit more complex and involves more files, because it involves a so-called build step, which means the code we write will not be the code that ends up in the browser. We simply write code in a very convenient way for us as a developer, and then behind the scenes, that code will be transformed before it reaches the browser. And in addition to that build step, with a modern React project, we typically also want a development server which hosts our running React application locally on our machine, and which, for example, updates the page in the browser whenever we make changes to our code, so that we don't have to reload that page manually all the time. And because that's the kind of setup we need, we don't just create a couple of HTML and JavaScript files. Instead, we typically create a React project with an extra tool that gives us all that behind-the-scenes magic added to the project automatically. And the most popular tool for that would be Create React App. You can simply Google for create-react-app, and you either find this entry on the official docs or this GitHub repository. In the end, you can use either of the two. There you learn a bit more about it and that you might not need it, but in reality, for most React projects you do. And then you learn how you can set up a project with that tool. And it's in the end just one easy command. Now, for this command to be executable on your system, though, you need to install Node.js first. Now, Node.js is a JavaScript runtime that allows you to run JavaScript outside of the browser. We don't write any Node.js code with React. React is not a Node.js library or framework. It is about browser-side JavaScript instead. But we do need Node.js to install this Create React App tool or to use this Create React App tool. And the project generated by that tool will also use Node.js behind the scenes for this automatically reloading development server and for some code transformations which transform the code we write into code that runs in the browser. That's why you should visit nodejs.org and there install the latest Node.js version, whatever that version is when you're visiting this. Simply install the latest version here by clicking on it. That will then give you an installer for your operating system. It's available for macOS, Linux, and Windows, and it should automatically select your operating system here. And then you simply walk through that installer and install Node.js. Here I'm on macOS, but the process will in the end be the same on Windows. You can just accept all the defaults, don't need to change anything there, and that will then install Node.js on your system. Now, once that is done, you are ready to run this npx create react app my app command. And for this, simply open up your default terminal or command prompt on Windows, and in there, use the cd command to navigate into a folder where you want to create your React project, your development folder, your desktop, anything like that. Then, once you're in that folder, once you navigated there inside of that terminal or command prompt, run npx create-react-app, and then simply something like my first app, or in my case, React-course. Simply hit enter thereafter, and this will now create a new folder named React course in that folder in which you ran that command. And here I need to confirm that I want to temporarily install this Create React App tool. And then this folder will be created of that name you chose here. And in that folder, a brand new React project will be set up for you. Now, React project sounds like a big thing. It will still be a simple web page with JavaScript managed through React in the end. But because of these transformations I discussed, because of that, it will be a project where all these transformation steps are already pre-configured for you, so that you can focus on the code and not on the setup of the project. Now, this can take a short while, and if you're facing any problems here, make sure you got no firewall blocking outgoing traffic or anything like that. No antivirus tool that could be interfering here. And then at some point, you should be done. You should see output that looks something like this. Now, with that, we can cd into that newly created folder and then run npm start, which is a command based on the Node Package Manager, which is a tool that was installed together with Node.js, which will in the end execute a script that was pre-configured in that created React project. And when we run this script, a development server will be started, as it says here, which will host this React project. It should open a new tab in your browser automatically on localhost 3000 and display a starting project there, a starting website. If it didn't, simply manually go to localhost 3000 or whichever address is shown to you here. And then you should see something like this. The exact starting project can change over time, since the starting project template can be changed by the Create React App team, but ultimately you should see something like this. And that's now a little dummy website which was pre-built for us and which already exists in that starting project. Now we are going to get rid of that starting project here and build our own website though, our own React project. Now I did now open this React course folder which we created in the last step with my editor, Visual Studio Code. Now, you can use any code editor you want. If you have a favorite editor already, you can stick to this. But you should use some code editor to have a better time working with React. And here I'm using Visual Studio Code, which is a great free IDE for web development. It's available for all major platforms, macOS, Windows, Linux. You can simply download it from code.visualstudio.com. And then once you download it and installed it, simply open your folder that we created in the last step, this React course folder in my case, with Visual Studio Code. Simply with File Open or Open Folder on Windows. Now, once you did that, you should see something like this. Now, you can tweak the settings of Visual Studio Code if you want to. If you have a different theme and you want my theme, you can go to Preferences, Color Theme. I'm using the Dark Plus theme. And it is worth noting that with Visual Studio Code, under View, you can tweak the appearance of the editor. For example, if you have a status bar at the bottom and things like that, which I disabled here. And you can go to View Extensions to install extra third-party extensions into Visual Studio Code, which can add new functionality. Now, I got a bunch of extensions installed, which you don't need, but there's one extension which I do recommend, and that's the Prettier extension. You can simply search for Prettier here, and then install that extra extension. This is an extension that helps with code formatting, and which therefore helps with making your code more readable with a simple keystroke. For this, you then also want to make sure that under Preferences, Keyboard Shortcuts, if you search for Format Document, you have this shortcut bound. Because that Format Document shortcut can then use Prettier to format your code and make it more readable. For this to ensure that you use Prettier, you might want to go to your settings, to your user or project-specific settings, and then there simply search for Format, and under Default Formatter, you want to select Prettier VS Code, which should be available since we installed Prettier. Now that's the setup I'm using here in the end, and with that I got an editor configured for my requirements, which we can now use to dive into that React project that was created for us and which we can now use to write some React code. So let's now, as a first step, clean up this project to get rid of some of the starting files and then start from scratch again to learn React in depth. Now, this project, which was created for us, has a couple of starting files which we don't need here. For example, a file for automated tests. That is something which I cover in my complete guide course, but we don't need it here. So I'll get rid of that file and also of the logo SVG, report web vitals, setup tests, and app CSS. If you got more files, you can get rid of those as well. You should be left with an index.js, a app.js, and an index CSS file thereafter. Now in index.js, I will get rid of that import of report web vitals, and I'll explain these imports in greater detail in a second. For the moment, let's just focus on cleaning up. And I'll get rid of that code down there, and I'll get rid of that strict mode, because for the moment, for getting started, it is simpler if we just get started like this. In index CSS, I'll get rid of all that code as well. We're going to add different CSS code soon. And in app.js, there I'll get rid of these two imports at the top, and then of all the content here in this return statement, all this HTML code. For the moment, we can just add a simple div here where we say hello. Now we can save that, and that's now the starting setup with which I want to get started. You also find this starting project snapshot attached to this video so that you can also download it from there and get started with that. If you do download my attached snapshot though, there's one important step you must not miss and you have to go through. You have to install third-party dependencies of that project. Because since it is a bit of a more complex project setup, working with third-party packages like the React project works a little bit differently here. We got this package.json file which lists all the dependencies of this project. And there we, for example, see the React library, and another package, which is part of the React library, which are listed as dependencies. Now, these dependencies are managed and installed automatically for us, and a big code bundle with our code and that third-party library code will be generated automatically behind the scenes by those build steps which exist in this project as well. Those are brought in by that React scripts package. Now, I am aware that this sounds fairly overwhelming and complex right now, especially if you never worked with anything like React before and you're used to standard setups where you have a HTML file and a bunch of JavaScript imports, but we can't ignore all of that for the moment. We just add dependencies here, and we can then import them into our JavaScript files. That's what you see here with those strange import statements. And then this build step, which is part of this project setup, which is started when we run one of these scripts like npm start, which we did before. These scripts will then in the end combine and transform all the code and combine the third-party package code with our code and make sure that the result is an output which the browser understands. Now, because we have that setup, if you download my attachment, you need to run one extra command before everything here will work for you. And for this, it's best if you open the terminal or command prompt, which is integrated into Visual Studio Code with terminal, new terminal, which is your standard operating system terminal or command prompt, just already integrated into this IDE. And any commands we run here are then automatically executed in this project folder. And here you need to run the npm install command, which will simply download all those dependencies this project has and store them in this node modules folder, which we have here. That's a folder in which we will never work because that holds all these third-party dependencies and their dependencies which our project needs. So that's a folder which is here, but which was not part of the attached code because it's a fairly large folder, and hence the attachment would be unnecessarily big, and you can simply recreate it by running npm install in that folder that has this package.json file. So that's why we need to do that then. And thereafter, you can run npm start again to bring up that development server. And I will do that here again. And for this, I'll go to that other terminal where I ran npm start before, and I'll quit this process with Ctrl-C now. Now, as long as you don't quit that process, the development server is up and running and listening to code changes to then display them in the browser. You can quit this server whenever you're done with development for the day, and then you simply restart it with npm start again if you want to pick up development again. But now I'm not restarting it in this standalone terminal, but instead in this integrated terminal, which is already navigated into my project folder. And the advantage of starting it here is that I will always immediately see any errors that might occur if I have an error in my code, for example. And that's why I'll start it here, zoom out a bit, make this a bit smaller, and keep that up and running as long as I'm developing. So don't close the terminal, don't run Ctrl-C here, keep it up and running. And if you do that, and you go back to localhost 3000 and reload, you should just see hello there because of our cleanup process. Now, that was a lot of work just to get started, but I am a big fan of having a clean start and explaining what's going on here instead of just throwing code at you and leaving it up to you to figure out what's happening. That's the project setup we're dealing with, that's my IDE, and that's the cleaned up project, which you'll also find attached. And therefore now, let's start writing our own code and let's understand these different React features and this strange syntax here step by step. Now, with the project cleaned up, let's explore React and let's write our own React code. Currently, we got two JavaScript files here, index.js and app.js. The index.js file will be the starting point of our React application. The code written in here will be the first code that will be executed in the browser when we load our project in the browser. So what we see here in the browser is the result of this code line here executing in the end. Now, we don't fully understand this code line yet, but what we do in this file is we're importing a couple of things. That is how in modern JavaScript, supported by that build setup we have here, supported by that npm start script and what it does behind the scenes, how we combine multiple files and how we import features like objects or functions from file A into file B. And here we're, for example, importing the React DOM object from the React DOM library. So that's not an object we created. That is an object created by the React team, exposed in that React DOM library, which is part of our project because it's part of our dependencies here. Now on that object, we call a render method. And to that render method, we pass this strange HTML code. Now this HTML in JavaScript syntax here only works because of that build step, as mentioned before, and it's actually called JSX. This kind of code is called JSX code, this HTML in JavaScript code. JSX is a special syntax which is not understood by the browser, and which therefore is converted behind the scenes, but which is more convenient for us as a developer to write, because working with React will be about building custom HTML elements, these components, and combining them together. And that is way easier if we can just write HTML code, kind of, in our JavaScript files to describe the desired output. So here we kind of create or we use our own HTML element, the app element, which is actually imported from that app file. The file extension is missing here because for JavaScript files it can be omitted. And the second argument to the render method in the end just tells React where this element should be rendered in the real DOM. Now here we're selecting an element by ID with an ID root, and we can find this on the single page that is part of this project. We find it in the public folder. There we get a couple of images, but also one HTML file. That is the single HTML file that makes up this React application. Because I mentioned before, you typically build these single page applications with React where only one HTML file is fetched from a server, and then React takes over and controls the DOM and what's visible on the screen. Now in this index.html file, in the body section, we got a div with an ID root, and that ID root should look familiar. That is the div which we in the end select with this document get element by ID code snippet here. And therefore, in the end, what we tell React with that line is that we want to render our app HTML element, our custom HTML element, which is defined in this app.js file, into this place, into the place of this element with this root ID. So into the place of that div here in the end. That's what we're telling React. That's why if we visit our page and we inspect it, so we don't view the page source, but we inspect it with the dev tools here, when we have a look at the rendered DOM here, we see embodied that there is this div with an ID of a root, and in there we see our div with hello, which is the content we defined in app.js. And that should make sense because it is the app thing which we import from the app.js file which we render here. Now let's take a closer look at this app thing then. That is a function which we export to make it available outside of this file, but in the end, just a standard function, a standard JavaScript function. The only special thing about that function is that it returns such JSX code. So this HTML in JavaScript code. That's the only special thing. Other than that, it's a regular JavaScript function. And that is super important. What we have here is a so-called React component. We can use it like an HTML element, as we're doing it here in index.js, but it's of course not an HTML element the browser would know, but one defined by us, the developers of this project. Now this component, as it's called in React's world, this custom HTML element, is in the end just a function. A function which is defined and exported, and specifically a function that returns JSX. That's important. A component, so a function that should act as a component and be usable as a component by React, must return something that can be rendered in the browser. That could be plain text, it could be a couple of other things, but it can, and most typically will be, HTML code as well, so this JSX code. And what's interesting is that in the browser, if we have a look at the DOM again, we don't see our app element anywhere here. We don't see an HTML tag called app. Instead, we just see the content of our component here, this div with hello as a text. Because these custom elements, these are not known by the browser. We just write this code in our React application, and then when it runs in the browser, React will not render these custom elements, which wouldn't tell the browser anything, but instead it will render the content returned by these custom elements. And that's how these React components work in a nutshell. That is already one very important first piece of knowledge here. That we have these React components, which are functions returning JSX, which we can use to, well, tell React, and therefore in the end the browser, what should appear on the screen. But of course, we typically don't do that with just one simple component that just returns a div of hello. Instead, I mentioned before that I want to rebuild this basic first example with this delete button, and then thereafter dive into a little bit of a more complex project in a second step. And therefore, let's now work towards that first example with that delete button and that modal overlay. Now for this first example, for this delete button, let's remove this hello text, and instead inside of this div, I'll add another div. And before that div, a h1 tag where I say my to-dos, because that was also some text which we had there. And then this other div next to the h1 tag, inside of the outer div, that div will contain that single to-do item which we have in this dummy project. For that, I'll use a h2 tag for the title. And then below that, I want to have that delete button here. Now, I'm using regular HTML elements here, because when working with JSX, you can use your own elements, your own components if you have some, but you can also use all the built-in default browser tags, like divs, paragraphs, h1 tags, buttons, inputs, and so on. So in the end here, in the component, we just write the HTML code that should eventually appear on the screen. So the output that should be rendered by the browser. So for this, we have our to-do item here and some title above it. And on that button, I'll now say delete. That was the text we had here. Now for styling purposes, we're going to add some styling soon. I'll add another div here and actually put that button inside of that div. And now I pressed this format document shortcut to auto-format this code and make it a bit more readable. Now that's a more complex HTML structure, and if we now save this file and we reload, or actually we don't even need to reload because of this auto-reloading built into the dev server, we should see that output here. The title, the delete button, and my to-dos. Now, the delete button is not doing anything at the moment, and the title also is just static text, but we again see that we can influence what shows up in the browser with the code we define in our app component here. Now, some styling would be nice. And for this, I attached the index CSS file, which you also find attached here, which contains some basic styling for this first demo. You can simply replace your index CSS file with the attached one. And if you do that and reload, it looks a bit nicer. And we can also now add some CSS classes here to this code. Some CSS classes that will also influence the styling. For example, to this div, which contains the title and the nested div, I want to add a class of card. Now, in regular HTML, you would do that by adding the class attribute and setting this to card, for example. Now, this is not how you should do it with React. This code here looks like HTML, but it actually isn't. Behind the scenes, it is transformed to standard JavaScript. And in standard JavaScript, for one, class is a keyword, but even more important than that, if you look at vanilla JavaScript, the property name of a HTML element object for assigning or for setting the CSS classes on that object is actually class name, not class. That's just how vanilla JavaScript works. And therefore here, the attribute name actually also is class name. Now again, this can be confusing because it looks like HTML, and in standard HTML that would be class. But since this isn't HTML, since this in the end is JavaScript, just looking differently, we need to keep minor things like this in mind. Now, the good news is, however, that this is one of the very rare cases where the attribute name differs from the property name, and we have to use the property name here, and hence we don't use what we would write in standard HTML. In most cases, you can write standard HTML code here, and the class name is the most prominent special case in React, where you assign a CSS class to an element with class name as a attribute, in quotes, added to an element. But with that, if we save this again, now we have this card look of this to-do. Now, there are a couple of other classes that should be added. For example, on this div, which holds the button, you should add a class name of actions. And on the button here, we add a class name of btn for button. We do all of that. That's the look we get, and that looks a bit nicer. So now we also added some styling to our first component simply by changing the code in the index.css file and adding a couple of classes here, and therefore our first component is taking shape. However, at the moment, all that code is in one component, and there are a couple of reasons why we might want to split that up and also make our component a bit more flexible. This first code here for our to-do element exists in this app component. There's nothing wrong with it, but not only do we have some static text here, we would of course want the actual to-do title here. Not only is that the case, if we would want to add a second to-do, we would have to replicate this entire code block. And if we then ever want to change anything about that, let's say we want to add an extra span to that button, whatever, then we have to do this in all those places where we use the same code. That's not really what we want to do. That's why React embraces this concept of components, of building our own building blocks, which we then compose together. For this, I'll remove this duplicate code and instead create a new file. A new file in that src folder, which I'll name to-do.js. The name is up to you. The extension should be .js though, and that will simply hold another component. We're going to build our second component here. Now, typically those component files, except for that so-called root component, this app component, are stored in a separate components folder, which I also added in the source folder. So I'll move to-do.js into that folder. That's not a must-do, but it is a convention to keep your project organized. Now, in this to-do.js file, I want to create my second component, that to-do component. And we did learn that a component in React is just a function. So in the end here, we define a function, to-do, and then we export that. We need to export it like this, with this syntax, to make this function available outside of this file and usable in other files. Now, one important note about this function name though, you can name your component functions however you want, but there is one important restriction, one important thing to keep in mind. The name of the function should start with a capital character. That matters because when we later use this function as a component in our HTML code, so if we use it as a custom HTML element, then it will have to start with a capital character there as well to differentiate it from the built-in HTML elements. React wants custom components to start with a capital character. So now we have our function here. And then here in this function, we must return something that can be rendered to turn this function into a component. And that something is this div here. This div with the class name card. I'll cut it from app.js and then return it here in to-do.js and press that auto format shortcut again. So now that's our to-do function returning this JSX code. Back in app.js, we can now use this to-do component. And we don't do that by executing to-do like a function, as we would normally do that, but instead we use it as a custom HTML element, just as we did it with app in the index.js file. So here, where I cut the code from, I'll add to-do like this, as a HTML element. The only special thing here is that it's self-closing. Alternatively, we write an opening and closing tag. This would work as well. But since there will be no content between the tags, we can also write a self-closing tag. But then it has to have this /. It would not be allowed like this. Now, as noted before, it is worth pointing out here that this component, this custom element, when we're using it here in this JSX code, that there it has to start with a capital character. So to-do with a lowercase t at the beginning would not be valid, because React internally differentiates between built-in HTML elements like divs and h1 tags and custom elements by casing. All these built-in elements start with a lowercase character. Custom elements built by you or others have to start with an uppercase character. And that is just something to be aware of. Now, to use to-do in app.js, though, we need to import it from the to-do.js file. And for this, at the top of this file, we import to-do from /components to construct a relative path to that components folder /to-do. Again, the file extension of .js can be omitted here. That's now this to-do imported and rendered here. If we now save all files, we see the same output as before, which is good. That means that everything still works, but we're now getting to that output with help of our separate component. Now, if we want to have multiple to-dos, we just got to replicate this to-do component here in the app component, and we now have a couple of to-dos. And if we now ever want to change anything about that to-do component, about this HTML markup that makes up a to-do, we just need to do it in the to-do.js file, like adding this span, which has no real purpose but acts as a demo. And if we then save that file, we see that extra span in all our to-dos, because we define it once and then reuse it multiple times. Just as in vanilla JavaScript, we would define a function once and then possibly call it multiple times from different places in our application. It's the same concept here with React components. Though we don't need the span here, so I will get rid of that now. What we do need here, though, is some configurability. At the moment, all to-dos just say title. And that's not too useful. These should be different to-do titles for our different to-dos. And of course, I can change the title here to Learn React, but since I do this in this to-do.js file, this will now affect all to-do usages again. So all to-dos which we're outputting. So that's not how we make this more configurable. Instead, we want to let the place where we use the to-do, so the app component, pass different data into these to-do components, just as we pass arguments into functions when we call them, to then output different data in each to-do instance depending on which data we're passing in. And that's what we're going to do now. To make our component a bit more configurable and accept different data, we in the end want to utilize a concept which we know from the function world and from standard HTML elements. In the place where we used to do, so in this app component, it would be nice if we could add an attribute like text or title, totally up to you. Let's go with text, and then set this to some value, like learn React on the first to-do, then master React on the second to-do, and let's say explore the full React course in the third to-do. Now, it would be nice if we could do that. But if I add this here in app.js and save it, this has no effect on what we see on the screen. The reason for this is that we're setting these custom attributes, but in the to-do.js file, we have no code that would pick up those values. Nonetheless, this is how you do pass data into a component. We just also need to write some code in the component to then accept and use those received values. And we do that with a concept called props. We accept a parameter in our function component, and in every function component, we can accept that parameter. And that parameter is typically called props. You can name it whatever you want, since it's your code, but it's called props because this React concept is called props. This will be an object, props will be a JavaScript object, where all the attributes added on the element are in the end available as key value pairs in this props object. So here, these attribute names will be the keys, and the values will be, well, the values. So props inside of the to-do component will be an object now that has a text property and then different values for this text property. And if you named this attribute differently, that's also okay. You will then have a property of that name in your props object. So therefore now here in this h2 tag, we want to output this text we're getting on this props object. Now, in standard JavaScript, we access object properties with the dot notation. So we could output props.text here to access the text property in the props object and therefore the value stored in this property. But if we do this here, we just see props.text as an output. The reason for this is that everything here in this JSX block is treated as HTML elements or plain text. The good news, however, is that we can also output dynamic expressions as part of the JSX code. We can tell React that something should not be treated as plain text, but instead as a JavaScript expression that should be evaluated. And we do this with a special syntax inside of this JSX code, which looks like this. Opening and closing curly braces, single curly braces. And between those braces, you can have any JavaScript expression you want, like for example 2 + 2. Now this will not be treated as plain text, but instead it will be executed as JavaScript. So if I save this, we see 4, the result of this expression. Now you can have any single line expression in here, but you can't have any block statements here. So adding an if check here would not work. But what does work is referring to props.text here. So simply outputting the result of accessing this text property on the props object. If we add this code and save this, we see our different texts here for the different to-dos. And now we build our own truly reusable React component here, the to-do component. It is truly reusable because now it does not just have some hard-coded structure and text inside of it, but also some dynamic code using this core concept built into React, the props concept, for accepting data from outside, so from the place where it is being rendered. That is a key concept, this props concept, and that is how you build reusable custom elements, reusable components. And that's therefore a major first step here. Now let's make sure that we handle events, that we handle a click on the delete button, and that we then also change something on the screen when the button is clicked. To be precise, that we present this nice overlay when that delete button is clicked. So let's now make sure we can listen to a click on this delete button. In vanilla JavaScript, so in just JavaScript without React, we would find a way of selecting this button, for example with document query selector button. And then once we got hold of this DOM object, we could add a click listener with add event listener. Now this is again an imperative approach. We describe what should happen. With React, we rather use a declarative approach describing the target result. And hence this is not code we write in React. Instead, with React, if we want to listen to a click on this button, we add an extra attribute on this button. And for this, it's important to understand that all these default HTML elements are in the end also just React components. Just React components that are built into React already. So they look like regular HTML elements and you use them like regular HTML elements, but under the hood, these are components. And that matters because that means that you can add certain attributes which you could not add like this, at least with just HTML. For example, on a button, or actually on any HTML element here in JSX, you can add an onClick attribute written like this: lowercase o, uppercase C. And the casing does matter. Unlike in regular HTML, here it does matter. Now, when you add the onClick prop, as it's called, as you learned, to a button or to any other element, you're telling React that you want to react to a click on that element. Now, the value you assign for this attribute is then not some text, not a string, but instead a dynamic expression which should hold a function that should be executed when a click occurs. So here we could define an anonymous inline function like this, or also with the arrow function syntax, which you can use in modern JavaScript, or you point at another function. And I'll do the latter. I'll create a new function, and important, I'll create it as a nested function inside of the to-do function. And that might look weird, but that's actually standard JavaScript. In JavaScript, also without React, you can define functions inside of functions. So here I'll add a function inside of the to-do function, inside of that to-do function component, and we could name this delete handler. The function name is totally up to you. I personally like this convention where functions which are executed upon events end with handler, but other people don't use that, but instead might use handle delete or just delete. Totally up to you. I'll go with delete handler here and then point at this function as a value here for this onClick prop, simply by repeating the function name here. And now here is an extremely important thing to keep in mind. You don't execute the function here, so no parentheses. If you would execute it here, this function would be executed as soon as JavaScript and React evaluates this code. So when this line of code is evaluated, the function would execute. Now that is too early though. We want to execute the function when the button is clicked, not when that code is evaluated by JavaScript, because that happens right before that content is rendered in the browser. Hence, we just point at this function by just using its name here, and that just tells React in the end that it's this function that should be executed when this element is clicked. And now in here we can do whatever we want. For example, we can console log clicked here for the moment. And if we do that and save this, if I go to the JavaScript console in the DevTools, if we click one of these delete buttons, doesn't matter which one you click, you see clicked. Now we could also output clicked and then as an extra log props.text, so that text value which we receive via props, which I also output down there in the h2 tag. I'm now referring to it again here, because this is just standard JavaScript in the end, even though this JSX code definitely doesn't look like it. But up here, we write standard JavaScript, and hence, of course, here we can also use one of our arguments. And if that argument turns out to be an object, which props is, we can also drill into that object here. And with that, if I save this and click delete, you see the proper text being output here as well. And maybe it's not clear here, but that's another strength of React. Without any extra work from our side, these 3 different buttons are doing different things. I mean, they're always doing the same thing. We just defined this logic once, but the concrete values with which they work, the concrete text which they output, is not the same. Instead, it's different for every button. And that means that we can easily write logic that's specific to a specific to-do, whilst still being able to define this logic once instead of 3 times, which is great and makes our code way more reusable. But of course, here the goal is not to log something to the console. Instead, we want to show a little overlay when that button is clicked. And for this, of course, we need to, first of all, create that overlay. We need to create the HTML code that should be showing up. And then as a second step, we also need to find a way of showing it conditionally. Now let's start with creating the code for the overlay. For this, I'll add a new component. We could add the code in the existing component, but it is considered a good practice to put every building block into its own file, every component into its file, and to avoid very long JSX blocks by instead splitting it up into separate components. Now, when you should make a split, that's something which will come with experience, and you'll see a couple of examples throughout this course here. But in general, you want to keep your component functions small and maintainable. The JSX code that belongs to a component shouldn't become too complex. And therefore, I'll add a new file in the components folder, and I'll name it modal.js, because that's the component that should be responsible for rendering a modal, this overlay. That's typically called a modal. And in here, we therefore create another function, the modal function, and we export this function like this. And here we can also accept this props parameter. As I mentioned, every component function gets this parameter. It's passed in automatically by React. But of course, if you don't use this parameter in a function, if you don't use it in a given component, you can also omit it. And here, for the moment, I will omit it. Then we need to return something here, something which can be rendered by the browser, as we learned. And for me, that will be another div. And in that div, we can then have a paragraph, let's say, with a text of "Are you sure?" or something like this. And below that, let's say 2 buttons. One button where we say cancel, and one button where we say confirm. Now in this demo, the buttons won't really do anything except for closing the modal. But of course, in a bigger application, you could then trigger different actions based on which button was clicked. But again, that's just a first demo. We're going to see a slightly bigger app thereafter in this course. So for the moment, it's this div. Let me format this with a paragraph and 2 buttons. Now we want to add some styling. So on that div, I'll add a class name, as you learned, of modal. And on the buttons, I'll also add some class names. On the cancel button, it's button, and then another class named button-alt. And these are simply classes defined in the index CSS file I provided to you earlier. And then here on the second button, it's just a button. And that's now the markup for this overlay component. Now, in addition to this overlay, we also want to have a backdrop, some gray background behind the modal, which blocks interaction with the page whilst the modal is opened. And for this, I'll add another component, the backdrop component in a backdrop.js file. And that will also be a straightforward component, simply a backdrop function here like this. And then we export this as a default. And here, I just want to return a div with a class name of backdrop. This div has no content, and therefore we can write it as a self-closing tag, actually. In standard HTML, you would not write it like this. Their divs are not void tags. But in JSX, you are allowed to do that if you have no actual content between the opening and closing tags. And here I just render this div because of this styling, which is added by this class, and hence I need no content, and hence we can write it like a self-closing tag. Okay, so now we got the backdrop and the modal. Now we can use both, and for the moment, we will always show both. So for the moment, we can go to app.js, for example, and below all these to-dos, we can now also output the modal as a self-closing tag like this, and the backdrop as a self-closing tag like this. And we again need to import these two component functions in order to use them here. So we import modal from /components modal, and we import backdrop from /components backdrop like this. If you now save all your files, you should see something like this. Let me zoom out a bit. Something like this. This is our modal. And at the moment, it's always visible and we can't close it. Because that's now one big missing piece. We know how to build components, how to build reusable components, and how to build our interface. But at this point, our interface is 100% static. It never changes. What we output here, that never changes. No matter how we interact with it as a user, the interface always stays the same. And of course, that's typically not what you want in a web interface. Things should be interactive and things should change. That's one of the main reasons for using a library like React. And therefore, let's now explore how React makes sure that we can change what we see after the page was loaded. In order to change what's visible on the screen, we need to change the state of this app, so to say. Now, attached you find an extra article and video which I created, where I explain what state is. In the end, you can take it quite literally, though. The current state of this application is that we have 3 to-dos and this overlay is open. Now, we would like to also be able to present another state, where this overlay is closed. And we want to switch between the states. When we click on delete, then it should open. And when we click on cancel or confirm or the backdrop, it should close. So that should be our ways of switching between the states. And React has a built-in concept that helps us with that. And conveniently, it's called state. For this, let's go to our to-do.js file, to our to-do component. Here we got this delete handler, this function which is triggered when the delete button is clicked. When it is clicked, we would like to switch to the state where the modal is open. To make that happen, we need to import some functionality from the React library. So we import from React. Important here, we have no // because React is a third-party library. You import from those by just referencing the library name. And then we import something like this with curly braces. We import the useState function. That is a function exposed by the React library, which we can use in our component functions. With useState, we register different states which we want to support in our React application, and React will react to changes in that state and allow us as a developer to render different output depending on which state is active. Now, that all starts with calling useState directly in our component function like this. So not inside of the delete handler, instead directly in the component function. Use state is a so-called React hook, and those React hooks can only be called directly in React component functions and in custom hooks, which is a topic we'll not discuss in this course, but which is discussed in depth in my complete guide as well. For the moment, it's enough that we know that we can use React hooks in React component functions. Now, calling use state creates a state React is aware of. Now, we can give this state a starting value by passing it here as an argument to use state, and that could be false if our state is that we want to control whether the modal is open or not. And initially, it should not be open, so the initial state is false. Now, use state always returns an array with exactly 2 elements. That's how use state works. It always returns an array with 2 elements, and we can store this returned array in a constant, or we use array destructuring, which is a JavaScript feature, to store these 2 elements, since we know that it will be always 2 elements, in different constants. And we could give the first constant a name of show modal, or modal is open, or anything like this. And the second element here, the second constant, a name of set modal is open. Now, why did I choose these names? Because the first element, which use state returns in its array, is the current state snapshot. So this value, which is stored in this state. You can think of React state as a variable, which is managed for you by React. You define the initial value here, and you will then also be able to change that value. Now you get access to the currently stored value through this first element here. The second element is a function that allows you to change that value. Because you don't change it by assigning a new value to modal is open, instead you always call this second function to assign a new value. Why does this matter? Because whenever you call this state changing function, React will in the end re-execute the component function to which this state belongs and re-evaluate it, and also update what's rendered on the screen. This allows you to pick up the latest state value and possibly render something different depending on the state. Now, this might still be a bit abstract. It will become crystal clear in a couple of seconds. What we can do now with these 2 elements is that in delete handler, we call set modal is open and set this to true to change that modal is open state from false, which is our initial state, to true. And then we use modal is open to conditionally render the modal and backdrop down there in this JSX code. So I go to app.js and I remove modal and backdrop from there and remove the imports, since we're not using modal and backdrop in this file anymore. And instead I'll go to to-do.js and import modal there from /modal, and import backdrop here from /backdrop, constructing the relative paths to these files as seen from inside this to-do.js file. And since modal and backdrop are neighbors to this file, the paths look just like this. And then we can use these components down here, let's say here in that div, modal and backdrop. Now, if we add it like this, they would always be rendered. I only want to render them if modal is open is true, if that state has a value of true. Now we are changing the state here. To use it, we can simply output a dynamic expression down here and check if modal is open is truthy, like this, and then write a ternary expression where if this is true, we render modal. And that might look strange, but that is code which you can write, else we don't output anything. So we render null. This certainly looks strange, but that is how you can render content conditionally with React and JSX. In these dynamic expressions between the curly braces, you can again use JSX, and that's what I'm doing here. So I'm checking if modal is open is true, and if it is, I render the modal, otherwise I don't render anything. And we can actually use a short trick or shortcut here and use the double ampersand, the logical AND operator here, like this, to simply use the fact that in JavaScript, if you use this operator, if both conditions are true, the second value will be returned. So if that is true, and that is true, and a function, a component function will always be true, then this component function is output here. And that's simply shorter than writing this ternary expression. We can now repeat that modal is open check here for the backdrop, and with that, we only output modal and backdrop if modal is open is true, and not if it's false. And we do this for every to-do component. So if we save this file as well now, we don't see the modal right now, but if we click on delete, we see it. And now we can't interact with the rest of this page because of this backdrop. So that's a great step forward. How can we now get rid of that modal though? To get rid of the modal and the backdrop now, we need to change the state again. From set modal is open true to false. We need to call set modal is open again and pass false as a value. The problem just is, when do we want to do that? We want to do that when the backdrop is clicked or when the cancel or confirm buttons are clicked. We don't want to do that if the modal itself is clicked, for example. Now for the backdrop click, you could think that on backdrop, you simply add on click again, and then we add a second function here, the close modal handler, let's say. And there we call set modal is open and set this to false. And then we point at this close modal handler here as a value for on click, just as we did it with the button in the end. But that won't work. If we save that and I reload, I can click the backdrop the entire day, the modal won't close. The reason for this is that the backdrop, like the modal, is our own component. These are not built-in components. So they don't know the on-click prop. Our own components have to be configured 100% by us. They have no built-in props which we can use. To be precise, they actually do, but only for some very special cases and not for event listeners like this. So if we want to make sure that an on-click prop exists in the backdrop component, we have to add code to this component function to support this prop. And for this, we can go to the component function and accept this props argument here, this props parameter. And then here, we can, of course, work with an on-click prop or any other name we want. It's totally up to you because it's our component. But here we can, for example, expect an on-click prop because I'm setting this here in the to-do component. And we actually expect a function as a value on this on-click prop. Because in the to-do component, I do pass in a function in the end. I point at a function, which means I pass a pointer to the function as a value for this prop. Now, in the backdrop component, we actually want to call this function, which we receive on the on-click prop, when this div is clicked. Now, the div is a built-in component again, so it does have on-click prop. And now we could simply point at props on-click as a value here. By doing this, we would in the end forward the function which we receive on our props here, on our on-click prop, into that div on its on-click prop. And these names don't have to be equal. We could expect an on-cancel prop here instead, and in to-do component rename this to on-cancel. It's our component, so we can name this however we want. Now, if we do that and save all the files, if I reload, now we can close the modal by clicking the backdrop. Because now we're using a prop to pass a function as a value. And that's a pattern which can be confusing and might look strange at first, but keep in mind that in JavaScript, functions are first-class objects. You can pass them around as values just as you can pass strings and arrays and objects and numbers as values. Hence, you can pass a function as an argument to another function, and therefore also as a value for a prop to another component. And then that function which we receive in that component can be executed in that component, or, as we're doing it here, it can be forwarded to yet another element, another component. Now we can use that same approach in the modal component for canceling and confirming. There we could add functions like the cancel handler and then let's say the confirm handler, and kick off different logic depending on which button was clicked. But in this case, I'll simply, in the end, run the same code in both functions. Nonetheless, we can bind the first button with the onClick prop to cancel handler. And here it has to be onClick because that's not a custom component, but a built-in one. So here we can't come up with any other name. And for the confirm button, I'll also add onClick and point at the confirm handler. And now in these functions, we can run any code we want. In this case, though, I also want to just close the modal. So again, I'll just accept the props parameter here. And in cancel handler, I'll just execute props on cancel, let's say. In the confirm handler, I'll execute props on confirm. And hence, instead of defining these functions here and pointing at them here, we could have also just forwarded props on cancel here like this, just as we did it for the backdrop. I'm just showing this alternative approach to make it crystal clear that you can execute these functions which you receive through props. You can forward them to other elements if that's what you need to do, but you can also execute them anywhere in your components. And hence, I'm using this alternative setup with these extra wrapper functions, at which I then point here. And now we got an onCancel and an onConfirm prop, which are expected on that modal component. So in the place where we use the modal component, we should add onCancel and onConfirm. And here in both cases, I'll just point at the close modal handler, because as mentioned before, here I got no special logic, I just want to close the modal. With that, if we save this and reload, we can not just close the modal by clicking the backdrop, but also by clicking cancel or by clicking confirm. And that works for every to-do here. For all to-dos, the modal works in the same way. And that's therefore another very important building block of React. Props are important for building reusable components. State is important for changing what we see on the screen dynamically, for adding or removing elements, for changing text on the screen, or, like in this case, for showing and hiding an overlay. So now that we picked up those important React basics, it's time to dig a bit deeper to dive into some advanced concepts like routing, sending HTTP requests, and application-wide state management, and what all these things are. We're going to explore that. And for this, we're going to leave this basic project, this basic demo we worked on. Instead, we're going to build this meetup demo application I showed you earlier already. And for that, I cleaned up my project. I removed basically all the imports and all the content from this app file here. And index.css has some new content. You find my updated project attached. So there you also find the updated index.css file. And I deleted all the components. Now, as I just said, you find this updated starting state attached, and you can therefore then start with that same project. In the end here, once you downloaded it, you need to run npm install again. Then once that's done, you can npm start this project again to bring up that development server again. And that will give you a blank page. Because now we're going to build this project from the ground up, and this project will now involve more components than the previous one, and it will involve the important concept of routing. Now, what does routing mean? Consider this Netflix example from before again. There I went to the My List page to view the items I added to my list. Now, it looks like I visited a totally different page, but if you watch this refresh icon in the top left corner, you see that it never changes. It never goes into that loading mode. Because actually, we never fetched a new HTML page. The page loaded by the browser never changed. We always stay on that single page. And that's the case for Netflix, because they also have such a single page application. It should also be the case for our project now. I want to give the user the illusion of having different pages to which we can navigate, whilst actually staying on one and the same page and leaving it up to React to change what's visible on the page. The advantage of this approach is that we never have to wait for a new page to be loaded. Instead, we can always stay fast, stay reactive, because everything is handled by client-side JavaScript, which is faster than sending a new request to a server. And that can really enhance the user experience. Now, therefore, we want to add something which is called routing to our project. We want to add a router, a special tool which actually watches changes in the URL and then changes what's visible on the screen based on the URL. So which basically gives us a way of giving our users this illusion of routing. And for this, I'll actually quit this development server again and install a new dependency, a new third-party package into this project. We do this with npm install, with the npm install command, but now not just executed like this, but instead we now add a package name thereafter. The name of the package which should be installed, so downloaded, into this project here. And that's the React-router-DOM package. That's a package which, as the name kind of implies, allows us to add routing functionality to React. So it allows us to handle URLs and change what's visible on the screen without fetching new HTML pages. Simply hit enter and this package will be installed. And in package.json, you'll see that a new entry was added. So that file was automatically updated, which means that if you now share this project again without a Node modules folder, and someone then runs just npm install again, that newly added package will also be picked up and installed because it is part of this package.json file. Now we don't need to do this here because we just did install it. So we can run npm start again to bring up that development server again. And now we can add routing. But what does this mean? What does add routing mean? In the end, it means that we need to add this routing tool to our code so that we have this thing watching for URL changes. And we need to let this thing, this tool, know which component should be loaded as a page for which route, for which URL. And for this, I'll start by adding a new folder next to the components folder inside the src folder, and that's the pages folder. You don't have to add this folder and you don't have to name it pages, but in the end here, this is a good way of differentiating and of separating our components that are embedded in other components, which will be stored in the components folder, from the components that will be loaded as pages. Technically, we'll build components in the same way, no matter how we use them. But for us as a developer, to have an easier time to quickly find the right component we want to work on, I'll separate them into these two folders. And in the pages folder, we're now going to add a couple of React components, which again will be built just like all the other components, but which will be loaded by this router we just installed when certain URLs are visited. And here for this application, for this project we're building here, I'll add a all meetups.js file, so a component that will be responsible for loading and displaying all the meetups we have. I'll add a new meetup.js file, and I'll add a favorites.js file. New meetup will allow us to add a new meetup later, and favorites.js will allow us to view our favorited meetups, because we'll add a functionality that allows us to bookmark, to favorite a meetup as a user. But step by step, for the moment, I'll just set up some dummy components in these free files. And I'll start with all meetups, and I'll name this component function all meetups page. You can name it however you want. I'll just choose this name to make it clear that this component will be used as a page that's loaded by this router. Now, just as all the other components we built before, this component has to be exported, and it needs to return some JSX code. And for the moment, I'll just return a div where I say all meetups page. That's of course not the final content, but some starting content for now. Then we can copy this and add it in the favorites file here. So this is the favorites page, and we want to export the favorites page. And here I'll then say favorites page, and then save this and copy this into new meetup and name this new meetup page, and also use that name for exporting. And here we say new meetup page. Now we got these three page components. Now we need to use that router package to define when which page should be loaded. And for this, we first of all need to go to index.js and wrap our app component, which we render here, with another component. For this, we need to import something from React-router-DOM. And that something which we import is the browser router, like this. Now it turns out that browser router is in the end a component itself. And therefore we can use it as a HTML element, opening and closing tags, and wrap those tags around the app component. Now that is something we haven't seen up to this point, that a non-standard component, so a non-HTML component, would be wrapped around something, but it is something we can do, and it is something we are doing here. We're going to learn how we make our own components wrappable a little bit later in this course. So now we initialize this router package. We make it aware of this app, and we ensure that it watches our URL, so to say. Now, as a next step, we need to define the URLs we want to support and which pages should be loaded for the different URLs. And we do this in the app component now, so in this wrapped component. In there, we return a div, and we can leave it like this. But now in this div, I want to return or use other components which are also imported from React Router DOM. So we also import React Router DOM here, and here we import the route component. So just like browser router, route is a component, and we use it like a component, but the job of the route component is to define different paths in the URL we want to listen to, and which component should be loaded for these different paths. And therefore, I will also already import my three page components here, the all meetups page from /pages all meetups, and then the new meetup page from .pages new meetup, and of course also the favorites page component from /pages favorites. And now in this div here, we can use the route component, which I'm importing from React Router DOM, and give it a path prop, a path attribute. Now path takes a string, and that will be the path in the URL after your domain. So in our case, our domain is, for example, localhost 3000. That's our domain. Of course, on a real server after deployment, that would be something like mypage.com. And now the part after the domain is the path. That can be just a slash, so no path at all in the end, or it can be something like /favorites or /products or anything like that. So the part after the domain is the path, and here we define for which path which component should be loaded. And here we can start with /nothing to handle the default path that we just visited our domain /nothing. And then between these route tags, we actually do now add the component that should be loaded, like the all meetups page like this. Because that should be the starting page actually. We can add another route here for, let's say, /new-meetup. And the path is up to you. If we now visit mydomain.com/new-meetup, then the component which we render between these route tags will be loaded. And that could be the new meetups page. And last but not least, we can also define a route for the path /favorites and then render the favorites page like this. Now we're defining 3 routes, and instead of this content here, the actual page component will be rendered if that route determines that the current URL matches this path. So if we are on mydomain.com/new-meetup, this new meetup page component would be rendered and not the favorites page, for example. So if we save this and we go back and reload localhost 3000, we should see the all meetups page here. But if we go to favorites, for example, we see favorites page as well. But wait a second, is this the desired result, that we see it as well? Well, it depends. In some applications, depending on what you build, you might want such a nested page so that the page for just /nothing is rendered, but also this specific page for /favorites. We see this output because by default, React Router matches all your paths, and it simply checks if the current path includes these paths here. And /favorites includes both /favorites as well as just /, which is why both components are rendered. Again, that could be what you want, but often it's not. That's why there is another component provided by React Router DOM which helps us, and that's the switch component. We can use the switch component to wrap all our route components like this, and with that we tell React Router that only one of these routes should be active, so at most one of these pages should be rendered. If we do that and save this, we don't see 2 components being rendered, but we don't see the correct component being rendered either. Instead, for /favorites, we now see all meetups. And the reason for this is now how your routes are matched. React Router by default checks if the path of the current URL starts with the paths defined here. And because of switch, it will then stop looking at the other routes as soon as it has a hit, as soon as it finds a match. Now, of course, /favorites starts with just /, and then because of switch, it doesn't look any further, and therefore all meetups is rendered. That's not what we want, and we can prevent this by adding the exact prop here on route and setting this to true. Though you can also shorten this, and if you have a prop which you just want to set to a truthy value, you can just add the prop name like this. So we add the exact prop and set it to true to this first route. And the exact prop tells React Router that for this route, it should not check if the path begins with this path, but if the full path matches this path. And that's now, of course, not the case for /favorites. So this will not create a match, and it will continue looking, and it will ultimately find this route for /favorites. So now we see the favorites page. For new-meetup, we see the new meetup page. And for just localhost 3000, we see the all meetups page. And that's how we can add routing. But of course, at the moment, we're just navigating around by entering URLs manually. And that's not very realistic. In reality, we would probably want some header, some navigation bar at the top, which provides different links. And therefore, that is what we're going to add next. Now let's take care about adding such a navigation bar to our application. And for this, I'll go to the components folder and add a new folder in there. And I'll name it layout because it will hold some general layout components. So a subfolder inside of components. And in there, I'll add the main navigation.js file, which is the file that should hold this main navigation component. Now I added it here in the components folder and not in the pages folder because this component will not be loaded as a page with help of the router, but instead we will embed it in the content of our other code, just as we did before, totally unrelated to the router. Now in this main navigation component file, we can again define our component function, main navigation, and export it as we're used to. And then of course return some JSX content here. And here I want to return a header component, which in the end will then wrap all the items that should go into this header. And here I actually want to have a div first with my logo, which in this case will just be some text. I'll name it React Meetups. And then next to this div, inside of the header, I'll add a nav element. And here I'll then add an unordered list with a couple of list items, where all those list items will be the different links which we have here. Now, when it comes to those links, we typically render links by using the anchor tag. That's how we do that in standard HTML. We could do this here as well, but using that link component, that link element, has one big disadvantage. If we use a link like this, whenever we click it, a new request will be sent to the server. The server here is the server hosting this React application, and indeed that server would then reply with our application, and there the router would figure out which page to load. So a link would work, but we sent this request first, which is redundant. We already are in our running React application, and it would be great if we don't leave it just because we want to navigate somewhere. Hence, sending that extra request is not something we necessarily want to do. That's why instead of this anchor tag, we instead use another component provided by the React Router DOM package. So we again import from React Router DOM, and we import the link component here. The link component can be wrapped around our link text, just like the anchor tag, and it will render an anchor tag in the end, but internally, React Router DOM attaches a click listener to the anchor tag, and when you click on it, it will prevent that browser default of sending a request, and instead just parse the URL you want to go to, change it in the browser URL bar, but then not send a request, but instead load the appropriate component onto the screen just with React and JavaScript, so that we stay on this already loaded page and we don't send this extra request. So that's why we add links like this. Now, of course, here that should not be some link, but a link to all the meetups, let's say. And to make link aware of the URL it should navigate to, we have to set the to prop here. This is one of the expected props on the link component. And here we set a path, in this case just /nothing, because that is the path to the all meetups page. Now we can replicate this and add two more list items, where the second one leads to /new meetup and says new meetup, or add new meetup. That's up to you, of course. And on the last link, we go to /favorites and we say favorites or my favorites, something like this. Now we got those links in place and we got this main navigation component. we can now use this in the app.js file, and there we can now import main navigation from /components/layout/main navigation and add this above that switch statement. Here we can add main navigation as a self-closing tag still, if we want to. If we save this, we'll see some navigation here. And if we click those links, they work. The styling is missing, but we got working links. We got a working navigation. Now I want to add some styling, and for this we're going to explore a different way of styling our components. In the first demo application we built, I gave you one CSS file that contained the styles for all components. That works for a small demo, but not necessarily for a bigger project. There, you typically want to have different CSS files for your different components. And hence the CSS file which I provided to you here is very slim. Now, when it comes to styling the different components, it would be even nicer if the styles set up in a specific CSS file would then be scoped to the component to which they belong. So it would be nice if next to main navigation, we could add, let's say, a main navigation.css file, and then define the styles in that file that belong to this main navigation.js file. And they should not affect any other component. That's something you often want, because in bigger React projects, you often work with hundreds or thousands of components, and you want to make sure that your styles don't clash with each other. Now, the good thing is that Create React App, this tool which we used for creating this project, gives us a project that has a feature built in that allows us to scope styles to components. And that feature is called CSS Modules. It's a behind-the-scenes code transformation which will make sure that we can attach CSS files to specific components. For this, we first of all need to name our CSS files in a certain way. We need to make sure that they end with .module.css. So in this case, the file is named main navigation.module.css. And then in main navigation.js, we can import from this CSS file. That certainly looks strange, and it's not something that would work in standard JavaScript. But since we have this extra build step here, which parses and transforms our code before it reaches the browser, we can actually import from CSS. And that is what we're already doing in index.js, by the way. We're importing a CSS file, and behind the scenes, that will tell the build process that this CSS code should be injected into the loaded page as well. We can do the same here in main navigation.js, but now to attach this styling or this style file and its classes to this component, we don't import just main navigation.module.css like this, but instead we import something, for example, classes, this name is up to you, from this file. Now I named it classes because this something here, which we import, will actually be a JavaScript object where all the CSS classes you define in this CSS file will be properties of this object. And you can then use them in your JSX code to attach those classes to your elements. And behind the scenes, everything will be transformed such that those class names are made unique per component. So let me give you an example. We could go to the header JSX element here and add the class name prop and set this not to a hard-coded string, but instead to a dynamic value with curly braces and set it equal to classes.header. Now we can add a class named header, because here I'm accessing header on classes, to this CSS file. And any styles we define in here would then only affect this component here. So if I save this and I gave this a red color, you see now that's colored red. And if I had another header class in another component, it would not be red because the styles are scoped, as I just explained. Now the goal is here not to make this red, but instead I prepared some other styles for you, which you find attached. You find a main navigation.module.css file attached, and you can simply replace your main navigation.module CSS file with mine. Now in here I defined a bunch of styles for you, and therefore we now just have to wire them up to the elements. We already added the header class to the header. On this div with the logo text, you should add classes.logo, and that's actually it already. And with that, if you save this, let me zoom out a bit, now we got this good looking navigation bar at the top here. By the way, it's not optimized for mobile since this is not really a CSS course, but I want to focus on React instead. But now with that, we added this nice navigation bar, and we added it such that we have component-specific styles which are also scoped to this component. Now that we added our styling in our navigation bar, let's work on the pages. Let's maybe start with the all meetups page, and let's output a list of dummy meetups for the moment, before we then make sure that we can add our own meetups. Now for this, I'll go to the all meetups.js file, and the goal in there is to get a list of meetups. Later, we will get it from a server by sending a HTTP request. For the moment, we'll work with some dummy meetups, and I then want to output those meetups. Now for this, I'll first of all add a constant named dummy data, which we'll replace later, which holds an array of dummy meetups. Now here I'll just add a bunch of JavaScript objects which hold the meetup data. Things like the image, the title, the description text, and the address maybe. And for this, you can definitely also use my code attachments. There you'll find some prepared dummy data. You can also prepare your own one. Here I just have two dummy objects, which have basically the same content, just different IDs and different titles, but the same image, the same address, the same description text, because of course it's not about the dummy data, but about what we do with it. Now one word about that image. I got that from Wikipedia. You can of course bring your own images. Here I got this nice looking image here, created by Thomas Wolf and not by me, so just to give him due credits. And you can of course bring your own image, just make sure that you simply get a URL to some image and store that in this image property of your dummy data points. Now we got the dummy data, now the goal is to output that data. So for this here in this div or a section which we could also use, we can add a h1 tag, let's say, and say all meetups. And then below that, we want to output this data, but of course not as code like this, but instead as JSX elements. And for this, we now need to learn how we can render a list of JSX elements dynamically, how we can translate a list of data into a list of JSX elements. Because it is worth noting that in JSX, you can actually render an array of JSX elements like this. So output a dynamic expression with curly braces, then add an array, and in there you could have list items like item 1, and then as a second item, item 2. And if you do that, those are rendered. So arrays are rendered correctly, automatically by React. And that's important to know, because that means that if we can translate this array of objects into an array of JSX elements, we can output it down there. And there is a way for translating an array into an array of different data in JavaScript. On that dummy data array, we can call the built-in map method, which exists in JavaScript. And map allows us to execute a function. here I'm writing an arrow function, on every element in that array, and it will get this element as an input. So in this case, the meetup, let's say, as an input automatically, because this function is called automatically by JavaScript. And we then return the transformed data. And the result of calling map then is a new array full of that transformed data. And here we could say for every meetup object which we're getting, we want to return a list item. And hence we maybe actually wrap this all here with an unordered list. And in that list item, we want to output data about that meetup. For example, to begin with, to output the title. So here I'm dynamically outputting meetup title in this JSX code. So with that, we transform our array of objects into an array of li elements. And if we do that just like this, and we reload, we see this is a first and this is a second meetup. So that does work. Now there is one important note about lists though. If you open the developer tools, you'll see a warning here that each child in a list should have a unique key prop. That is a requirement by React, which it needs to update and render lists efficiently. I dive deeper into that in my React course. For the moment, it's enough to know that we should add the key prop here to the list item and then set this to some unique value per item. And we have a unique value for every list item here, the IDs. The IDs are different for every item. So here we can then set this to meetup.id. And with that, we'll no longer get that warning if we reload. So that is how we can render a list of data, simply by mapping it. And that is how you typically do render lists of data with React. But in the end, you can just render any array of JSX elements, no matter how you derived that array. Now, rendering our list like this is of course not our goal. We want to render a more beautiful, a more good-looking list. And for this, we could structure our code here differently and add more styling. But ultimately, I simply want to create a new component here and add component-specific styling. So that's what we'll do. In the components folder, I'll add another subfolder next to layout, and I'll name it meetups. And this holds all my meetup-specific code. And in there, I'll add a meetup item.js file and a meetup list.js file, because I want to outsource both the list as well as the individual list items into components. Because, as mentioned earlier, it is a good practice to split your components and your application as a whole into small, reusable pieces. Now let's start with the meetup item. In that file, we create our meetup item function, of course, as we did before, and we export that function. And then in here, we return a list item. And then in that list item, I want to have a div in which I render the image and set the source to something and the alt text to something. And then that's a self-closing element. And below that div, I have another div with the content, where I have a h3 tag with the title, an address tag, which is a default HTML tag, where I output the address later, and then a paragraph with the description. And all this hard-coded text will, of course, soon be replaced with dynamic data. And then below that, we can add another div with a button where we say to favorites, so that this adds the item to our favorites later. That's the general structure I want to have here. Now, as mentioned, title, address, and description, and also the data for the image should be dynamic. I don't want to hard code it here. Instead, it should be passed in from outside, from the so-called parent component, so the component where we use this component in its JSX code. And we learned how we can make that happen. We can accept props here and use props. And then, for example, for the image source, we could set this to props.image. expecting an image prop on the meetup item which holds that URL that should be set as a source here. And the same for the alt text, that could be our title. The title can also be used down there so that we output props.title here. And for the address, it's props.address. For the description, it's props.description. And now all of a sudden, this component is reusable and dynamic. Some styling would also be nice, and for that, again attached, you find CSS files here, the meetup item.module CSS and the meetup list.module CSS files, which you can copy in next to these JavaScript files. And then in meetup item.js, we want to import classes from /meetup item.module.css and assign a couple of classes in that JavaScript file. On the list item, for example, we'll add the item class like this. On this div, which is wrapped around the image, we'll add the image class like this. On the div, which is wrapped around the title and description and so on, we'll add the content class. And then down there for the button, I'll add a class of actions, like this. Now that's not all. I also want to work on that meetup list component already. So here we can again create another component, meetup list, and export that as a default. Also accept props here, because I expect to get that list data from outside as well. And I'm expecting this because I'm the one building this app. We could also write the code for fetching meetups in this component, but I instead want to make this component reusable and not care about the data source in here, but instead just expect that I get meetups through some prop, and then it's the component which uses the meetup list component that has to worry about getting the meetups. And I'm setting it up like this because I plan on using the meetup list component in the all meetups component and also in the favorites component later. And there we'll have different data sources, but the same way of displaying the data. And that's what we can make work by adding a separate reusable component. In here, I also already want to import classes from /meetup list.module.css and return an unordered list here, which receives a class name of classes.list, which is one of the, or the only provided CSS class for this component. And inside of the unordered list here, I now want to output my meetup items in the same way as we did it in all meetups, by mapping an array of objects into an array of JSX elements. Just that the JSX elements will now be the list items. And for this here, we again add a dynamic expression with curly braces, and we can expect that on our props here in meetup list, we get, let's say, a meetups prop. The name is up to you because it's your component. This could also be named items, but here I'll go with meetups. And then I map every meetup into another object, into a JSX element to be precise. So therefore, using the arrow function shorthand syntax here, I'll transform every meetup into a meetup item. And for this, you need to add this import. It was automatically added for me here by the IDE. If that does not work for you, just add it manually and import meetup item from the meetup item file. Now we render one meetup item per object in the meetups array, and that now needs to be configured. It needs this key prop, this special prop React expects, one of the very few special props that are built into React and that can be used on any component, including your own components, without you writing any special code for it inside of your components. So you can just add that anywhere. And we set that equal to meetup.id. Then in my own component, I'll actually pass in the ID as well as an ID prop. We will use that later for the favorite feature. I'll pass in the image prop with meetup.image. Let me reformat this to make it a bit more readable. Add the title prop and point at meetup.title. And also add address and description. So meetup.address and description is equal to meetup.description. Now, alternatively, we could have also just passed in a meetup prop or any other name and just passed in the meetup as a whole. Then we would have to destructure it inside of the meetup item component. It's up to you which approach you prefer. Here I'm passing in individual props. With all of that done though, we can go back to all meetups and now use the meetup list component instead of the unordered list. So we go up and we import meetup list from going up one level out of the pages folder into the components folder, into the meetups folder to meetup list, and then just output meetup list like this, and very important, provide the meetups prop, because we're expecting that prop inside of the meetup list component here. So set up the meetups prop here and pass in the dummy data array as a value. With all of that done, if you save all the files, you should see something like this. Now, this is not the final look. We'll continue tweaking this, but it shows that our content is being rendered, and that's not too bad. But now it would be nice to kind of restrict the width which we use on the screen, and it would also be nice if the individual meetups would look like cards with a nice drop shadow, maybe rounded corners, something like that. That's what we're going to add next. Now let's start with that card look. In case it's not clear what I mean that look which we also used earlier for the first demo project, where we simply have a nice white background and a slight drop shadow. And I'd like to have that for every meetup item. Now we can solve this by adding a couple of CSS classes in the meetup item module CSS file, and then changing the look of our list item. That would work. But this card look is so common that we maybe also want to use it in other components of this application. And we will actually use it in other components later. That's why I want to create a separate reusable component, which should act as a wrapper around other components and just give those components some styling, which we then reuse. And for this, in the components folder, I'll add a new subfolder, which I just want to name UI for user interface. The name is up to you, of course. In there, I want to store some general user interface components, which don't belong to a specific feature, but instead are used in different places of the app. And here I'll add a card.js file, and attached you find a card module CSS file, which you can simply add next to this card.js file. And in the card.js file, we'll now create a component as we did it before, simple functional component, and export it, of course. And we'll also import the styling, import classes from /card.module.css. And then in the component function, return a simple div where we set the class name to classes.card. Now, the special thing about this component is that this should now be the first custom component which we can wrap around JSX content. Because the goal is to use this card component such that on a meetup item, inside of this list item, we can use card, and for this you need to add the import. So import card from going up one level, diving into UI, card. And we can wrap card around that JSX content, so that we can use the card component like this. That's the goal. But at the moment, if you save all files, the result is that you don't see anything. And the reason is that at the moment, this card component simply swallows everything we wrap and throws it away, you could say. Because this card component just renders a div, and it doesn't know what it should do with any wrapped content. Now, it's such a common case, though, that you build components that should wrap itself around more JSX content. So you could say that you want to inject JSX content into this component. That React, of course, has a solution for this case. And this solution, again, is related to props. We learned that we can pass props by adding attributes to an element, and that does work. But you can also add a special prop by passing content between the opening and closing tags. And that content is then exposed under that special prop inside of that wrapping component. So here we accept the props parameter again. And then between the div tags, I want to output props.children. Props.children is a special prop. The children prop is a special prop which every component receives by default. And children always holds the content which is passed between the opening and closing component tags. So this JSX content, that is the value stored in that children prop in this case, when we use card in this component like this. And now I'm just outputting the value stored in children between these div tags. And with that, if we reload, we now have this slight card look and we see a drop shadow here. Since we take up too much width, we don't see it perfectly, but we can see it a bit. And if we inspect this in the DevTools, we see that every meetup item here has this div with the card class. The name was transformed because of that CSS Modules feature, but it has that div with a card class wrapped around these other divs, image, content, and actions, inside of the list item. So that wrapping works, and that is another very important technique when it comes to composing user interfaces with React components. And that's why we also cover it here. And we can now use this technique as well for setting up a general layout for this application. Because I'd like to have more white space around the content here. And for this, I'll go to the layout folder and add a layout component in there. Attached, you also find a layout module CSS file, which you can add next to this JavaScript file. And then here in layout.js, we can create a layout component function and export it as a default. And import classes here from /layout.module.css. And then in here, return our layout. And that could be a div with our main navigation, let's say. So from app.js, I'll cut main navigation and remove the import there. And instead in the layout component, I'll add that here. And therefore, of course, also add an import of main navigation from that main navigation JavaScript file, which is next to the layout file. And below that, we could use the regular main HTML element and then use the layout component such that we wrap it around the actual JSX code that should be rendered. So we could say that in app.js, we want to wrap the content selected and rendered by the router with our layout. So here in app.js, we can import layout from, going up, diving into the components folder, layout. And instead of having this useless wrapping div, we could use our own layout component for wrapping here. And now this content here, the actual route content, the page component that is being loaded, should be rendered inside of this main block. And we can again achieve this with props children. We can again accept props here and then output props.children here inside of the main element. And that will then just forward that content, which is between our layout tags, so this content here, into that main element. Now here we should also add a class name of classes.main for styling. And with that, if we save this, now we're utilizing this nice layout component for wrapping all our content. It's technically not required. We could have added the styling in another way too, but it is another nice practice of this children concept, and it removes some extra code from our app component and makes sure that this component can focus on one main thing: rendering the routing configuration. Because your components typically should be focused on one thing. And now we got a leaner app component, and we're again using props children to create this layout component here. Now that we're able to render a couple of meetups there with help of our meetup list and meetup item components, it would of course be good if those meetups would not come from our dummy data source, but from an actual server. And they should actually end up on that server because we created them on the Add New Meetup page. After all, that's the goal of this demo application. That on this add page, we have a nice little form for entering data about a meetup. So entering this kind of data in the end. And then that data should be sent to some server, to some backend, where it's then also stored in a database, so that then it can be fetched and loaded in all meetups. By doing that, meetups that are added here could be shared with all visitors from all over the world, since data is stored in a database on some backend server, not just in our browser. And the data would also be there if we reload the page. If we just store data in memory, any data is lost if we reload the page because the JavaScript application restarts and the previous state is lost. And therefore, the first step is to add this form to this Add New Meetup page, so that then in a second step we can gather the entered data and send it to a server. And for this, we'll work in this new meetup.js file, which is the file that should render this meetup form. So in here, I'll actually also add a section and the h1 title of Add New Meetup. But then below that, I want to output the meetup form, which I will actually create and store in a separate file to, again, keep this new meetup page lean. Now, a good folder would be the meetups folder in the components folder. And therefore, in here, we can add a new file, the new meetup form file, for example, new meetup form.js. Now, attached again, you find a styling file for this file, the new meetup form.module.css, which you can just download and add next to this JavaScript file, so that you have some styles which I prepared for you. And in the new meetup form.js file, we now create another function because we're going to create another component, the new meetup form function and component, which, just as before, is exported here to make it available outside of this file. In the new meetup page component, below this title, we can then already add that new meetup form. Make sure you also add the appropriate import. Now, once you did add it, back in the new meetup form.js file, we can start with outputting the JSX code for the form. Now, I want to actually wrap this form again in this card to give it this card look. And that's why I created that separate card component before, so that we can now reuse that component. So now, besides using the card component in the meetup item component, we can also use it in the new meetup form simply by using it here. And of course, by importing it. You always need to import what you use in a file from the UI folder and the card file. Now, card will then be wrapped around the actual HTML form that we'll create, and then we'll, populate that form with various inputs. Now I did provide that CSS file for the form, so let's also already import classes from /new meetup form.module.css to have these scoped styles. And we can start assigning classes on that form element where you should assign the form class like this. Now inside of this form, you can of course structure this however you want, but to fit the styles which I provided to you, I'll add a div with a class of classes control. And in that div, I want to have a label where we say meetup title, for example, for the first input we're going to add. Now that input is added here and it's of type text. It should be required so that we have that in-browser validation. And I will give it an ID of title and then self-close it. And now connect this label to this input by adding the for attribute. But just as class, for is a keyword in JavaScript. And therefore the actual property name for setting this for value or for setting this attribute here is HTML4. So I add HTML4 as a prop, and that's another exception besides class name where you use an attribute name that deviates from the regular HTML attribute name. It's basically the only other important exception besides class name which you have to memorize. And then we point at title here. And this simply connects this label to this title for screen readers and other assistive technologies. Now we have this input with this label here, and we can now repeat this entire control div multiple times to also render a label for the meetup image, and maybe use an ID of image here and change this to type URL, since the image set here should actually be a URL pointing at an image. If you're interested in uploading files with React, that is not really that much of a React task, but mostly a backend server task. And hence I discuss file uploads in my Node.js course, for example. But to learn how to make file uploads work with React, I also have a resource attached, a tutorial, which you can take a closer look at to learn how to upload files with React. Here, we'll not upload files, we'll just insert the URL of an existing image, which already exists on some server. Then we can replicate this div again for our address here, let's say, and the ID could be address. And here we'll again just have some plain text as an input type. And thereafter, I want to have one more control, which is the actual description of the meetup. And hence, we could use description as an ID. But here, I'll actually not render an input, but instead a text area, which is another default HTML element. It'll still get that ID description here. And it will also still get the required attribute for adding this in-browser validation, and I'll set rows to 5. That's another default attribute which we can add to text areas. Now last but not least, below that I'll add another div with a class name of classes actions, and in there I want to have the button that submits the form. So here we can add a button where we say add meetup, and that button will then submit that form. That's how HTML in the browser works. If you have a button in a form, a button which is not of type button, so if you have a regular button like this, then such a button will submit that form. And we can later listen to that submit event. And this should be actions as a class here. And with that, if you save that file, you should see this form on the screen. Now the form doesn't work yet, but it's there. Now to handle the form submission, we got to do two main things. We have to listen to the form submission, And we then actually have to prevent the browser default, which is that it sends a HTTP request automatically, and hence it would reload the page. We want to prevent this and instead handle the submission with JavaScript, with React. And in addition to that, we of course need to read the entered values. We need to get the actual input the user entered. Now let's start with the form submission. To listen for that submission, we can add the onSubmit prop on the form. Because by default, a submit event will be emitted if you have a button in a form and that button is clicked. And we can then catch this submit event here and run our own logic with help of that onSubmit prop. Now I will add another nested function in the new meetup form component function, let's say the submit handler, which should be triggered when the submit event occurs by connecting function and onSubmit like this. But as I mentioned a couple of seconds ago, the default behavior of the browser would actually be that it sends a request to the server serving this page automatically. And we don't want that. We don't want that browser default. Instead, we want to prevent that default and run our own JavaScript logic. That might then still involve that we send the HTTP request later, but we want to send that request behind the scenes without reloading the page, which is what would happen if the browser does its default thing. Now, thankfully, preventing that browser default is simple. We will get an event object automatically here, because all those built-in events like onClick, onSubmit, and all the other events to which we can listen, for all those events, React will automatically pass an event argument into the function that is executed for those events. This argument, which we can accept here as a parameter. And this event object will have a prevent default method, which we can call to prevent the browser default. That's actually not even React specific. This event object and this method, that is vanilla JavaScript, which is fully supported by React. So that will prevent that browser default and will allow us to fully handle the submission with just JavaScript and React. So that's step one. Now we need to find a way of reading those entered values. For reading the entered values, we got two main ways of handling this. We can use state again and add the onChange event listener to all those inputs, which will in the end trigger a function for every keystroke, and then we can extract that value the user entered from the event object which will receive for that event and update our state for that given input with the entered value. That would allow us to keep track of what the user entered with every keystroke. But here I'm actually only interested in the user input once, when the form is submitted. And for this we can use another concept built into React, the concept of refs. Now ref stands for reference, and React simply allows us to set up references to DOM elements, so we can get direct access to DOM elements. To set up such a reference, such a connection, we first of all have to import the useRef hook from React. So just like useState, that's another built-in special function offered by React, which we can execute in our functional components. And we can execute useRef here. And with that, we create a ref object, a reference object. We can store this in a constant, and we could name it title input ref, because my first ref here should be for this title input. Now to connect this created object to this input, we add another special prop to this HTML element. Another special prop besides the key prop, which is built into React and supported on all elements out of the box. And that's the ref prop. We add the ref prop to this input, and as a value, we point at this title input ref. This will establish a connection and will give us access to this input element through this ref object. So here in this submit handler, we can then get the entered title, so the concrete value the user entered, by using that title input ref, and then there actually .current, all those ref objects created with the useRef work such that they have a current property, which then holds the actual connected value. And therefore it's .current, which then holds this input element object, the JavaScript representation of that input element. And all those input elements have a value property. That's just how JavaScript works. The JavaScript object representing an input element has a value property, and that value property holds the currently entered value of that input. So that's how we can extract what the user entered. We could also change it. We could set value to some new value, but we shouldn't really do that. If you want to change what's output on the screen, use state for that instead. But for reading input, for reading values, refs can be a very useful tool. And here we are reading what the user entered. Now we can repeat that for the other inputs, simply by creating more refs. You can have more than one ref per component. So here I also create the image input ref like this, and I'll already copy that a couple of times, and also create the address input ref and the description input ref. And then we connect those refs with the ref property here on the image. We connect this to image input ref. For the address, we connect this to address input ref. And on the text area, which is there to enter a description, we connect the description input ref. Now with that, we can extract all those entered values in the submit handler. So we get the entered image with image input ref .current.value. We got the entered address with the address input ref .current.value. And we got the entered description by using the description input ref current.value. And that then allows us to create a new object, let's say, the meetup data object, which then has a couple of keys, like let's say title, and stores those entered values as values. So the entered title for the title key. For the image key, I store the entered image. For the address key, let's say, we store the entered address. And for the description key, we store the entered description. And now for the moment, I'll simply log that meetup data with console log. Soon we will send it to a server instead. But for the moment, let's just see if that works. And hence, if I now go back and open up the DevTools here and reload, we can enter something here like a test, and then here's some URL. Let me just grab that dummy image URL from my dummy meetup data in the all meetups.js file and insert that here without quotes. Some test address 12345 test city, and then this is a test. And if we now click add meetup, we see this object here on the right, which is the object with all the entered data. So submitting the form and handling the submission, preventing the browser default, and gathering all the user input, all of that works now. And that is how we can handle forms with React. Now, of course, the goal is not to just log the data here, though. Instead, we now want to send it to a server, which then stores it in a database. So we want to send our meetup data to a server. This course is about React, about the front end. And therefore here, we will not write any server-side code or create our own backend. I do have separate tutorials on that. Got my Node.js course where you learn all about that backend technology, including how to connect to databases, how to create REST APIs, and much more. And I got a free tutorial as well where we also build a REST API in detail with Node.js step by step. Because with React, or with single-page applications in general, you typically need a backend API to which you can send your requests. So a backend which does not send back HTML, but which instead expects data in a certain format, typically JSON format, and which then returns data in that JSON format, and which simply exposes a couple of URLs to which you can send requests, and depending on which URL you're sending a request to, different things will happen. That's the kind of backend you typically connect to with React. Now, you don't connect a front-end application like React or Angular to a database itself. I got a full tutorial on that where I explain why we don't want to do that. You'll also find a link to that attached. You don't connect directly to a database with React and so on because of security. All the code you write here in your React application in the end is exposed to the visitors of your page. Through the DevTools, if I look at sources, if I dig into that, I can read the JavaScript code that makes up your application. It might look a bit different than when we wrote it, but all the code is in there. And database credentials would be in there as well. That's why instead we need a backend API, a backend server, to which we can send requests, and then it's that server which on the server connects to a database and stores data in a database. And hence that's what we're going to do here. Now, as I mentioned though, we're not going to write our own API, instead we're going to use Firebase as a dummy backend here. Firebase is a service offered by Google. It is actually made up of a bunch of different services, but it is a service which you can get started with for free. You just need a Google account. And it is a service which contains a database and an API to which we can send requests, which will then ensure that data is saved in that database. And for this, I'll therefore log in here with my Google account. And then once logged in, we can create a new project here. You can enter any project name you want here. I'll just name it React getting-started. Click continue. You can disable Google Analytics, we don't need that, and create that project. Now, as I said, Firebase is a service which has a bunch of built-in capabilities. Here, we'll just use it in a very basic way to have this dummy backend to talk to. And I'm using this backend, this service, because that allows me to show you how you send requests to a backend, and you would then do that in the same way no matter which backend you use in the end. That's why that's a good service to use. Now here, we want to use the real-time database, which is one of the features Firebase offers, and then there click on Create Database. Now you can leave the default region and make sure that you start in test mode, not in locked mode. Otherwise, you'll not be able to send requests. Now this sets up a database and, very important, also immediately an API to which we can send requests. We can use this URL here to send requests to, and behind the scenes on Firebase servers, those requests will then be parsed, and depending on which kind of request we send, data attached to the request will be extracted and stored in the database automatically. And therefore it can look like if we're directly sending requests to a database, but we're actually sending requests to that Firebase API, which then behind the scenes stores them in a database. And therefore, that's the URL to which we now want to send a request when we submit that form. Now it's up to us where we want to send that request. If that's in the Meetup form component, or maybe in the new Meetup page component. And since the new Meetup form component is already quite a big file, I will actually not add the HTTP code here, but instead in the new Meetup component code. So in the new Meetup form component, I just want to forward that Meetup data to the parent component, to the component where we use this component. And we learned that we can do that with props. We can accept props here in the new meetup form. And then instead of console logging the meetup data, we can expect that on props, we have some prop which actually gets a function as a value. A function which we can then call from inside here. Let's say the onAddMeetup prop. The name is up to you because that's our component. I expect that the value on this prop is a function, so we can execute it here, and I'll pass meetup data as an argument. Now, of course, for this to work, we now need to make sure that in the new meetup component, we now add this onAddMeetup prop, and that the value we pass in here is a function. So here I'll add a new function, the addMeetupHandler function, which expects to get some meetup data, because I'm passing that argument here when I call the function from inside the new meetup form component. So I expect that data here, and I then pass this addMeetupHandler function as a value to onAddMeetup, like this, without parentheses, just pointing at it. Now in this function, that's where I want to send a HTTP request. Now for sending a HTTP request, we can use the fetch function. That's a default JavaScript function built into JavaScript. It has nothing to do with React. It's a standard JavaScript function supported in modern browsers. And it is a function that allows us to send HTTP requests. We could also use third-party packages like Axios, which is also a popular library for sending HTTP requests, but I don't want to install an extra library here, so I'll stick to fetch. Now fetch wants an argument, and the first argument should be a string. It should be the URL to which we want to send a request. And here that's that URL which we get from the Firebase real-time database console. Now this Firebase real-time database service works such that this URL can be manipulated. We can add segments after this domain, and then these segments will be translated into folders, you could say, in your database, into tables, you could say. So we could send a request to this URL /meetups, and that would add a meetups table, a meetups collection to that database here. And hence I'll do that here. Now, one special thing about this Firebase API is that you need to add .json at the end here. That's not React specific, that's just something Firebase requires. And with that, that is the URL to which we're sending our request. But here, I actually want to store data on Firebase servers. And to signal to Firebase and to this API that we want to store data, we actually must send a post request. And by default, fetch sends a get request. And that will always depend on the API you're working with, but most APIs are built such that storing data requires post requests. Now, to send a post instead of a get request, we add a second argument to fetch here, and that second argument is an object which allows us to configure this fetch function call and this HTTP request, therefore. And here in this object, we can, for example, set a method property to define the HTTP method that will be used. And here we can set this to post instead of get, which would be the default. So here we use post instead. Now, when we send a post request, we should also add the data to the request, the data which we want to store. And we do that through the body field, which we add to this second argument, to this configuration object. Now, body wants the data we want to append, and that data should typically be in JSON format, which is a very popular, the most popular, I would argue, data format for transmitting data with HTTP requests. And in JavaScript, we can easily create JSON by using the built-in JSON object and calling the stringify method. And to stringify, we can pass default JavaScript objects or arrays or values in general, and they will be converted to JSON. So here we could pass our meetup data object, which we're getting as a parameter, as an argument to the stringify method. Now, last but not least, we can add some extra headers if we want to. And for example, add the content type header and set it to application/JSON to add this extra metadata to the outgoing request and make it crystal clear that this request carries JSON data. Some APIs also require this. And with that, we're sending such a post request. We can do more with fetch. We can listen to the success and error cases, and we do that in the full React course, which I offer. But for the moment here, this is actually enough because this will already send a post request with our data to Firebase. And hence now here, if we save this and I click on Add Meetup Now with data entered, we don't see any feedback here. We'll work on that in a second. But if we go to Firebase, we see that there's a new Meetups node. And in that node, we got this cryptic ID here, which is actually auto-generated by Firebase. And if we expand this, we see our submitted data. So storing that data on Firebase servers works. Now let's work on the feedback which we provide to the user here when we add a meetup. To give the user some feedback that it worked, we probably want to navigate away from this page once the request was sent. And previously, we navigated through these links, which we added to the navigation here. Now we want to trigger navigation programmatically. So once we're done with a certain task, in this case, once we're done with sending a HTTP request. Thankfully, implementing this is also simple with React Router. We can simply import something from React Router DOM, and that something is another hook, the use history hook. So React has some built-in hooks. Other third-party packages also can provide their own hooks. You can also build your own hooks, but we're not going to do that here in this course. But here we now got this use history hook, and we can call this hook here in the new meetup page component function. Now this gives us a history object, and that's simply an object which exposes certain methods to us that allow us to manipulate the browser history, to navigate away, for example. Now here, let's say we want to navigate away after the data was submitted. To achieve this, we can use the fact that fetch returns a promise, which resolves as soon as this is done, and hence we can add a then block here and define a function which will execute when the promise completed, and it's then in this function where we want to execute history and then some method that allows us to navigate away. For example, the push method to push a new page onto the stack of pages. In that case, we could then later use the back button to go back to the previous page. And since that doesn't make too much sense after submitting a form, I'll instead use the replace method. That will navigate us away, but it won't allow us to use the back button to go back to the previous page. And here I'll just want to navigate to the starting page with /nothing. So in the end, we pass to replace what we also passed to link to the to prop. Here we set up the destination, the target destination of a link. With the replace and push methods on history, we also pass the target path as an argument now. Now instead of then, we could also use async await here, by the way, if you wanted to. Now with that, we're navigating away once the request succeeded, and therefore let's now give this a try. Let's save this and enter some new data. I'll repeat using that image here, that dummy image URL, some other address and some other description here. And then I'll click on Add Meetup, and you see that I'm now navigated away. And going back won't get me back to that forum. And on Firebase, we of course now also have that second meetup added here. And that's how we can navigate programmatically and leave that Add New Meetup page once we're done. Now let's make sure that the meetups we show on the All Meetups page are actually the meetups stored on Firebase, because at the moment that's not happening. So let's now make sure that we load the data we store here on Firebase into our application, into our website here, when we load this starting page. Because at the moment here in the All Meetups page, we're still using this dummy data, and that's of course not the goal. Now to load data from our backend, from our API, we need to send a HTTP request again, just as we send one when we store data. So in the All Meetups.js file, in the All Meetups page component, we want to send a request. The question is, when do we want to send the request? And the answer is whenever this component is being rendered. So whenever we visit this page. So what you could do, what could be your first idea, is that directly in this component function, before we return the JSX code, we can fetch our data. We can use the same URL as we used for storing the data, since we want to fetch data from the same API and node. And hence we can use the same URL here. Now we don't need to configure this request here with this second argument, because the default is that a GET request is sent, and that's exactly the kind of request we need here. We want to send a request to get our data. So we can call fetch just like this, and this will fetch this data. But now, unlike as with the post request, when we send data, now when we get data, we are definitely also interested in the response. Now, since fetch returns a promise, we can of course use the then method here and chain this after then to handle this response. So we pass an anonymous function to then, and here we'll get the response object as an argument automatically, because that's how the fetch function works. It returns a promise which resolves to the actual response at some point in time. Now from that response, we want to read the body, we want to read the data, and we can do that with the JSON method. That's a method which exists on this response object out of the box, and this will give us access to that data automatically converted from JSON to a plain JavaScript object. But here's a gotcha. JSON will actually return a promise as well, so we also need to wait for this promise to resolve. So I actually will return response JSON here and add another then block where we then get the actual data. And it's now in this second then block where we can work on that data. We could also add error handling, and we do that in the complete guide course, but for the moment here, let's focus on just getting that data and using that data. So here in this then block, we get the data. What do we want to do with this data now? In the end, we want to extract an array of meetups from that response data and pass that as a value to the meetups prop on the meetup list. Now we'll have a problem here though. Since fetch returns a promise, and we're in this promise chain, JavaScript does not wait for this promise to complete before we return here. Now you could think that we can use async await here to wait until this is done, but that would be bad, because that would mean that the entire component function now returns a promise, because that's what the async keyword does. It converts this function to a function that returns a promise, and that then no longer qualifies as a valid React component, because React component functions must be synchronous and must not return a promise, but instead they have to directly return JSX. So we can't use async await here. Hence, we can't defer returning a value until we have a response. Instead, what we need to do is we need to return some temporary JSX code, for example, a loading spinner or something like this. And then once we have the response, we want to update the returned JSX code. And how do we change what's visible on the screen? With state. That's what we learned earlier already. We can use state to change what's displayed on the screen when certain conditions change. Before, we did that when the user clicked a button and we wanted to show an overlay. Now I want to change the state once we have response data. So for that here, in this all meetups.js file, we can import use state from React, so this use state hook, and then register some state here with use state. And here we could, for example, set up some loading state. So name the constant loading or is loading and add a set is loading state updating function, because you learned that use state always returns an array with exactly 2 elements, where the first element is the current state snapshot and the second element is a function for updating the state. And when we have data, we want to set is loading to false again because we're not loading anymore. But actually the initial state here should be true, not false. So we start in a loading state and then we set it to false once we have the data. And then with that, we could check if we are loading here in the component function before we return. I check if we are loading. And if we are, then I want to return another piece of JSX code where I, for example, have a section with a paragraph where I say loading, something like this. So that's my fallback content, which I want to return in this component whilst we are loading. And we only return the actual meetup list if we're done loading, so if we have the data. But speaking of that, there we're missing an important point. At the moment we're just managing the loading state, we're not doing anything with the actual data that is being fetched. For this, we could add another state to this component. And that is something we haven't done before, but you can have multiple pieces of state in one and the same component, as many as you need. There is no restriction here. And this could be our array of meetups. And it could be an empty array initially, but eventually we want to override this once we fetched our data from the backend, from the API. So here I'll name this loaded meetups and set loaded meetups. And here we want to set loaded meetups to data, let's say. That will not be the final step, but for the moment we can do it like this. And then we could pass the loaded meetups instead of the dummy data to our meetups prop down there. And that means that now we can also get rid of that dummy data. So I will delete this dummy data constant. Now don't save this file yet though, because this code will cause an infinite loop. What's the problem here? The problem is related to state and our HTTP request. You might recall that I mentioned when I introduced state that when we call this state updating function, we tell React that it should re-execute this component function and re-evaluate it, and then return the updated JSX code. That's the idea of state. It allows us to re-evaluate a component and possibly render different content on the screen whenever state changes. The problem here is that we change state once we made our request. We changed the loading and the loaded meetup state. Then this component function will execute again. What does this mean? It means that this fetch function will run again and we send another request. And once that's done, we update the state again, which means the component function executes again and fetch is called again, and so on and so on. So we have an infinite loop, and that breaks our application and spams our API with requests, and it's not something we want. How can we prevent this? So how can we work around that problem? This is such a common problem and such a common scenario that React has a solution for it. There is another hook which we can import from React, and that's the useEffect hook. useEffect is a hook that allows you to run some code under certain conditions. At the moment, this code for sending the request runs always when the component function runs. With useEffect, we'll be able to restrict this and define conditions when this code should run, so that it does not always run. For this, we call useEffect. We execute this useEffect function directly in our component function. And then useEffect wants two arguments. The first argument is a function. And here I will pass in an anonymous arrow function. The second argument is an array of dependencies. And I'll come back to this array in a second. Now, inside of this first argument, inside of this function, we can execute our fetch code here. So I'll cut this and add this into this effect function. Now, this effect function, this first argument here, which we pass to useEffect, will be executed by React on our behalf, but only under certain circumstances, not always when this component reruns. I'll come back to those circumstances in a second. Now, with that, we make sure that our fetch request here, our fetch function, is only executed when React executes this function. Now, when does React execute this function though? If we would not specify this second argument, this array, if we would omit this, then this effect function would execute whenever this component function executes. So then we don't gain anything. That's why you need this second argument. You technically don't need it, it's not required, but if you omit it, there is no difference compared to just running the code in the component function. With this second argument added though, React will check the values you add to this array and compare them to their equivalents when this effect function was executed the last time. Now, if that's an empty array, there are no dependencies. And then React will only execute this function when this component function rendered and executed for the first time. And for subsequent executions of this component function, this effect function will not run because we have no dependencies. So the values of the dependencies are always the same because there are no values. Now, if you would add a dependency here, like let's say the isLoading snapshot, which you should not, but if we would have this as a dependency here, then this function would execute whenever the value of isLoading changed. So if that value does not change, if that always stays the same, then this would also not execute again. But if isLoading was false, and then you somewhere update its state to true, then the value of isLoading would have changed, and then this effect function would execute again. Now, in reality, you don't need to think which values should trigger your effect function. Instead, there is a simple rule. In your dependencies array, you should add all external values your effect function relies on. So in this case, there are no external values. The fetch function is a built-in browser function. It's not one of our component props or state. And other than that, we don't use any state or prop values in this effect function that would belong to our component. If we would extract some data from props here though, if we would, for example, get the URL from props URL, let's say, then props would be a dependency and we should add props here. But that's not the case here, but that is how it would work then. Set isLoading and set loaded meetups actually technically would be external dependencies because these are constants defined outside of this effect function, but these state updating functions are an exception. You can add them here, and that would not be incorrect that these functions are external dependencies, and whenever these functions change, this effect should run again, because then these functions might do different things than they did the last time they were executed. But React actually guarantees that these state updating functions will never change. They will always do exactly the same thing. And therefore it's allowed to omit these functions here. And hence, in our scenario here, we use useEffect like this, with an empty dependencies array, since we have no external dependencies here, and therefore this code will only run once when this component is rendered for the first time. Now I dive way deeper into useEffect with more examples and also more features of this hook in my course, but what you learned here is the core foundation of useEffect, which you have to understand. That you can use it for running such side effects, as they are called, code which does not directly influence what's showing up on the screen, and that for such side effects, useEffect is the proper solution for controlling when this code should run. Now with that, we actually should also set isLoading to true here at the beginning of this effect function, so that whenever this effect would run again, we set this to true again. It doesn't run again here, but still, that is cleaner, I would argue. And then we send this request, and ultimately, we update our loading state again, and we set our loaded meetups to the data we fetched here. And now with that, it still won't work, because setting the data like this is incorrect, as it turns out, but we don't have an infinite loop. And I hope I could make it clear why that's the case. If we now save everything, our app crashes, because as I said, we're setting the wrong data, but we don't have an infinite loop. So now what's wrong with that data though? The problem with our data is that when we fetch meetups from Firebase, we actually don't get an array. Instead, we get an object where these cryptic auto-generated IDs act as properties. So when we send a GET request to our Firebase API, we get back an object with two properties in this case, and these here are our property names, and then nested inside of these properties, we got nested objects with the actual meetup data. Now, here in our component though, we expect an array, because in meetup list, we map on our data, and that only exists on an array, not on our object. Hence, we need to transform the data here in all meetups before we set our state. Once we fetched the data, so in this second then block here, we want to transform the data. And we can do this for creating a helper array here, meetups like this, and then a for in loop where we go through all our keys in data, so all the keys in this data object we fetched from Firebase. And these keys will be these random IDs here, these unique IDs, that will be our keys. And then we create a new meetup here for every key through which we loop. So for every meetup that's stored on Firebase. And we can set the ID equal to key, since that is that auto-generated ID. And then just distribute data key into this object. So we access the nested object for the given key. So we access the nested object here. And then we just use the spread operator, which is a default JavaScript operator, to copy all the key value pairs of this nested object into this object. And that constructs a meetup object as we need it. And then we just need to push that onto our helper array here. And then it's this helper meetups array, which we want to set as our loaded meetups data. And now if we do that, if we transform the data like this, if we save this, and reload. We see loading briefly, but then we see all our meetups. And that's how we can fetch data, in this case from Firebase, but in general with useEffect, fetching data with a loading and a data state without causing an infinite loop. Now that we can add data to Firebase so that we can store data on a server and that we can fetch data whenever we visit all meetups, now with that we got the core functionality built in. The last feature which I want to add here is this favorites feature. This button here should be clickable, and when we click it, this meetup should be added to our favorites. Then on the My Favorites page, I want to see a list of all my favorites. And of course, as soon as an item is a favorite, I want to be able to unfavorite it. And then I also want to show a little badge here in the navigation next to My Favorites, where we see the current count of favorites. That's the last feature I want to add. And for this, we'll need to manage some state which affects more than one component. Because our list of favorites is some state that should cause the UI to update. Because we, for example, will have that badge here, which shows the current number of favorites. And of course, this button should change once an item is a favorite. So we'll have different parts of this application that will be affected by our state. And because that's the case, because we'll have a state that affects more than one component, we will need a mechanism of managing that state globally and distributing that state to different components. Because just using useState inside of a single component doesn't necessarily do the trick anymore, because that only affects one component. Now, one thing we could do is we could lift the state up. That means that we could, for example, manage our favorites state in app.js, and then we pass it into all the components that are interested as props. So to the layout component, which has access to the main navigation component, which is where I want to show this badge in the end, to that component, we could pass the number of favorites if we manage the favorites state in the app component. And then to the favorites page component, we could pass the array of favorite meetups. So we could manage the state here in the app component and then just distribute it through props. That would work, but it has a couple of downsides. One problem would be that if we have a bigger application with different states that affect different components, we have to manage more and more state in this app component, and hence this app component becomes bigger and bigger. And that's maybe not ideal. Another problem is that if we pass state down through props, that we can end up with very long prop chains. We pass the number of favorites to the layout component, and from there we pass it into main navigation. So we already pass props to layout just so that this component can then pass that data on to another component. Whilst that is not horrible, it's also not necessarily great, and it can also make our code a bit harder to maintain. And because we have issues like this, there are state management solutions for managing application-wide state in a more convenient way. One very popular state management package is Redux. I cover it in my course, but for many scenarios, we don't even need Redux, because React also has a built-in state management solution for application-wide state. And that's a feature called context. Now for this, to add this context feature, I'll add a new folder in the source folder, and I'll name it store. The folder name is up to you, but store is a common convention since we will set up the state store for this application. Inside of store, I'll add a favorites-context.js file. And in this file, I'll now create such a context. For this, in this file, we first of all import create context from React. So that's a function exposed by the React library. And we can then call create context. And this does what the name implies. It creates a context. We don't know yet what exactly such a context is, but hey, we are creating one at least. Now, context in the end is a JavaScript object. And we can store this in a constant, and I'll name it favorites context. I start with a capital F because this object, which is created by context, actually will contain a React component. And when you build your own React components, the convention which you should follow is that you start with a capital character for your component names. So that's why I store my context in a favorites context constant here. Now, create context also takes an argument, and that argument is the initial value for that context. So the initial value for this application or component-wide state. And that can be any value of your choice. It could, for example, be an object. Let's say an object where we have a favorites key, which is an empty array initially, because we have no favorites at the beginning. And maybe a total favorites key, which is 0 initially, which is the total number of favorites. That could be our context. But like this, it's not too useful. We also need ways of changing these values, of adding and removing favorites. And that's why I will also add a component in this file. So a component function, which I'll name favorites context provider. This component will be a regular React component, but it will have the job of providing this context to all the components that are interested in listening to the values. So all the components that need values from the context. And this component here, the favorites context provider component, will also be responsible for updating the context values. Now for this, what we'll do here is we'll return favorites context, so this constant which we created here, dot provider. That's a component this context object has built in. And this provider component needs to be wrapped around all the components that are interested in interacting with that context. Now, this favorites context provider component, which we are building here, itself should be wrapped around other components later. I plan on using it in index.js to wrap it around my entire app so that all the components in the app have access to the context. And therefore, what we can do here is we can accept props and simply wrap this provider component, which we get from this context object, around props children. That means that we can now wrap our component here around any other components, and those components will be wrapped by context automatically. I hope this makes sense. Now, why am I doing it like this? Because now in this favorites context provider component, which we're building here, we can manage our context data. We can manage that with state, because this component, which we are working on here, is still a regular React component. So when we manage state in there, when we change that state, that component here will still execute again and will be re-evaluated. And that means that if we change our context value in this component and we pass this context value to the provider, all components that are listening to our context will be updated and will get that latest updated data. And in case it's not 100% clear yet, we'll get there step by step because we're now going to add the logic for this. In favorites context provider, I'll create a context object and I'll pass this context object as a value to favorites context dot provider. This component, which is exposed by this favorites context object, wants a value prop where we pass the current context value. We set the initial values here when we create the context, but we can then update those values and pass the latest values with help of that value prop. And whenever that value changes, all components that are listening to our context will be updated in the end. That's how this works. So now we just need to derive this context object and its values dynamically. And that's where useState comes into play now. We can manage some state here in this favorites context provider, and we can manage an array of favorited meetups here. So here we have the user favorites, let's say, and a function for setting those user favorites. Now here, this context object, which we construct, which holds the latest values that should be exposed to our components, that object now has a favorites key because we define that here in the initial context value as well. And we set our current user favorites array, this state snapshot, as a value. So when the state changes, this value will change and we'll have a new context object, and we'll pass this new updated context object to all the components that are wrapped by this provider in the end. And I'll also set total favorites here, and that is simply user favorites.length. Like this. Now we just need a way of changing our state here. And of course we can do this with functions. We can add a function that's called the add favorite handler, for example, and a function that we could call remove favorite handler. And I will also add a helper function, which I'll name item is favorite handler. That's a function which will later help us determine whether a given item is a favorite or not. Now in the add favorite handler item, I expect to get my favorite meetup as a parameter. And then in there, I want to set my user favorites to the old array plus this new item. Now for this, we could use user favorites dot concat and add the favorite meetup. Concat is like push, but returns a new array, and it's then this new array with that added meetup, which we set as our new state. But there is a gotcha. We should not do it like this, even though it typically will work. When working with useState, it is worth knowing that React actually does not process state updates instantly, but it schedules them behind the scenes. And it still then processes them very quickly, but not instantly necessarily. Now, because of that, when you update your state, and your state update depends on the latest state snapshot, there is a scenario where the state snapshot does not really reflect the latest state because the last state update wasn't processed yet. And because that is the case, there is an alternative form of calling this state updating function if you depend on that last state snapshot. Instead of passing the new value as I did it a second ago, you should pass a function to the state updating function. And that function will be executed for you by React. That function will then automatically receive the previous state snapshot, so the previous user favorites here, and you should return the updated state here. So in this case, previous user favorites, where we then concat the favorite meetup we get as a parameter. This will guarantee that we always get the latest state snapshot here, because React will execute these functions, which we pass to the state updating functions, in the correct order. So now we have a guarantee that we definitely work on the latest state snapshot here. And that's therefore the better way of updating your state if you depend on a previous version of that state. And that's now how we could add a favorite item. Now in remove favorite handler, we probably can expect a meetup ID which identifies the meetup that should be removed. And then we can update user favorites again with this state updating function, where we get the previous user favorites and return a new state snapshot, because here again we rely on that previous state. And here we then want to return previous user favorites, filter, because filter returns a new array where we can filter out items. And I want to filter out the item where the meetup ID matches this ID we're getting as a parameter. Filter is a built-in method which takes a function as an argument, which executes for every item in this array, and we get that item as a parameter then. And then we have to return true if we want to keep that item, or false if we want to get rid of it in that new array which is returned. And here I want to return true if meetup ID is not equal to the meetup ID I get as a parameter. So if it is equal, we return false here because of this check. And that means we drop the item where the ID is equal. And that means that the returned array will be missing the item which has this meetup ID, which is exactly what we need here since we want to remove that item. And in item is favorite handler, I just want to return a response here, return a value, and I want to check whether, let's say, an item with a given ID is part of our favorites. And for this, we don't need to update any state. It's just a helper function where I return user favorites sum, which is another built-in method which exists in vanilla JavaScript. And sum also wants a function as an argument, which executes for every item in this array. And this function should return true or false. And if at least one of the items in the array returns true or false with that function, sum overall will return true or false. And that allows us to find out if some item in this array matches our condition here. And the condition is that some meetup ID is equal to the meetup ID we get as a parameter. So we return true if we have a meetup with that ID in our user favorites. Now we get these three functions for changing our context. But at the moment, these functions are never called anywhere. They should instead be called from inside some of our other components and pages. So actually what we want to do here is we don't just want to manage values, which are then accessible by different components, but also functions that will change those values that are accessible from different components. And hence we can expose pointers at these functions to our different components as well. So in our context here, we don't just have the values for our favorites, but we also can add functions there. We can add an add favorite key, for example, which stores a pointer at the add favorite handler as a value. So we don't execute the function here, we point at it. And that exposes this function defined in this component to all components in this application that are interested. And you will see how to use this context in other components in just a second. And we can therefore also add remove favorite here and point at the remove favorite handler and add the item is Now, besides practicing, which is a super important next step, I can also only encourage you to explore the React ecosystem. Because in this course, I gave you a great foundation, and we had a look at a couple of key third-party libraries which you also need in a lot of React projects.